Check. 2, 2, boom. Okay.
Good morning, ladies and gentlemen. Welcome to day 2 of Collision. Please make your way to centre stage where this morning's content is about to begin. Thank you. Please take your seats. All Please take your seats. AutoTech will begin in 5 minutes. Please take your seats. AutoTech will begin in 5 minutes. Please welcome to the stage from Discovery Communications, Adam Zuckerman.
Good morning, everybody. Welcome to AutoTech TalkRobot, right? Not bad. Everybody's awake, had fun last night, got to bed 9 o'clock, good breakfast, walk in the morning. Well, the good news is that pretty soon you're not going to have to set your alarm anymore. Your computers, your phones, your devices, they're naturally going to help you wake up. You're going to wake up and go, wait a minute, what do I need to do today? And just waking up and walking over to your mirror, you're going to see your schedule. You're going to see the calendar that you have. You're going to see the weather outside, video, news, things that are relevant for you. And the reason why are the companies that we're going to hear from today are the ones that are building the technologies that are going to make our lives easier. Now, they're working in fields of artificial intelligence, AI, in virtual reality, in augmented reality, in autonomous vehicles. And using their technologies, using their innovations, our lives and society, not only in New Orleans, not only around the country, but around the world, is going to change. Now, there's so much excitement in automation about how the connectivity that's coming to our lives is going to bring. And the question then becomes, is how close are we really to the point where these devices are making our lives easier versus taking away jobs versus changing how people interact with each other? We're going to be discussing this and witnessing some great new products, even product launches today. We're going to talk with companies like Volvo, like HP, like Amazon. And there's a lot to cover. So for that reason, let's stop hearing from me, and we'll bring on the first panel. From AI assistance to e-commerce to financial trading, where is AI filling the gaps and solving problems? To weigh in, we have the CEO of SoundHound, which is a music company that turned to AI to increase their product. We're talking to XAI, which is an automated creator of personal assistants. You may have heard of Amy, you may have heard of Andrew. And Sentient Technologies, which is the most well-funded AI technology company in the world. Please welcome in a talk with Binary Capital's Jonathan Teow, Kevion Mohair, Dennis Mortensen, and Anthony Blundau. Thank you. Or Antoine, rather.
All right. Morning, everyone. How's everybody feeling? I know it's early morning, but hopefully you guys had a good time last night.
This is right.
Frenchman. Did you guys go out?
Of course.
Oh no, Dennis just flew in this morning because he's got an amazing personal assistant that keeps him on schedule, right?
Keeps me sharp, up and early, 3:30 a.m.
There you go. So today we're going to talk about AI, the state of the art, the interaction models that AI has with humans and machines, and also different approaches to it. So I want to keep it light, want to keep it more of a conversation. I'm going to start out basically asking each of the panelists to give a little bit of background on them and their company, and then I'll dive straight into questions, and hopefully we'll get a nice interactive discussion going, because there's been obviously different approaches, and I think we have some philosophically opposing viewpoints. Hopefully they'll come up through this conversation. All right, so Kevon, do you want to get started?
Sure. Hi, everyone. My name is Keyvan Mohajer. I'm one of the co-founders and CEO of SoundHound Inc., which is a company I started in a dorm room at Stanford University more than 10 years ago. We specialize in voice-enabled AI, or artificial intelligence. We have close to 200 people in 5 offices in 3 countries. And we have 3 products, a developer platform called Houndify, which allows anyone to add voice AI to their product, whether it's hardware or software. And then we have 2 consumer products. One of them is in the music space called SoundHound. The other one is a mobile voice search and assistant app called Hound. All 3 products are live. We have over 310 million users globally and more than 30,000 partners on the platform.
Great, 30,000 partners. That's good.
30,000.
We'll double click on that. Dennis.
Hey, my name is Dennis. I'm the CEO and founder of X.AI. Me and my 150 propeller head friends have spent the last 3 years trying to create these two intelligent agents, Amy and Andrew, that can do this one particular task, that of helping you set up a meeting. So no more, no less, just making sure if you shoot me an email and say, hey Dennis, I'm in Manhattan come first week of July, do you got time to meet up? I can do something as simple as replying and CCing in Amy and say, hey, you know what? I'm up for that. Amy can find a time at the office on 200 Broadway for half an hour. See you soon. And then it's her job to understand the request, remove me from the conversation, and have this very human-like negotiation with you back and forth, move it towards conclusion, and once concluded, send you an invite. Which sounds simple, but I kid you not, 3 years later, we just launched our business edition on the 28th of February. That's a lot of time in the basement, in the dark, alone.
Thank you, Dennis. Antoine actually, his team was the original team that was behind Siri. And just to give you some context, so of the three here, we have two of the most well-funded startups in the AI space, and the third will be coming up soon. But Antoine, you want to give a quick background?
Yeah, thanks, John. So at Sentient, we take the state of the art in AI, and we scale it to the hilt. And by scaling it, I mean massive scale. So we are running our AI on about 2 million CPUs and 5,000 GPUs. That's 9 petaflops of horsepower. It's a lot of compute. And we use it to solve, because of that amount of compute, we use it to solve some of the world's most complex problems. And that means trading. So we do have a hedge fund which we run and trade every day. We apply it also to e-commerce as well as digital marketing. And then on the research side, we work with MIT and Oxford on healthcare and agriculture problems as well.
Awesome. So before we dive into the discussion, I wanted to just go through each of you guys' motivations for why you're building what you're building. You know, there's of course the research side, and then there's also the utility side of the AI approach that you have. So maybe give really quickly 30 seconds or so on why this problem that you're solving or why this company you're building is important to you philosophically.
Sure. So let me rewind 17 years ago. When I just started my PhD at Stanford, I made two conclusions. One, I decided that voice-enabled AI will happen, so we will talk to everything and they will talk back to us. And my second conclusion was that it will happen within my lifetime, and that was important because I know there are other things that will happen eventually, but maybe not within my lifetime. Mm-hmm. And with those two conclusions, I wanted to be the one to do it. And then I aligned myself in that direction. I chose my thesis for my graduate work to be in voice recognition and machine learning, and after 5 years, we started the company.
Awesome, thanks.
We were not really AI focused per se. We're super focused on the idea of latching on to a consumer pain. So having sold my last venture in 2013, I had a little bit of extra time on my hands. I went back into my calendar and counted all the meetings I did the year prior, just for the fun of it. And over those 3 diacodes, I figured out that I did 1,019 meetings in 2012. And what was even sadder, I had 672 reschedules. What a bunch of fuckers. I said all those meetings myself. No assistant, no help, no nothing. And I'm sure SoftBank would have been all okay with me if I hired somebody to the office. And I think that pain just seemed odd to me that I spent 20 years doing that. And I certainly couldn't imagine myself spending the next 20 years continuing to do so. And I think that was the catalyst for me bringing the team back together and us spending the last 3 years in that basement trying to kind of not alleviate that pain, but really completely remove it so we could kind of democratize access to an assistant.
So to me, you know, it's this device here in our head consumes about 20 watts and is very efficient. It still has a lot of potential, including versus machines, but it's only good at certain things. And we saw when we started this that we could harness this amount of compute and the state of the art of AI to solve problems that this thing cannot solve. Yeah. And if we can do that, then we can augment our human intelligence, our species intelligence, then we will be a lot better for it.
So Antoine, maybe start with you around answering the question around, you know, we are all pretty much in the AI space that's been researched on for a long time. It's not a new space by far, but its emergence in the public perception has been quite recent. As far as the state of the art of what's happening in AI research, what are the challenges that currently exist, and where
there's the hype or the expectation that the public has around what AI can solve, not meet actual expectation or reality.
Sure. So what I see as the biggest challenge is the fact, ironically, is the fact that to do good AI, you need good human brains. And those are in short supply. That's the biggest issue we have. So for example, if you're trying like Google did with AlphaGo to develop a novel types of architecture for deep learning, so deep learners, it's going to take you 15 PhDs, 2 years. And that's a lot of work, a lot of pretty big egos to manage, and that's complex. So what we're trying to do to solve that problem is, can we replace those 15 PhDs in 2 years with 1 intern, 3 months, and 5,000 GPUs? Can you do that? And we're there. We are at the state of the art already, able to sort of short circuit this need for talent by having AI, if you will, evolve AI.
Right.
I think that is one thing, one big direction that I think will help unblock some of these problems.
I'll actually double click on that a little bit later, because the idea of self-evolving AIs has been a big topic of conversation as far as some of the fears in the space, etc. But moving on, same question, Dennis. You're interacting a lot with consumers, and so AI that's talking to computers versus AI that's actually talking to consumers, very different kind of approach with different kind of UX. Where do you see the challenges there? What is it that you're primarily trying to solve in that regard?
So there's certainly a challenge around managing the expectation, right? Because Hollywood have trained the consumer for the last X number of decades, and they've trained them quite well, but on a set of expectations that are just really hard to deliver on. But I certainly think we might have a possible chance of kind of delivering against those expectations if we pick a vertical for where you and I are in agreement up front. So if you and I talk about setting up a meeting, we don't really have much of a disconnect around what that means. And if we can somehow define that universe in full, that seems somewhat solvable. And that's certainly what we've been chasing. And I think the biggest challenge for us have been around not necessarily finding the 15 PhDs. If you have some money, you can certainly go hunt for them, and we can compete on who get the better ones. I think one of our kind of internal struggles that I think is not fully appreciated, and perhaps this is just turning into some sort of therapy session for me, but one of the kind of struggles that we've had been on the data collection end, which is that we have about 100 people on our team full-time that does nothing but data annotation and labeling, as in just assembling a data set which we didn't have before. And that is hard because they're still humans, right? Just because I ask you a question and you give me an answer, that doesn't make it true. That's just your label of it. And that has been a 3-year struggle. And certainly, if I were to kind of look at that set of internal challenges, that would be it. And I think the external ones would be expectations.
Yeah, I think that, well, expectations for sure, but this is actually an area where I think philosophically there's some difference. And I know, Antoine, you're going after more of a generalized AI approach. Speak broadly, and Dennis, obviously this view around verticalization. Maybe you could just give, sorry, Antoine, you can speak a little bit about that. I would love to hear that. And then maybe lead into, if you could just give one sentence or one statement around why the other approach is not the approach that you think is the right one or the most efficient one to go after. I'd love to hear that from both of you.
Yeah, can I talk about data collection? Because there is this, in my view, common misconception that data is going to win this war, that whomever has the most data is going to win. And in my view, it's very wrong. If you embed an AI system in the workflow of an organization or a process, and if that system can self-learn, then that doesn't need all that data to start with. You don't need to train it or less. You need less. And so, we as humans do not go around and collect data for the sake of collecting data. We go around and look at data to learn and make decisions. And when we make decisions, we learn back from this. So if you have a system that can learn from interacting, operating, and getting feedback, you don't need all that data.
Dennis, what do you have to say to that?
So, fuck, we made a mistake. 3 years. I do think even when we look at our data set, and we certainly had that kind of pushback, right? Imagine we raised a little capital, about $35 million. We walk into some investor meeting, and the first question is always, hey, Dennis, tell me why Google is not going to kill you tomorrow, because they got 900 million email accounts, and they must have all these conversations already, and couldn't they just train on it tomorrow, and you would be toast? And I'm not so sure that's, which is where I think our Venn diagrams kind of overlap a little bit here, that set of trillions of emails that they might have really either is a true data set which you can train on, and two is the amount of data that you need. So for us, there's certainly been, even before we started labeling, this major challenge of trying to kind of define this universe which we exist in, as in, what are the intents that exist in my universe? Set up meeting, cancel meeting, reschedule, postpone, follow up, running late, extend duration, you're optional, all the things that can happen in my little universe. Even just defining that, which seems like a 20-minute at the whiteboard for you and I, have turned into a major challenge. And if I look at all the money we've invested over the years, most of it have gone into, again, the labeling end. And whenever we make a mistake on, say, how I want to annotate time, we spend 8 months in collecting that, we label it, then we wake up one morning figuring out, you know what, that's not optimal. What it really means is that I need to go to the next board meeting and say, hey, remember that $2 million we spent on labeling this data set? We're going to flush that down the toilet because I have a better idea. Those meetings are hard. Right. So I certainly think that data is highly necessary, and some processes are near impossible to solve without a well-annotated data set at some volume. I think that's the most positive way I can push back on that.
I like what Antoine said earlier, where you know, machine learning and NLP, but machine learning as it relates to data is a necessary but insufficient approach to solving the AI problem. Kevin, so you're building obviously an interface for companies to use in their products so that they can interact with consumers with an artificial intelligence. Now, as the CEO of the company, how do you balance out the needs and priorities of those enterprises versus the needs and priorities of the consumers that eventually are going to touch your product?
Sure, that's a great question. So we have 3 products, a developer platform, which is a B2B product called Houndify, and then we have 2 consumer products called Hound and SoundHound that do different things. They are both powered by Houndify, and we get that question a lot. You know, can you stay focused and have these 3 products?
Sorry, that's a very VC type question to ask.
Well, even internally, our management and our employees sometimes ask, like, can we do everything? So we summarized our mission in, very focused in 2 words: Houndify everything, which is add voice-enabled AI to every product, whether it's a car or a cell phone or a mobile app or a refrigerator. We think you should be able to talk to everything around you and have a conversation with it. And we can't do that without having a platform that has a lot of tools for others to use without us engaging with them, because we can't go and Houndify everybody else's products. We have to enable them to do it. So we really need a platform. But we also believe that to make a successful platform, we need to have a product, at least one product that uses that platform that we built. Mm-hmm. Otherwise, we don't know how to evolve that platform, and we can't showcase the platform, and so on. So, and I've seen companies that build a platform and they want to take over the world with it, but they just build it and wait for people to create success stories on top of it. And that never happens because nobody knows about the platform, and the platform is not doing the things that people need. So we have, our Hound app, for example, we have really big ambitions for it. We want it to be, a voice-enabled assistant everywhere for everyone. And as we have ambitions and we want to make it better, we are very disciplined to make our Houndify platform better to enable those features in Hound. It's tempting to cut corners and only build features for our own app, but we always build those for our platform, which enables everybody else. And that has been a great strategy for us, because when we have 30,000 partners, including 11 car companies, are actively using our platform, and they always write to us, "Oh my God, you've thought of everything. This platform is so good." And the main reason is because, yes, we have a great product ourselves that use that platform, and that has been a great strategy for us.
So as far as this issue around humanization of AI, giving it a personality, giving it a way to interact with human beings versus just machines. What are your thoughts on that level of humanization? Is it necessary? Is it necessary for us to do that so that it becomes more accessible to folks? And then, maybe even talk a little bit about, the self-evolving part of it. If we're actually going to start to humanize AI, do they have to be self-learning? Where do you see the dangers and the challenges there as we segue into some of the potential fears that people might have around AI?
Sure. So everybody talks about AI, and it's a big buzzword, and some people use it to raise funding or sell other products. So we have to really understand what that means. Yep. There is generalized AI, which is machines with consciousness, and nobody has that today.
Sorry, what was that word?
Generalized AI.
Machines with what?
Consciousness.
Consciousness.
Yeah. So they actually know, they are aware, they evolve. It's like a human, and that is a big dream, but nobody has that today, and it's a big motivation to get there. But if, as a consumer, you're expecting that kind of interaction, you always will be disappointed. And if you have a product and you make that promise, you will disappoint your users. And then there is narrow AI or specialized AI. So like the things that Dennis is doing with his company, or we are doing in our own platform. That problem is solvable. It's difficult. He's has all this data and all these people working on one specific task, and it's extremely difficult. But I think it's doable. Mm-hmm. Part of our effort is always educating the users not to expect, like they're really talking to a human, because if you can ask, to book meetings, or you can say, we have really amazing features in our app. You can ask, I'm looking for an Asian restaurant that's not Chinese and is not Japanese and is open after 9 p.m. on Wednesdays and has Wi-Fi access and has 10 reviews and is within walking distance. We understand that, and we give you exactly what you want. And you can follow up. You can say, sort by rating, remove Korean, then sort by distance, and only show the ones that have a patio and are good for kids. Again, we give you that. Yeah. Now, once you have that interaction, which is human-like, you might say, okay, why is my wife mad at me? Right? People ask us that question, like, in our queries, why is my wife mad at me? Right? So we don't know, right? So, well, yeah, we don't. I don't even know if the generalized AI can answer that question. But that is a big challenge, and if you make it very human-like, you might raise the expectation, and then you might disappoint
That's
people.
a really good point.
Yeah.
Antoine, you talked a little bit about self-evolving, but yeah, it sounds like you have something to say about this.
Yeah, I can talk about this awareness thing a little bit. So, yeah. I think, first of all, there is this, people are fearful of this moment when machines become aware. This is not going to happen suddenly. We're not going to wake up in the morning one day and say, oh, the machines are aware. It's going to be very progressive. And let me give you an example. So in our trading system, we allow our artificial traders, self-evolved traders from data, both historical and live, we allow them to understand their state. So am I long, am I short, am I exposed, am I not exposed, am I doing well, am I doing poorly? And we actually see in a rule set that this self-evolves, that they actually take this into account when making decisions. What does that mean? Does they have a form of conscience? So, so you can see progressively that we are embedding aspects of state and perception about oneself that progressively lead to some form of consciousness. And then there's a whole big philosophical debate of what is consciousness, what is, and what is soul. I will leave this for the next time. But I think we're slowly getting there.
Yeah. Dennis, do you want to talk really briefly on that, or?
Sure.
Yeah.
I'm probably a little bit more skeptical, perhaps because I spent those 3 years in the basement in the dark, and I just can't even imagine in my lifetime some moment where we end up in a place where we could somehow align what we have here to some machinery. I can't see that. That doesn't mean that it's not going to happen, and I might be the one who's the most surprised. But I think if we come back to your question, a good way of perhaps breaking down the challenge is to kind of think of this as a conversational UI and a set of agents. And I think sometimes we mix the two together, for where there's certainly been a dramatic push on the conversational UI, whether that be in voice or in text. And I think there's plenty of application for where that is exactly what I want, right? So you stay at the Hilton tonight, and it's 11 p.m. and you want a Diet Coke. Your first thought is not, Yeah, let me go to the App Store, find the Hilton app, download and install it, set up an account, log in, find the store, add Diet Coke to basket, click checkout. Like, you fucking died before you got that Diet Coke. I said, that's not what you want. What you want is some conversational UI, which you got, which is called the phone. You click room service, you scream Diet Coke, you hang up, and somehow magically a Diet Coke arrives in 10 minutes. Perhaps a better version would be a big-ass number on the door, an Alexa in the room. So that conversational UI can very well be managed with human agents. That doesn't mean it's a bad UI. I think that's a good new UI paradigm. Now, the agents that exist within this UI paradigm, where I'm one of them, I'm the meeting scheduling agent. They can be machine-driven or human-driven, doesn't really matter. But I think if you separate the two, then I think you can justify why you would want them to be humanized, because I would really want perhaps some machine agents to coexist with some human agents, travel, elsewhere, and I don't really want the consumer to care whether it's one or the other.
So if we were to just wrap up with one final parting thought from each of you, but mostly around this idea of, if you were to just forget about what you guys are working on, right, and you think about AI and all the different approaches around and the state of that currently exists, where do you think AI is able to benefit humanity at large? Where do you think, if we as an entire species were to say, this is what we want to focus AI on, what problem would you like to see it solve? What kind of research approaches do you want to see being funded? And just, maybe spend 30 seconds, 45 seconds each on that.
So we're working with MIT on a project around agriculture, and we've worked with them also on healthcare. Those are two areas where I think there is a huge benefit to be derived from AI. I'll give you the example of agriculture. MIT has this open ag project where they embed a whole environment in a container. Container can be 40 feet long, or can be this size, right, roughly. And in it, they control temperature, lighting, nutrients, humidity, what have you.
Right.
And we inject our AI in it so that the actuators are driven by this feedback loop. So we learn from the growth of the plant, and we optimize the growth and the quality. So it can be taste, it can be quantity, whatever it is. And we've already achieved great results. And so can we solve the food supply through this? We can. It's creating the next generation of agriculture without any GMO.
I love that.
That's an example.
Dennis?
So I would certainly like to see some version of the future for where you are not rewarded for the answer you provide, but for the question you came up with. And today, most people spend almost all the time on providing answers, right? You run my set of digital campaigns, I ask you a question about how they perform, you spend 4 hours in our BI solution, you come up with an answer. But the question was really where the value was. And I think if we end up with this plethora of highly specialized vertical AI agents that can do little jobs in specific fields, perhaps it becomes easier to get that answer. And those with the best questions tends to be the ones that are closest to the customer, those lowest in the organization. And that means all of a sudden the organization could be turned on its head.
Totally.
That people in account management, customer success, and what have you, can very easily get answers, but they have really good questions. So I'm super optimistic about the future. Not one for where we end up with tens of millions of people unemployed, but for where those higher up, myself included, might actually end up being less valuable.
I think reframing what metrics we measure ourselves by, that is the key here. So that's great. Kema?
So I'm a big sci-fi fan, Star Wars, Star Trek, and I really like to see that future happen when you wake up in the morning and you talk to your alarm clock, then you go to the kitchen, you talk to your coffee machine, and then you go to your car, you talk to your car, and you talk to everything around you. There are robots, there are computers, there are TVs, there are refrigerators and microwaves, everything is voice enabled. And they don't just do what they are supposed to do, like making coffee for you, but they can answer questions to you, and they can do things for you with the services that they're connected to, answer questions about weather and sports and stocks and flights. And that's an area I'm really passionate about, and I'm working on it.
You know what I really like? Every single one of you is working on what you think is the best way AI can be used. So thank you very much, guys.
you ask any of the Amazon Alexa products, whether it be the Echo, the Dot, or the Tap, what she wants to be when she grows up, the answer is, I want to be the computer from Star Trek. And the reality is that voice control is now at the forefront of innovation, not only on our cell phones, but also in the home and at work. But in many ways, we're still trying to figure out what the next step is. Is it improving and increasing on things that we already use every day? For example, the LG fridge has Amazon Alexa built in. Is it in the Ford cars that are building Amazon Alexa? Or where is this technology going to go? Today, we're here to discuss and unveil a new product, which is fantastic, from Ecobee. So let's welcome alongside journalist Molly Wood, Ecobee CEO Stuart Lombard, and the VP of Amazon Alexa, Steve Robichon.
Guys, I love my stylish moderator chair.
Yeah. Nice.
Look at this big crowd. This is delightful. I heard them talking about voice services just as we were about to come on, so I feel like we're in good hands. I'm Molly Wood. I'm from Marketplace Business News. You may have heard us on public radio. And I'm going to let these two gentlemen introduce themselves so that you can put the face to the name, and then we'll get started with our conversation. Stuart, go ahead.
Beautiful. I'm Stuart Lombard. I'm one of the founders and the CEO of Ecobee. We make Wi-Fi connected thermostats, and we're going to talk about our whole home voice vision today, which is also very exciting.
Hi everyone, my name's Steve Robichon. Been at Amazon 13 years. I'm currently the Vice President of Alexa.
All right, we're going to talk loud because I know there's a lot of hubbub. Hopefully you can hear us. Just like give a wave or a shout if you cannot. And I know that we're going to just start with the headline at the top. You may have already seen some quite glowing reviews of your new product, but what have you announced today?
Yeah, very exciting. So today we announced our vision for whole home voice. And that vision is really around a home where you can walk into any room in your home and you can say something casually and get access to all those great internet services that you love. And it's a home that, understands what you want and anticipates what you want and just makes your life simpler and better so you can focus on the things that really matter to you, which is your family, your friends, and the moments that you share in your home. And so today we announced two products. The first one is Ecobee 4. And Ecobee 4 is awesome because it has all of the great features of Ecobee 3. It comes with room sensors, so it makes it comfortable in the rooms that you actually use.
We should tell people here if they don't know, it's a thermostat.
It's a thermostat, sorry, pardon me. It's a thermostat. It's a Wi-Fi connected thermostat. It'll save you money. It'll keep you comfortable. It has room sensors, so we know which rooms you're in and we make it comfortable in the rooms that you actually are in. But what's new and what's really exciting is for the same price, for that same $249 price, you now get Alexa built in. And so you can stand across the room and you can say, Alexa, play my music, or turn up the temperature, or turn off the lights, or whatever the case might be. Remind my kids to take out the garbage, which I always do, and it'll do it for you. And in addition to that, because you don't have a thermostat in every room in your house, we announced our smart light switches today. And the idea is exactly the same. It's a Wi-Fi connected light switch. You can control it through your smartphone. It has temperature and occupancy detection in it, so it'll work with your thermostat to make you comfortable in the rooms that you have light switches in. But it also has Amazon Alexa built in, and so if you put one in your bedroom or in your kids' rooms, you have all the same access to all those great internet features, and just really exciting.
Is this independent of owning an Echo?
Yeah, so clearly Echo and Amazon Dots have been hugely successful, so you can have those that'll work with those devices in your home. But it's like having a thermostat with an Amazon Dot built right into it, or a light switch with an Amazon Dot integrated right into it.
Now, is that what you imagined when you opened up Amazon Voice Services? You'd be kicking Echoes out of the house, Steve?
It is what we imagine. We have this vision of Alexa everywhere, and I thought maybe I'd just go into a little of the background of how we got here with Alexa. So, Amazon, we have this doc writing process, written documents. Is how we start off all of our meetings, and even if it's a new product idea. And so, well over 4 years ago, there was a doc review, and there's literally 2 sentences in the doc that kind of went like, what if we built the next Star Trek computer or the Star Trek computer? And that ended up being the inspiration, what is now today Alexa and the Echo product lines. And so at that time, a lot of this invention wasn't in place. So, if you think about the Echo hardware or the Ecobee thermostat, there's a lot of technology in the device that gets the sound. It's always ready to hear this one word, Alexa, to wake it up, listen to what's said, and then send that out in the cloud. So there's a lot of invention in the device itself over the last several years, as well as building this artificial intelligence that's out in the cloud. And a lot of things came together over this time. People have been working on voice and artificial intelligence for decades, but it was really the kind of perfect storm of AWS with unlimited compute out in the cloud, machine learning and deep learning to really bring these systems together. And so November 2014, we launched Echo. Wasn't sure how it was going to go, and customer response was really positive. It started off in an invite-only, preview to get the devices, and then we opened it up. And then as we thought about voice and how it can control technology, we believe it's a significant new interface that humans will use. It's very convenient, and it makes hard things simple, such as changing the temperature in your house just by speaking. And so, as we thought about that, we also opened up the service to third-party developers to do two things. One, help Alexa get smarter. So we have this concept of developers building what we call skills. And so anyone can build a skill to increase the capabilities of Alexa, whether it's, Oprah just launched a new skill a couple weeks ago. There's a Shark Week skill. You can get pizza delivered, as well as a smart home area, which we think voice is going to play a significant role in going forward. It just, for us, makes perfect sense. And so developer interest and feedback's been tremendous. We have tens of thousands of developers building on the platform. But then we also opened up another set of developer programming interfaces, which is what Stewart's company uses to embed Alexa right into their device, the Ecobee 4. And so we have this vision of Alexa everywhere. We can't do it all ourselves. There's no way we're going to build every smart home device and every wearable and automobiles. We don't build automobiles today.
Yet.
Yeah, I didn't say that. And so that we opened that up, and now we have companies like Ecobee embedding Alexa into their own products, which we're thrilled with.
Yeah, and I think one of the things that's so exciting is just where the technology's gone, right? And that it's so good now. And I think that's something that's really changed in the last, call it year or 18 months, to a point where, customers, it's really, really usable. It's really a different way of interfacing. It's simple, it's easy, it's frictionless. And in our field trials, what was really interesting is our Net Promoter Score on our field trials was 80, which is which is truly phenomenal. And I think it's a testament to just how far the technology has come over the last, call it 24 months.
Had you had a vision of voice as an ideal input, for connected homes prior to the Alexa integration, or was that the thing that made you go, okay, this is how we can use it?
I think we always had a vision for, how do we make our customers' lives simpler and better. That's really what we're thinking about. I think, with what Amazon has done, the availability of the Alexa voice services really changed the game, right? And I think we've been working on this for about 2 years now. It was a big part of our roadmap starting about 2 years from now, and there's a lot of effort that goes into making a great far-field voice experience. And so it's just exciting to see it come to fruition today.
And Steve, was that always part of the plan? People like me are always looking for a secret takeover plan. Was it always part of the plan for you to build out Alexa as a platform, or were you like, hey, this is really good, we could take over the world with this?
Yeah, Molly, it's a great question. It's, the way Amazon looks at a lot of things we do, we like to open it up and see what the community do to surprise us. And if you go back, I worked in AWS for 5 years when I started. In AWS, which is our cloud computing business, that was born because we felt we got really good at building our own infrastructure, scaling it, making it easy for development teams to build on it without being tied together. And so we opened that platform up. that offering up, and it's become a pretty decent sized business for us. And so we view Alexa the same way. Again, if you believe voice, which we do, is going to be a significant new interface, and if you look back, there was mainframes and green dumb terminals and keyboards, and unfortunately I'm old enough to have done email that way, and then that transitioned to PCs and laptops with mouses where you pointed and clicked, and then our mobile phones where you have the touch interface. And now we believe the next big phase is voice, and we're investing heavily in it. We have thousands of people now working on Alexa, and if you believe all that, again, we love to open these things up. They're going to be one of the best companies at building thermostats. We're working with
the best. You got that right.
the best.
The best. Thank you.
We're working with Ford and VW to put Alexa into their automobiles, appliances in the kitchen from LG and GE's building skills, and everything from door locks to sprinklers to garage door openers. And we just think that's the best way to go is to open it up, let other people build Alexa into their platforms, and by the way, we've spent years of this and have thousands of people. It's not we have hiring data scientists
really
and speech scientists,
people?
thousands
of people. Wow.
Yeah. And so I don't think Stuart would want to build his own AI. So again, it's let us do what we do best. We open it up and then watch the innovation that occurs with in collaborations like Ecobee.
And Stuart, I feel like it's a benefit, of course, to have this already built for you and have this great infrastructure built for you. It also gives a lot of power to Amazon. What are the potential pitfalls of being dependent? And this is a question I think everybody in the tech industry is asking about every platform, right? What are the potential pitfalls of being dependent on someone else's platform?
And I can hear you, by the way.
He's right there. We just don't look at him. Just eyes on me, Stuart.
I mean, I think anytime you partner, you have to have trust in your partner that they're going to deliver. And I think to Steve's point about focus, implementing far-field voice, the natural language processing backend, the artificial intelligence, the machine learning, that kind of stuff that goes into building that is super, super important. But there are all kinds of other things that are important to making a great consumer experience in your home. And so, the things that we're focusing on are really around, how do we create those great consumer experiences in your home? How do our devices work better together? Just like where the smartphone was, when we went from feature phones to smartphones, and your phone all of a sudden became much more than a phone and maybe a crappy camera. It had an awesome camera, it had a GPS, it had an accelerometer, it was a game console, it was like a navigator, it was like all those different things. The same thing is true with your connected home products. And so if you look at the light switch that we announced, for example, it detects motion and occupancy. And so it will be able to act like one of our room sensors. So it'll make you actually comfortable in the rooms that you have. And once you put a CPU on someone's wall, the incremental cost of adding a sensor is very low. And so what you're going to see is a proliferation of devices with more and more intelligence in them that can do more things for you that will make your life simpler and better. And that's really where we're focused in how we can really improve that consumer experience. And then relying on partners, and as Steve said, they've got thousands of people working on natural language understanding. Like, we're not going to out Amazon or out Google. We have to win, with a different strategy, which is what we're really focused on.
So you're saying the products are great even without? Like, if Alexa's down for a day, they'll still be great products.
Yeah, I think,
Not that would ever happen.
Yeah, that would never happen. I mean,
Steve's like, what did you hear?
I'm like, wait.
Yeah, I mean, I think all our products are built with this sort of idea in the back of our heads that if the world goes to hell in a handbasket, you don't want to freeze, right? And so, and especially, if you live in a climate that is quite severe, you understand like the pain that you go through when stuff doesn't work, right? Yeah. There was an ice storm in Toronto, and there was no power for 3 days. You're highly sensitive to what happens if your device goes out. So all our devices are designed to work standalone without internet connectivity or whatever, but they work much better if you have internet connectivity, access to Alexa.
What is one thing, and then I'm going to come back to Steve, but while you have him right here, what is one thing that you wish Alexa could do that it currently cannot do?
get my kids to take out the garbage.
Cop out.
You know what? I think it's one of the exciting things about the product category is that all of the devices are fully upgradable. So if you opened up one of our thermostats, or you open up the light switch that we're launching, it would look much more like your smartphone than a typical programmable thermostat. And the result of that is we can add features over time. So we have a really great product roadmap. I know Amazon is working on a bunch of things, and the really nice thing is consumers get access to that technology as it becomes available. So for example, if you bought an Ecobee Smart Thermostat back in 2009 when we launched our very first product, it works with Amazon Echo today. And similarly, we just launched Ecobee 3 Lite. We just upgraded it. If you bought an Ecobee 3 Lite 6 months ago, it now works with room sensors. And so one of the great things about this technology is that over time it just gets better and better.
Steve, how big of thousands of people is a pretty big initiative on Alexa.
Yeah.
How big of an initiative is Alexa voice services? Like, is it now, or do you think it will become a significant revenue stream for you?
Well, we do think it'll become a significant business. Just in terms of interest we've seen with partners like Ecobee. And we were at CES last year in between Skills and partners announcing AVS integrations. I think we had over 40 announcements at CES. And again, everything from Huawei on mobile handsets to Ford and VW, which I mentioned, other smart home providers. And so, if you believe voice will be this significant interface, I think every company out there, well, not every company, but many companies in the smart home space, automobile manufacturers, everyone's trying to figure out today where is voice in their strategy. And so we're in a lot of early discussions with companies as they're ideating what to do next and how to integrate voice with their products. And we're investing quite well in this area of the Alexa family as well.
Yeah, I would argue, I think I even wrote a blog post saying that Amazon won CES in terms of those. How far out ahead are you of the competition? We were just talking about what Google has announced in terms of voice-based APIs, and it sounds like they're, pretty far behind you, and I don't think that HomeKit doesn't seem to be going anywhere. So
we're actually pleased to see other folks entering the space because we think it's good for customers. We launched in 2014, opened up in 2015, and our job number one is to listen to customers, listen to companies we're working with, and execute and innovate as quickly as we can on their behalf. And so that's why I think you see the companies investing so much in this area right now.
So let's turn to the consumer experience because, of course, the unavoidable question that everyone has. I have noticed, for example, that my cleaning lady mutes my Echo every time she comes into my house, which I think is fascinating. I don't know if it's like by accident or if she's doing it on purpose. But if she's doing it on purpose, it speaks to a real consumer question, which is what are the pitfalls of having an always-on, always-listening device in your house? Do you feel like you've adequate? How do you address that, for one?
Well,
and then we'll ask Stuart the same question.
Yeah, we do get this question. Stuart can answer from his side, but we do get this question a lot. And as you think back, more than 4 years ago when we started off building this product, we always set what we call tenets for how we're going to proceed. And security and privacy for us are the most important tenets for this product line. Like Stuart said, if we aren't perfect and the best we can be in those areas, we really have no business. And so we have we have an internal security team. Even when we build our own APIs that we expose, it goes through an entire security review. We use security protocols, best practices from other parts of the company, like AWS. It has built a multi-billion-dollar business on opening up developer APIs where other companies run their entire business, on the AWS cloud. And then even when we work with partners, and we're in close collaboration with the Ecobee team, when they're ready and they have their device, we help certify it and bring it in-house and do more security reviews. So utmost important to us. A little bit just, how the device works. I'll talk from the Echo perspective. How many people own Echoes out there? All right, that's pretty good. Thank you. So for those of you that don't, it's a cone-shaped speaker, and it's always ready, waiting for this one word that wakes it up. and it starts recording. And that word is Alexa, but you can change it to a couple other words. And when it's woken up, a blue light comes on, and that's the only time the device is actually recording. And then that speech is sent out to the cloud for natural language understanding and processing, and with super low latency comes back and sets your temperature, plays music, tells you the weather. And so, and then when the blue light's not on, it's not recording. And all that is in control of the customer. They can delete all those, we call them utterances, but what you say to Alexa, you can go in and delete those. You can delete them all. You can delete them by sentence by sentence. So you're in complete control of the data that's captured by us, but it's also in your Alexa app. You can see exactly what's been recorded. And then when you hit the red light, electrically the microphones are disconnected, so the device is just not working at that point.
How can we know that? Like, have you put the certification process out for peer review at all? I feel like a lot of companies, especially now, right? Every company is saying that privacy is really important to them and that they're taking the utmost precautions. But it's rare that we can see that. Like, how can we know that, especially as voice becomes, and look, I live my life on voice. I dictate every text. I hit the microphone button to do every single email. Like, somebody for sure knows everything I say all the time and how I say it. But I really want to know, as it proliferates, can you prove it to us?
Pardon?
Can you prove it to us?
Look, we don't test it externally. I don't think we've had incidents where this has been an issue. I will say, Amazon is kind of, not the answer you're looking for, but we're one of the most trusted companies out there by surveys and polls. And we have a lot of customer data, shopping, and we have company data on AWS, and we just take it so seriously at the highest level of our company, all the way down. Is
this something you hear from consumers, Stuart? How do you address this?
Yeah, definitely we hear it from consumers. I mean, we see ourselves as guests in your home, right? And so, like any guest, we're not going to be in your home if we don't behave well. And so thinking about security from the very beginning is super important for us, and it's everything about our brand, and we know that if we did have a security breach, we would have no business. And so it's in the forefront of our mind. That's the first thing. I think the second thing that's good news is there's a lot of industry best practices that are out there, so we don't have to create everything from the ground up. When you look at attacking a thermostat as an example versus attacking your bank account is probably a better target. And so we can take technologies that are available in other industries and we can use them to protect products like our connected home products. And so, we use things like public key certificates and encryption. We use those best practices. We actually do send out our devices to third parties to get them tested, to look for vulnerabilities and those types of things. We have a security team. And so I think, as Steve said, I think it's such an important part of our business that we're very focused on it. I'd say, there's definitely a group of companies that would be similar, right? I think our concern is more, that you get a cheap knockoff, let's say, where they haven't thought about security. And so, for example, there was the issue with the bots and the security cameras that weren't protected, that had weak passwords, right? I don't think that any high quality product being released, in this day and age would have that vulnerability. And certainly not from one of the tier 1 companies.
Mm-hmm. Yeah. Who in the audience has some sort of a smart home product, either hooked up to your Echo or otherwise? So fewer, but still some. What is the barrier? It seems like now we're basically at thermostats and lights. I did the TV thing. Alexa turns off and on my TV. My house sitter this week actually was like, "Why won't the TV come on?" You have to ask. You have to ask the machine to turn it on for you. But what are the barriers or what are the next steps? How do we move sort of beyond this product category to that vision of a whole voice-controlled home? Whole home voice, is that what you're calling it?
Whole home voice, yeah. I think I think consumers are on a journey. So one of the reasons thermostats sell really well is because the value proposition is really easy to understand. Mm-hmm. Looks way better than the old one I had. It's connected on my phone like everything else in my life. Probably pay for itself in about a year. Like, why wouldn't I, right? And so what we're seeing is consumers are buying a first connected home product, which is often a thermostat. And whether you read the reviews for us or Nest, people are getting good value, right? The the consumer scores on those products are good and getting better, which means that as we move from an early adopter phase to a early majority phase, we're seeing that people continue to get value. So it's not just that early tech adopter. And once they have one product and they're like, wow, that was awesome, what next can I do? Then they add a second or third. And I think that's really where we are right now. And once they have 2, 3, 4 products, that's when the light bulb goes off and they start thinking about like, how do they all work together? And that's where I think the integrations that we're doing with our ecosystem partners, like Apple, like Samsung, like Amazon, obviously, can really change the way consumers interact with those devices and create that really magical experience. And there's nothing like walking into your home, into a dark home and saying, Alexa, turn on the lights, and the lights come on, or play my music, or whatever it is. Text mom, I'm home. Those are all like wonderful, wonderful use cases that that people love.
Steve, what do you worry about in terms of voice services being everywhere? Because let's say I buy a bunch of Ecobee products that have, this was, for example, the Android concern. People may start to have, maybe the lights don't come on. Not the Ecobee light bulbs, but maybe some other light bulbs with Alexa built in don't come on. To what extent do you start to bear brand responsibility for the way that other people integrate Alexa voice services?
Well, we, in all the smart home devices, we have a separate certification program so that products go through and they're certified as works with Alexa. And we actually use third-party labs for that as well. And so we run them all through that. I think overall, and also back to your question on ease of use, it's, we're making it easier and easier to set up all the smart home devices, but, to use another Amazon term, it's still day one. This was written about in Jeff Bezos' recent stockholder letter. The whole letter was about it's always day one. And it's so early on for us. And so we've been at this only a couple years now. We're listening to the companies we're working with as well as consumers. And I think you'll just see us continue to innovate and make it as dead simple as we can.
Yep.
Yeah.
It still is an ecosystem, right? It still is living within the Amazon ecosystem. And I would say that probably the biggest question that people have about Alexa is why it can't answer more questions, right? Like why we are fond of saying in my family, why doesn't Alexa have Google? How is that awkwardness going to play out? Or is there going to be some version? Could you get Bing? Like, could something come in to just?
Again, we have a dedicated team, so we have what we call our knowledge graph, and we just keep adding to it. Every day, Alexa gets smarter, through third-party developer skills, and a lot of skills have a lot of knowledge in those, but also just our core knowledge graph. We just keep finding more and more data sources, adding to it. Every day she gets smarter, and so again, we've been at it a few years. We think over time the knowledge graph will just get better and better, and we'll continue to add to it every day. That's another dedicated team. A good-sized investment team that just does nothing but make sure she's answering questions that we're hearing.
Maybe like Yahoo? You could just get Yahoo search. All right, I'll leave it alone. I had I was going somewhere with this. When do people, I tend to get a lot of emails. This occurred to me in the middle of our question, and it's a little bit out of left field, but I actually get a lot of email from people who are concerned about accessibility. And obviously, whole home voice has some accessibility concerns, whether you're deaf or speech impaired. Is that something you can deal with at all? Is it something that can be baked in? Is there ever going to be a physical interface that can solve accessibility concerns around voice?
Yeah, I mean, it's a multifaceted question, I think. So today, if you're deaf or hearing impaired, there is screens involved with Alexa. So there's Fire TV, there's our own tablets, and so you're starting to see Alexa have this blend of what we call headless or just voice only, but also paired with a visual experience in some of our current products that are shipping. We've also been really pleasantly surprised. We don't have an initial focus on this area, but there's been other people with disabilities or handicaps that have fundamentally said this voice and echo have just changed their lives.
Right.
And we get emails come inbound just thanking us for all sorts of different scenarios where, this one guy, he built dots and put them up in the ceiling. His brother's physically handicapped, and so that he fixed them to the ceiling in the light sockets in every room, changed his life. And so we just get a lot of those type of stories coming in. And so, we have a team looking at it and see how we can be better in this area as well. But it's been, for some people it's been, a big,
I would say it's really pushing the envelope the other way, right?
Yeah.
And so now you just have more choice. So if you're visually impaired, you can use voice. If you're mobility impaired, you can use voice, or you can use your phone. If you're, if you're deaf, for example, you can use your phone. So you have many different ways of interacting with the device, which just makes it more accessible.
Steve Rabuchin, Stuart Lombard, thank you so much, guys.
Thanks,
I would
Molly.
have between 10 to 100 follow-up questions, and unfortunately, we have to go. Thank you so much for your time, guys.
Thank you.
Thank you, everyone.
Thank you.
Let's shift gears a little bit and move away from the home to the vehicles that get us there. Big automakers are frequently finding themselves not only collaborating with, but also competing against many startups and companies that are building the technologies that are driving autonomous vehicles. Too many puns. A fast-charging unicorn that is building the crucial elements of these autonomous vehicles is up next to explain what they're working on, where they're going. Let's welcome Comet Labs founder Adam Kell and new unicorn Quanergy's CEO Luay Eldada.
So just to squeeze a few more puns in there, I think we're the first speakers on the AutoTech stage talking about driverless vehicles at a conference called Collision. So for what that's worth, it's great to be here. How many people in the audience know what LiDAR is? Oh, cool.
Okay.
Awesome. Well, I thought for the rest of you, it might be good just to jump in a little bit into kind of what the core technology is that the company Quanergy is working on. And so would love to kind of hand it over to you to tell a little bit about what the LiDAR system is and how yours is different from what's out there on the market.
First, let me show you a LiDAR so you don't wonder too long what the thing looks like. This is our solid-state LiDAR. Solid-state means it has no moving parts. It's a laser-based sensor that maps in 3D the environment around it. It sends on the order of 500,000 laser pulses all around the object, the sensor in this case, or the vehicle, and creates a 3D envelope of the environment at a certain rate of 10, 100, or 1,000 frames per second. With the envelope being very tight, you can do classification of objects, track them, and have a very good understanding of the environment. So this is the hardware is the eyes, and then the software or the AI is the brain, and we do both.
This core technology has been super important. Have you guys ever seen the videos of the DARPA Urban Challenge where they have the cars that drive through the city? That started in the mid 2000s, and LiDAR has been a core component in making those successful. So most of the folks who are working on autonomous vehicles have LiDAR systems implemented.
And speaking of DARPA, actually, this work goes back to my DARPA-sponsored PhD in the early 90s.
There have been two main approaches for autonomous vehicles. I would say kind of the Google approach, which has been basically straight to level 5 autonomy. A level 5 autonomous car is one that doesn't have a steering wheel, so there's no way for the user to actually take control of the vehicle. Most of the other automakers and technologists have focused on a more incremental approach, so going through level 0, which is sort of the average car that you would have bought about 10 years ago, all the way up to level 5, which is that full autonomy. So the example that everybody thinks of is Tesla, which today has autopilot, which is, depending on whose definition you listen to, somewhere between level 2 and level 3, which means that you can operate it on the highway, and just based on the sensors on the Tesla itself, which actually doesn't have a LiDAR, but just based on those sensors, you can use kind of this lane keeping and collision avoidance, doing the relatively what we call the simple tasks of autonomous vehicles. So I would love to kind of get your opinion on these two different approaches, not necessarily on LiDAR versus no LiDAR, but more on kind of straight to level 5 versus this more incremental trajectory that most of the automakers are taking.
Well, Google went straight to level 5 in the spirit of their moonshot program. They're pushing the envelope, that's what they do. In reality, practically and commercially, you'll climb from level 1, 2, 3, 4, 5 gradually as the technology, hardware and software, and the legislation support deployment. We and our customers, whether it's the automotive components or system integrators, such as Delphi, Bosch, and others, and the car makers, we're all very careful. We're erring on the safe side in terms of when we decide that something is ready before deployment. Google has, in reality, it has vehicles where the steering wheel retracts, where in principle the pedals retract, but in case of an emergency, they can push a button and they come out and they can take control. So they're shooting for level 5, but it's definitely not ready. In my opinion, level 5, which is full autonomy, which basically where a vehicle would pick you up without a human being in it, or a car goes park itself, or it's just basically you take a nap in the back during your commute, or you really sit in the back and you work. That, in my opinion, it might take till 2025 to be ready. However, level 3 and 4 will be ready sooner, in the next 2 years. Now, there's different schools of thought. Some people say that level 3 might never happen because it relies on too many cases of the driver being asked to jump in. And you cannot count on every driver having the mental presence and the physical reaction to actually jump in many times. It could be a few times per minute. That's why level 3 is seen as maybe a level that should be skipped and go straight to level 4, where the driver really is sitting behind the wheel. The car is supposed to do everything, but the driver is there just in case, in the very unlikely event that something is needed. And we actually believe in that school of thought, because any one of you might say, I'm ready to jump. So if that's the case, great. You're in great physical shape. You're intense. You run in the morning. You're always kind of sharp and so on. But now, take a case of maybe as we get older, we all have a slower reaction time. Maybe our vision gets worse and so on. And once we go into a nap, maybe it takes longer to kind of wake up. You cannot expect every single human being to react the same way. Although you might say, I'm ready to jump in every 10 seconds, not everyone can. And when we do commercial deployment, we have to look at the worst case.
Yeah, I think definitely looking at the kind of the driver's ability to take control of the vehicle is one thing. Another one of the things that's pretty well known within autonomous vehicle circles is that the problem of making an autonomous vehicle would be a lot easier if all of them were autonomous. One of the other kind of variables is the other drivers on the road, and we like to, kind of jokingly say, it's all those other crazy people on the road, not me. But in this case, it really is. It's like if all vehicles were autonomous, if there was, a date that we picked that everything would switch, of course not feasible, but that would make the problem a lot easier, or at least a lot more predictable. And so you touched a little bit on mobility as a service. This is one of the things, kind of one of the overarching paradigms of what's happening in autonomous vehicles is the idea that automakers are going to look less like product companies. They're going to look less like a company that builds a widget and sells it to you for this much money, and then you maintain and operate that vehicle over the lifetime. Rather, what they're moving towards is mobility as a service. So that would be something where an automaker like GM, for example, starts to look a lot more like an airline provider like Southwest rather than an airplane manufacturer like Boeing, if that makes sense. Sorry, that was a big analogy to throw at you. But basically what that means is that companies like Ford or GM start to look a lot more like Uber or taxi services. And that's something that you touched on in kind of your previous answer, but I'd love to hear how a company like Quanergy thinks about that shift to mobility as a service. Is that something that you guys you think about, or?
We do, certainly. Mobility as a service, or MaaS, is definitely something that will happen. It doesn't mean it's going to happen. It doesn't mean it's going to be supported by every car maker. It doesn't mean it's going to be supported by all fleets. For fleets, it makes lots of sense. When you look at Uber, Lyft, and others, certainly it makes more sense to make the vehicles autonomous and have one car kind of pick people around, drop them off, and so on. Now, for automakers to shift to that model, that might take a bit longer. When you sell a vehicle, you sell it to a fleet owner or you sell it to an individual. When you sell it to an individual, often people don't want their car to basically be used by others. So now, if that means for that to happen, every car company has to turn into a rental car company, basically, where the vehicles are provided as a service. That could happen. It's going to take longer. Many companies, such as Daimler, have their main line, and then actually they also have a small subsidiary that does have mobility as a service. And that will grow over time at the expense of vehicles to individuals. But overall, it doesn't mean that the car industry is going to take a hit, because the demand will increase and the accessibility will be so compelling that even people who don't even use vehicles, like my wife, she bikes everywhere and so on. But if she knew that a vehicle could drop her off and it's being used in a green way, by not being unused too long, then even someone like my wife might use a car.
Yeah, I think definitely one of the other big pieces that people are talking about within autonomous vehicles is kind of the concept of a mapped environment versus doing all the computation on the fly. One of the things, like the example that I mentioned about all car companies moving towards mobility as a service, another piece is how much of the actual intelligence needs to be on the vehicle. The kind of analogy, I'm throwing a lot of these at you, but the analogy that I'll use is basically like, you can still operate. If you're not from New Orleans, you can still drive down the streets of New Orleans just based on taking in the information. There's a lot of schools of thought within autonomous vehicles that say, that's not good enough. Basically, the processing power on board and the sensors aren't good enough for us to be able to on the fly, or at least not safe enough for us to be able to do all those calculations on the fly. So how do you guys think about kind of the concept of a heavily mapped environment? When I say mapped environment, I mean, the car basically knowing where to effectively look to try to see the stoplight, or where to look to see, lane markers.
Actually, we agree with Google and with most automakers that you need to pre-map the environment. It gives you a more robust system for many reasons. Some examples include confidence in what you're seeing things that might be hidden by objects, but also reducing the compute power needed. If you're doing a true localization on the fly, the compute power that's needed is very high, it's expensive, and it's almost prohibitive.
Definitely. So I guess kind of in that same vein, the auto industry has a long history of being super thorough, and rightfully so, before they put a new product in the market. I think today the cars that are being designed are in the 2020 model year. What does that mean for startup companies that don't have $100 million in VC backing and a $1 billion valuation? Where do these smaller entities exist within that big supply chain?
Well, small startups maybe that don't have quite as much funding as we do would eventually be absorbed by others. It's very difficult to be relevant in the automotive space without the right resources. It's not something you can whip together and go with something that's good enough. As you said, the solution has to be done and tested in a thorough manner, and
autonomous vehicles being at I'll say the tail end of the hype cycle. So that's driven a lot of new companies to start, a lot of companies to be acquired. by automakers, and so yeah, I definitely agree that you know, a big consolidation is sort of coming.
And by the way, we're going public next year. We don't plan to be acquired. Yeah.
So next thing I'd love to jump into is there has been kind of a changing of the guard within LiDAR systems themselves. So there's sort of the old guard, the stuff that we mentioned in the DARPA Grand Challenge, Urban Challenge, and sort of there's what I would call like the second wave, including Quanergy in that group. And there have been a few others that have popped up. I'd love kind of just to chat a little bit about what has been the transition. You know, this LiDAR is a technology that pretty much everybody agrees it needs to be in autonomous vehicles, and yet it's been still very slow at being rolled out.
Right.
And so would love to get your thoughts about why that is and sort of what's going to change in the next couple of years.
The technologies that would meet performance, reliability, and cost requirements are rare and take time to develop. We've been working on this for 27 years, since I started my PhD and developed this chip for DARPA. A company that started to exist 6-9 months ago and whipped together a LiDAR from off-the-shelf components, you know, by shining a laser on mirrors and collecting the light that comes back, they will get something that's called a LiDAR. However, in terms of reliability, confidence in the data, in terms of cost, if they want to achieve long range and so on, that's not there. So they might achieve range and detection, but however, dependability, reliability, and cost are not there. It takes a very long time to make a technology that's worthy of being automotive grade and worthy of being in autonomous vehicles. It's our lives, the lives of our loved ones that we put in vehicles, and we don't take this lightly. We see as our mission, basically, we describe our mission as basically doing 5 things: save lives, save space, save time, save energy, and save cost. With save lives being the first one. 80% of accidents today, or collisions in the spirit of this event, are caused by a driver lack of attention. They're distracted, there's poor visibility, the sun is hitting you in the eyes, there's some kind of challenging condition that causes you to not be fully capable of making the right decision. And we can eliminate virtually all of those by using a LiDAR that's not distracted.
Within the scope of kind of this long automotive supply chain, one of the sort of case examples of how valuable being a tier 1 automotive supplier is exemplified. A lot of people are saying in the acquisition of a company called Mobileye, which builds computer vision processors for a lot of the lane keep technology that's in most of the cars that are shipped today. And there's a lot of, I don't know, kind of people talking in the media. I don't have necessarily any information about it, but a lot of people were saying that one of the main reasons for that acquisition by Intel, which happened just a few months ago, was around Mobileye's tier 1 status as a supplier to all these OEMs, and the huge growth in autonomous vehicles. So I'd love to ask you, how do you view kind of, we have these, well, we used to just have these 2 main players, which are the OEMs, those are the actual people who build the cars and brand them, and then the tier 1 suppliers, so those who supply honestly most of the parts that go into them. And now we sort of have this third group, which are the startups and kind of these people who are either going to grow into being tier 1 suppliers themselves, or maybe just kind of short circuit this in some way to be able to sell to a tier 1 and then to the OEM. So how do you view the power dynamic between OEMs and tier 1s changing?
Right. We have partners. Instead of us being a tier 1, we decided to go with the approach of having a tier 2 partner, Sensata, which is the former sensing division of TI, Texas Instruments. They're in the Boston area. And on the tier 1 level, our closest partner is Delphi. And through them, we supply automakers. And that brings a lot more confidence and credibility when you're supplying automakers. Speaking of Mobileye, we are very happy with the exit of Mobileye. Any success in the industry, as they say, rising water lifts all boats. It's definitely an exciting event. That said, Mobileye uses video cameras for perception. We use LiDAR. The differences are that when you use a video camera, it's a 2D sensing, and you're looking at each frame, 2D array of pixels, and analyzing this 2D array of grayscale pixels to estimate basically how far an object is, how big it is, what it might be, and so on. And the result of all this processing done on the Mobileye semiconductor, Mobileye is a semiconductor company, that's why they were acquired by Intel. So the outcome of the processing is a low quality version of the raw data you get from the LiDAR. Because as you're actually sending laser pulses and measuring the round trip time for each laser pulse with very high accuracy and resolution, you have a direct measurement of how far an object is, no need to estimate, of how big it is, of its exact shape. You have a very tight envelope of each object, up to 150 meters. So that's our raw data. So all the software that we do is for a few levels above that. So we look at the shape of objects, we classify them, we track them. Then we look at the environment, we do path planning, and then we make navigation decisions. So everything we do in software is levels that sit above what Mobileye does. Mobileye was a pioneer and leader in the ADAS space. We respect them a lot. This is the next wave, and this is the next generation of perception.
Awesome. In our last 30 seconds, I'd love to just close with what do you think are some of the most important questions about autonomous vehicles that people aren't asking right now, so that I can take notes for next time I host a panel like this?
Sometimes, people look at a technology and maybe in a pitch, one might show, beautiful visual graphics collected by, 3D sensors. The question is, how reliable is the data? What's the lifetime of the product? If it's based on moving parts, do they get stuck? And when they get stuck, is it eye safe? And fourth question is, what's the cost? It's very important. If there are fundamental limitations, for instance, you cannot work in silicon, you have to work in gallium arsenide, that's a factor of 1,000 in cost. An 8-inch silicon wafer is $5, an 8-inch gallium arsenide wafer is $5,000. So people who don't ask these questions and they get enamored with some visual, with some beautiful graphics and visuals that are colorful, are missing the point about whether it has the potential of being deployed in volume in vehicles. As any sensor in automotive, in the automotive industry, the cost has to ultimately go below $100, and we have a path to go to below $100. The entire LiDAR will become a single silicon chip, and the cost will be below $100 in our next version of this.
Great. Fantastic. So interesting. Please join me in thanking Dr. Louis Aldada from Quanergy.
Thank you.
Let's keep the conversation going about automated and autonomous transportation. Last year, the Volvo Group did something absolutely unbelievable, and that's debuting the world's first fully self-driving truck in a very exciting fashion. If you haven't heard about it, they had this truck drive underground through an operational mine, navigating on its own and stopping on a dime pretty much in front of one of their senior executives. Let's bring that senior executive on stage in a fireside chat with Popular Mechanics' Alexander George. Welcome, Torbjørn Holstrom.
What's up, everybody? My name is Alex George. I have the childhood dream job of being an editor at Popular Mechanics magazine, and I'm here with Mr. Holstrom here to talk about an invention that he's been working on. If we can get the visual up on stage of what of specifically what we're talking about. This is a screen capture of you decked out in a mine in northern Sweden, and the vehicle before you is the subject of our discussion. So for those who haven't seen the video or the images of it, what is before you in this picture?
Well, we have been working with autonomous vehicles and automation for many, many years. And we, as everyone else is doing in the industry, we are doing prototypes and we're doing tests with autonomous vehicles. And one way of doing that in, let's say, in the confined areas was that together with a very advanced mining company up in the northern part of Sweden, we went down in a mining pit 1,300 meters below the surface, and we were running then an autonomous mining truck. And you see me standing in front of it because it was a little bit a showcase then in front of my engineers at that time then, that if I dare to test the vehicle and standing in front of it so that it understands that someone is in front and stop at the right time, it was me to do it then from the very beginning. Then we still do test, and we are still doing development on the autonomous vehicles, and this is one way of doing it. It's in a confined area, it's very special, and it's in real operation, which is extremely important. It's easy to, or not easy, but it's easier to do a test when you're running around the corner, so to say, or running around the block. This is in real operation. It will operate in this mining operation then, running with the iron or with the ore from one place to another then, down in the pit then, 1,300 meters below the surface.
So off screen, it's an enormous, a diesel truck that you might recognize otherwise. Yeah. But tell me about, so what is the truck using to see that you're here and knowing to stop in time? What are all the geeky kind of LiDAR, everything that we were just talking about, all the redundancies that made you pretty confident wasn't going to make you into a pancake?
Well, of course, we are using all the new technologies that comes up right now, as you heard just a couple of minutes ago then, about LiDARs, radar system, ultrasonic sensors, cameras, of course. But what is important also is that we have for many, many years, all the way since the late 70s or the beginning of 80s then, stepwise then introduced systems and components in the vehicle that make the vehicle ready for automation. We have transmission automation, we have engine automation, braking automation, and lately we introduced then steering automation as a base for then taking the step and adding the new sensor technology and the computer technology and the software technology on top of that. And by that we are able now then to take the next step, because if you see then everyone else they are also talking about how do you make the vehicle itself then safe in, let's say, the autonomous era, which is very important. And we have been adding then features and testing that for many, many, many years, ever since the early 80s or late 70s.
So particularly to everybody who's had well-intentioned family members ask, what's going on with these self-driving cars? When are they coming? I'm partially responsible for those headlines, I apologize. But the specific thing that we talk a lot about is what advances have made inventions like this possible. And one of them is GPS and wireless communication. But a mine makes that very, very difficult. So it's different from any other environment. How do those essential parts work in an environment like that differently than above ground?
Of course, a GPS doesn't really function 1,300 meters below the surface. And high definition maps and so on. This vehicle, first of all, it makes its own map, which is one part of what self-driving or autonomous vehicle is doing. But on the other hand, this mining operation is very much in the forefront of technology. So it's there's a wireless system, Wi-Fi system in the whole mine, but there's also a traffic management system which controls or sees then all the vehicles, not just trucks, but other vehicles that you have in the mine, but also all human beings that are in the mine. And by that then ordering, let's say, an autonomous truck to go from one place to another, but also then seeing that if something happens, something dangerous happens, then they have track of all the vehicles and all the human beings then down in the mine. So in this specific case, it's a combination then of a good and high technology in the mining operation, but also then what we can deliver then in this case.
And so this is something, so we talk about technology, where I work, we talk about technology, we also talk about home improvement, construction, these different things. This makes me think of ways that drones are being used to survey land or to do inspections and basically take humans out of precarious situations. Now, talk to me about how, we're talking about mining, which is an extremely lethal profession. In a workplace, how does this change the workplace in terms of what are the very specific safety concerns that something like this addresses? And we were talking about ventilation before.
Yeah,
it's a place to start.
For sure. I mean, underground mining, one of the most expensive thing that you're doing then in an underground mine is to ventilate. When you have a blast, you have a lot of toxic gases then down in the mine. You have to ventilate the complete mine, and it's not few cubic meters. It's an enormous amount of air that needs to go out and in of a mine and to get people down in the mine. If you could have, and when you could have autonomous vehicles that doesn't really need that, let's say, clean air down in the mine, you could then send vehicles down in the mine without then ventilating the mine as much as you need to do then after every blast in the mine. So that is one thing. And of course, in mines, there are accidents. You have rocks falling down and so on, which makes the mine much safer. And by that, of course, also much more profitable in a way. So you could use the mine for a longer time, and you don't need so much rich ore, so to say then. So you could run the mine with less content of the real, let's say, if it's gold or zinc or whatever that you're taking out of the mine. So
right. This is north of Sweden. It's a rare earth mine that you're in right there.
Yeah.
Talk to me about the experience of the people who are involved. I know there's a lot of the technology goes into being aware of the human beings that are nearby it. When something like this gets introduced to a mine, how's that changed the workday for the humans involved?
Yeah, I mean, absolutely. I mean, if you take them typically for an individual that is running the vehicles, they can work for 4.5 hours, then they have to rest for at least 45 minutes, then can work for 4.5 hours again. And it's a very tough operation inside the mine. So there is a possibility then to run this type of operation then seamlessly. You don't have to rest. You could run the vehicles almost 24/7. You have to do some maintenance, and in the end, but a much more productive system, and you could use the infrastructure and the installed capital much better than in this case. And by that, of course, increase the profitability for the mining operation.
Got it. And it's communication from the surface down to the vehicle while it's in motion.
Yeah, yes.
What is the human involvement on that side of it?
There is a control. You could say it's a traffic controller and sitting on the surface, then overseeing then the whole operations from blast to transportation to the crusher and all the way up then to the surface, and from that all the way down to the next station, so to say. So.
And so it's outfitted with all this hardware that we just talked about too. But it's also is it a diesel truck more or less underneath it?
It's today it's almost a standard truck, then added the new sensor and the new software. So we today already have that truck in production. So it's very well tested, so to say, for many years.
And the thing that we were talking about before that is really interesting to me, if you've ever had seen somebody drive an 18-wheeler or a serious machine like that, maybe this would be a number of years ago, but how many gears you have to shift and how much work has to go into it and how much your left leg works with the clutch and all that. The difference between then and now in terms of how optimized the transmission is and how optimized the steering is, all those different things. What's different? What else is different about that?
It's a very big difference. If you go back in history, once, I mean, a lorry driver or a truck driver, they were worn out and very quick by shifting and declutching and so on. So the elbows and the joints all over were worn out. And that started everything when it comes to automation. And we have to see to that the driver is less fatigue and will not be worn out and over time. And that started the whole era then when it comes to automation. In combination with new technology at that time, if there is someone here in this audience remember the Intel's 8085 microcontroller, that was the first one then combining. We had that microcontroller and on top of that we have the mechanical system then, and combining that into mechatronics, that took the first step then when it comes to automating transmissions, engines, and onwards then all the way through then to where we are today. And today we are standing in front of a new step in technology where the new sensor technology, LiDARs, ultrasonic sensors, radars, cameras and so on, and software technology when it comes to sensor fusion, artificial intelligence and machine learning, that will make the same type of step and also the same type of, let's say, igniting the innovation spirit in the system going forward. Because all engineers, you that are sitting around here and everyone out there, they will understand that we can do that and that and that because we have that sensor system and we have the new software and the computing power. I mean, the graphic processing units that NVIDIA and others are now doing, they are the ones that will be what we need then going forward to do autonomous vehicles and to really come the next step in the coming years.
Talk about that, the adapting, the software side of it and the adaptability to it, because at least externally, it seems like that would be a semi-predictable, controlled environment compared to, say, somewhere with traffic or anything like that. But it requires a lot of energy to understand what's going on and actually become more efficient over time. What is it looking for, and what are the advances or the problems that you had to solve to focus on that and make sure it would really, it would learn and adapt in ways that would be useful?
Yeah, I mean, of course, while we are starting in the confined areas, I mean, we have been running this in public systems like this in public area also. Then we had a platooning event then going from one place in Sweden to one place in Europe then over a lot of country borders and so on, where you have a platooning event with 3 vehicles, and we have also tested then platooning events between passenger cars and trucks, which is an amazing thing then to run 55 miles an hour with 3.5 meters, and you have one truck in front of you and one truck behind you, and just let the steering wheel go. And it's possible to do that, but there's a lot of legislation that needs to be there, and there is a lot of tests, because all the operational modes you have to have, let's say, to be very sure about that if something happens, you fail safe or you fail operational, so to say. So that is what we are doing right now then, to debug the system, as everyone else is doing then out there, but we are doing that also then in the commercial industry.
Right, and that's these are the redundancies that help ensure something like that, and, keep you safe like that. The other thing I think we can that is uniquely interesting from your perspective is you started at Volvo in 1979, correct?
I did, yes.
Working on specifically it was automatic transmissions. Were I to show you something like this or a video like that to a young fledgling Torbjörn and explain what this is and what it does, would that make you say, yes, if I'm looking at what I'm doing right now, I could see that as an eventuality? Or are there parts to it that you're like, there are parts of this that were inconceivable back then that we can now wrap our heads around?
Going back then to 1979 when I started, we were a small, let's say, a startup within the bigger company. But of course, if you are, as I was at that time then, 24 years old, you think that everything is possible. So if someone would have told me that, please go out and do a autonomous vehicle, okay, let's start and try to see what we can do. But at that time, we didn't have the computing power, we didn't have the sensors, we didn't have the actuators, and so on, and we didn't have the software technology that we needed. So we started what we thought was a big step at that time. And then we have added, let's say, continuously up until now. I think we are in front of a new, let's say, a step change, because it was a step change when Intel came with 8085, the microcontroller that was done for, let's say, embedded systems, mechatronics, and real-time systems. I think we're standing in front of something new now, and I mean, the future will tell, but I would bet on that we will have, if you could call it then, the dronification of the society. We will have big drones like load-carrying systems that was in the past a truck, and we have smaller drones and so on, and going forward, the flying drones. That will be what we will see then going forward.
Yeah,
so.
I think that makes a lot of sense.
Yeah.
And I guess the thing that, at least editorially, requires a little bit of explanation too, is that it needs to be, I guess people want to understand it as being a giant, very drastic leap, but these iterations that are signs of progress, like outfitting an otherwise typical looking industrial truck with all this subdermal technology that's making it do a job that is not just augmenting what a human being would do, but actually affects how a given task is conceived of in certain ways. And I think that's, if I understand, that's a big part of your job too, is understanding what that will look like for somebody.
I mean, that has been my life for many, many years. But just so that you know, during my almost 40 years in the industry, it has always been the case that now this is something groundbreaking every time. But if I'm looking back and if I'm looking forward, of course there are some things that are step changes, but the real thing is then that you as soon as you have something new when it comes to technology, the imagination starts then to work, and all of a sudden you have a lot of other things then coming up, and that's extremely interesting and rewarding then going forward. And I think this is also a part of then solving the issue with sustainable mobility going forward. We need mobility, absolutely. We need more mobility than to fight poverty and to distribute wealth in the world. But we need to have it sustainable, and that is the challenge for my industry and myself and my company going forward.
Excellent. All right, thank you. Thank you for your time. Thank you
very
all
much.
for listening.
Yeah.
So on May 16th, they've got a big announcement. Please.
Thank you.
All right, thank you very much.
In our ever-buzzing transportation ecosystem, sensors are everywhere, gathering an unprecedented amount of data. And if you go back 4 years, just to give you the scope of how much data we're collecting, in the 2 years prior to 2013, there was more information and data created than in the history of humanity leading up to that point. And the reason why is because we are embedding sensors in everything right now. Just look around. Now, the CEO of GE Transportation is about to take the stage next to explain how their growing global company is working to make the rail system more intelligent and partnering with cities like LA to revolutionize our ports. Now, put your hands together for IEEE Spectrum's Evan Ackerman and GE's Jamie Miller.
Thanks, Evan.
Thank you very much. I'm Evan Ackerman. This is Jamie Miller. Let's just get started. Can you... Sorry.
Maybe start over.
Okay. Anybody? Nope, no mics? Okay. Well, can you just explain what GE Transportation is? If you folks do. About
3 and 4.
Okay.
3 and 4.
Quick fix.
There we go.
All right, how about now? Okay, great. So Jamie, can you just give us some context? What is GE Transportation and what do you folks do over there and why is it so exciting right now?
Sure. So GE Transportation is one of the divisions of GE, and it's really one of GE's most iconic businesses. You know, it's been around for more than 100 years. It's really locomotives, mining, services, and digital. And I think what we're really excited about is really how sensors, data, AI, and other things are really starting to transform the transportation industry itself.
And so you were CIO of GE just in general, and then you transitioned to CEO of GE Transportation. Can you talk about what that was like and kind of how you had to shift your mindset there?
Sure. So, so when I was CIO of GE, you know, 4 or 5 years ago, we were really leading the transformation inside GE to things like cloud computing. We really, you know, sort of built and launched the digital industrial vision that is defining GE today. And You know, it's interesting because as CIO, we were driving that transformation inside the company. When you think about our factories and this idea of, no unplanned downtime, inside the company, what did that really mean and how did we really do it? But as I've come into transportation, it's really how to think about transforming an entire industry around the same concepts. And, you start to think about this idea of whether it's no unplanned downtime or how do you really take data off of assets and transform how you work. You think about a locomotive. The locomotives we produce today have about 200 sensors. They pull data off those locomotives constantly, and we've got onboard computing that is constantly monitoring not only the health of the engine, how those engine components are running, but it monitors track grade and condition, it monitors the weather, it monitors, all the elements of things that run around the train. So, what it's really enabled us to do is establish this vision about, how transportation in the freight industry can be fundamentally rethought around, how you use the locomotives differently, how you can monitor and run trains in a different way, and more importantly, when you think about the rail network itself, how do you really get more trains running at a higher speed, to be safe, reliable, and predictable in ways that they can't today?
So I would imagine that a lot of this sensing that you're now able to do comes from this mobile and IoT infrastructure that's growing up. So what kinds of data are you able to collect now that you weren't before, and then how does that translate into tangible improvements in the rail sector?
Yeah, so we've been monitoring our locomotives for about 15 years now. So this is not a new science, inside GE. But I think what has changed is we're able to get more data, more of it, more kinds of it, and we're able to, combine it and fuse it in ways that we never have been able to before with all kinds of other data in the environment. So. Take a locomotive. When we pull that data off in real time, we're constantly monitoring it. So we monitor, today 17,000 locomotives around the world in 23 countries, from one location in the U.S. And when we monitor it, you constantly learn more about how that locomotive runs. So you're constantly tuning the performance. You're also able to predict, when something may fail or when something needs to be maintained, or equally importantly, when it comes in for routine maintenance, we tell our customers not only exactly what needs to be repaired, we also give them the work scopes for that, and we can be a lot smarter about making sure that, all the real-time delivery of the parts required to do it can happen just in time. So it's sort of a top-to-bottom sort of transformation of how the work happens in a much smarter way.
And are there examples that you can give of this has actually made a huge difference for people?
Sure. So, one of our customers, CSX, we've actually implemented something we call smart shopping in one of their service shops. And take that exact example I was just talking about, it's really reduced their dwell time by about 50%. And dwell is really important in the rail industry because it's the amount of time an asset sits idle while it may be pulled offline for maintenance. So that's, I think, a great example there. But when you take a step back and look beyond just, so that asset, and you start to look at, the rail network generally. So, railroads have, thousands of miles of fixed investment in track. And so this idea that if you know where these assets are and what cargo sits on them and when it's supposed to get to its destination, and if you could take your knowledge about the environment and where those trains are and combine it with your knowledge about the train itself, you're able to put software and AI around that to really improve the velocity in your entire network. So we have products like Movement Planner, Yard Planner that actually do those kinds of things. And we've got railroads running on that today.
And this is true not for just railroads, right? You folks work with all kinds of transport solutions, and I know that you're doing a pilot project with the Port of Los Angeles, right? That's implementing a lot of this stuff in kind of a much broader way. So how's that going?
Yeah, the Port of Los Angeles project is actually super exciting. When you think about cargo, 90% of the world's cargo hits, a seagoing or an ocean vessel at some point in its life. And so you think about seaports, they're an incredibly important and vital part of really a freight transport ecosystem. And they're interesting because they're really typically capacity constrained. They have a stretch of land that typically can't be expanded. They've got a certain set of assets and rhythms that surround it. You think about chassis operators, you think about terminal operators, you think about railroads who have to schedule trains, trucks that have to schedule trucks coming out of a seaport. Well, today, when an ocean vessel hits port, and let's take the port of Los Angeles as an example, you know, typically a port won't know what's coming into port, the vessel and what's on it and where it's going, until about 2 days in advance of hitting port. So you think about, you know, their ability to really plan, and all the railroad, the chassis operator, all of the suppliers' ability to plan kind of how much load will I get, where is it going, how do I plan, how much equipment is needed to actually transfer it. It's a very inefficient process today. So we're working with the Port of LA on a pilot project right now that's really going to expose and automate all of that data in ways that wasn't able to be done before. And so we're going to be able to take that data in 2 to 3 weeks in advance of a ship coming in, expose that to the partners, which is going to enable just a different reduction in dwell time, you know, the ability to have the right equipment on site when you need it. And so if you think about if you had, you know, 100 chassis when you only needed 80, you can redeploy those assets in other places. And so we're seeing some really exciting results as we launch the pilot right now. But it is all about reducing dwell time, leveraging assets in a different way, having just a much different turnaround time and experience, and much greater efficiency in terms of truckers, railroaders, ports, terminals, you know, all the people that participate in the process.
So if I have a company that is not, that doesn't have a nationwide rail network and doesn't have a port, a much smaller company, are there lessons that I could learn from what you folks have gone through?
You know, absolutely. You know, I think whether we're in transportation or in my role as GE CIO, you know, we work with startups all the time, and we work with small companies all the time. And, you know, I think there's one thing we keep in front of us all the time, which is as we go through this sort of transformation into just the next generation of what it means to be an industrial, I think it's important to know that you really can't do it all yourself. You need partners. And I think that goes for big companies, and I think that goes for small companies. And I think it is really important for any company to deeply understand what expertise they have, what domain they deeply have, and where they need a deep partner to help them both create and ideate, but really transform together forward. You know, we used to laugh when I was the CIO, because we used to keep this, you know, big roadmap of, you know, exactly where we were looking to see transformative technology, you know, how and where we wanted to really push the envelope. And we worked with a lot of startups, and it was great because on one hand, you know, we could really work with them to shape their vision, and they could move a lot faster than we could, and great partnerships. On the other hand, you know, I used to joke with them and say, you know, be careful what you wish for, because, you know, sometimes we can also love you so much that we break you. You know, so but I think the point is that you've got to find the spaces where you can both go fast and go slow, and you got to know when to do it, which way, and you got to know what you're good at.
Are there near-term technical advances that you folks are looking towards that you think are going to transform the industry, either a little bit or a lot, over the next, say, 5 to 10 years?
You know, look, I think like any industry, transformation in freight transportation tends to be generational. And so I think, you know, right now it's all about how do you have, we have a GoLink platform which we put on a locomotive, which we call the brain of the train, right? It is the mobile data center which pulls the data, it processes data on the edge, it sends controls back to the locomotive. You know, companies are really, I think, putting in front of them what does being a digital railroad really mean. And, you know, this idea that it's about getting more out of your CapEx, it's really leveraging your OpEx in different ways, and you know, getting those trains to be more reliable, predictive, is really the vision that's in front of them. So when you think about near-term technologies, it's not only the hardware, but it's also cloud computing, it's edge computing, you know, and the ability to intersect with big machines in ways that nobody's been able to do before. It's that intersection of sort of the physical and the digital that I think is really the sweet spot right now.
Well, how do you think that autonomy is going to affect both the kind of rail and otherwise? Because, you know, whether you look at it from the perspective of autonomous trucks may take over to some extent from the rail industry, or whether autonomy makes its way into the rail industry, how's that gonna look?
You know, look, I think you know, freight and rail have important places in freight transport. Actually, it's trucking and rail. But you know, rail is a very, very cost-effective solution for the industry. And when you start to think about autonomous, I think everybody talks about cars, they talk about trucks, And it's something that we all read articles about it in the paper every single day. When you start to look at the rail space, I mean, we have autonomous trains today. I mean, start to think about, airport transit. You start to think about monorail systems at places like Disney World, right? You already have autonomous, trains occurring today and live today, but they tend to be in closed loop environments. You also have them in open environments in Europe and passenger transport and other spaces. If you take a step back, though, and you start to think about freight rail transit, it's kind of interesting because, a freight locomotive can be, 2 to 3 miles long, right? It can be carrying 10,000 to 20,000 tons of cargo. I mean, a locomotive by itself is a 400,000-pound machine. So think about a machine like that carrying that kind of cargo going along the track at 30, 40, 50 miles an hour, right? It can take up to a mile or two of distance just to slow and stop a train. So when you think about knowing what's in the environment, whether it's a car stuck on the tracks, whether it's debris, whether it's a break in the track, or whether it's some other unforeseen obstacle, when you think about spacing of trains, there's all kinds of different elements that come into play when you start to think about, doing something at scale with freight. And I think there's an economic and a regulatory equation too, but the technology is there and it is transforming over time. You just don't hear it talked about quite as much as you do cars.
We do hear a lot about autonomous freight in the context of trucks. There are lots of companies working on that, and there are still regulatory and technological issues, but it really seems like within the next 5 years, that's going to be a big market. How is that is that something that GE is preparing for to kind of integrate that?
Look, I think that's one of the reasons why the concept of the digital railroad is so important, because when you can run more trains with higher speed, more predictably, and really predict the maintenance around the assets so you have no downtime, that's really a way to get more throughput on the same network and compete in different ways. And so while the vision today may be quite different than the vision in 5 and 10 years, because I think it will evolve, and I think this idea of autonomy is going to continue to be very front and center, I think that both freight, whether it's trucking or trains, you're going to see a lot of automation that happens along the way.
So more generally expanding just beyond actual moving of goods, when we talk about autonomy in the context of things like factories and just throughout the workforce overall, how is that going to affect factories in the future or the workforce in the future?
So what you see in factories, factories tend to be very generationally changing sorts of things, right? I mean, these are capital-intensive assets that people typically put in there, and how you work that, tends to be decade-like change shifts. One of the big strategies we launched inside GE probably 3 or 4 years ago was the concept of a brilliant factory. And it was really built around this idea that if we deliver machines for our customers that really have limited unplanned downtime, why can't we do that same thing with respect to our own machines that are in our own factories? And so we set out to really build 7 showcase sites around the world, one of which is GE Transportation's site in Grove City, Pennsylvania. And, look, a brilliant factory from our perspective is something that combines lean manufacturing with additive, with advanced manufacturing technologies, with digital. And so take Grove City as an example. Grove City is an engine plant that remanufactures about 1,200 medium-speed diesel engines per year. So it's a very big plant. And it used to be that when we brought these engines in for remanufacturing, so remanufacturing is basically a repair process, right? You bring it in after it's been on the line for a while, you tear the entire machine down, you remanufacture all of the components, you assemble the engine at the end of it, you deliver it back to your customer to put back onto a locomotive. That's the way it used to work. So today what happens is, because we already know the actual condition of all of the components in that locomotive before it ever hits our shop, we can, when we tear it down, have a purely condition-based remanufacturing repair scope for that engine. We know exactly what components don't need any repair, it can be set aside. We know some that need light repair versus heavy repair, and we align our remanufacturing scope to that specific scope of that engine. And so what happens is we've been able to reduce dwell time of that engine in our shop, or basically reduce cycle time by about 20% because of that. And it means our customers have that asset back in revenue production, that much faster. It also means we can drive more efficiency in our factory. So I think that's an interesting example of what it means to bring it to life. And then when you think about how jobs change, look, I think for the next at least decade, it's not about the replacement of jobs. It's about how jobs shift and how skill sets are needed in different ways. And it's about how if you're a supply chain or a factory leader, you've got to know digital just as much as you know how to run a factory, right? If you're an engineer, you've got to understand how control systems not only control a machine, but how they intersect and use data coming from any other digital realm in ways to make that asset run better. So I think it's this melding of skill sets that's going to happen. And that's really why at GE we've launched a handful of different massive sort of open, online, collaborative, different ways to train our people, to really respond to that.
And how has it been making that transition with GE, which is such, it's an enormous organization with a very deep history, and this is a lot of change happening very quickly.
So digital industrial is sort of exactly that, right? You've got the big physical, physics and engineering of machines, and then you've got really the software side of it, AI and other things with that. And I think, look, software is not something new to GE. I think that's the good news. I mean, we've had deep software domain for the last 30 or 40 years. And in fact, that was really part of the big driver behind this transformation we're leading, because you have this realization of the past couple of decades that, software and data is becoming an increasingly important part of the hardware itself, the part of the machine. And that's really what's behind it. But, when you think about what's hard, look, I think on either side of that it's hard, right? The digital domain needs to understand the deep machine side of it, the physics, how does it work, how does it learn, how does it work in that environment, and railroad operation as an example. The other side of it is that the engineers who have 30 or 40 years of deep expertise on how an aviation, an engine might run on an aircraft, they've got to sit with the digital folks and really marry that knowledge too. So what we found is today it's people working in multidisciplinary teams, and it's side-by-side work to learn and co-create together. I think in the future it'll be that skill set's all going to be in the same person.
Okay, that's awesome. Thank you so much, Jamie. This is all really exciting.
Great, thanks, Evan. Glad to be here. Okay.
So let's end the morning on a less optimistic note. We've heard about AI and technologies that are making our lives much easier, but the promise of AI and digital helpers that are going to change our lives and make everything virtually effortless has been promised and ideated on for more than 6 decades. So let's bring up our next presenter. He says that we're far from getting there, and he's got a few theories and ideas of why. Welcome scientist, author, and the founder of Geometric Intelligence, Gary Marcus.
Where's my magic eye? Hi there. So you might think my title is silly, Artificial General Intelligence. Why aren't we there yet? Because you might think we are already at the point of artificial general intelligence. If you read anything in the media, you'd probably think we're close. Or if you read Harvard Business Review, you might think we're close. Here's Andrew Ng, optimist-in-chief for AI. He says, if you can do anything in less than a second of thought, a computer can do it too. We've gone so far in AI that basically we can automate anything you can do in a second. I'm here to disabuse you of that popular notion. Andrew Ng is partly correct. There are some things that people can do in less than half a second that AI is pretty good at. For example, you can probably tell that that's Tiger Woods and not a golf ball, and we can program an AI system to do the same thing. Good for you, good for the AI system. The way that people have been doing this is with something called convolutional networks or deep learning. I won't go through all of the details, but essentially it's big data in and statistical approximations out. And this is the dominant thing in the field of artificial intelligence right now. It has been for the last 3 years. But perception, the ability to see the world and understand it, is more than just simple categorization. So you might be able to get a deep learning system to look at this picture and tell you there's a barbell in there. That wouldn't be too hard. And maybe the deep learning system could tell you there's a dog there, but that would be a little tricky because the ears are in a different orientation than you usually see ears. And more than that, you almost certainly couldn't get a deep learning system to tell you what's weird about this, right? It's pretty weird that a dog is doing a bench press. You might wonder what that dog's training regime is, how much the trainer costs, or things like that. And no AI system is going to do anything like that. Here's another example. You can look at this. You can look at this cartoon. I don't know if I should say the words out loud or just let you read them. But someone notices that they're not wearing a parachute. Instead, they have a backpack and a fanny pack. No AI system in the world is going to tell you what's going to happen next or why this is funny in a kind of sick way. But I assume if you're paying attention, that you can tell that this person is likely to not be living for much longer. So here's an actual AI system that was on the cover, the front page of the New York Times a couple years ago, created by Google to do captioning. This is something that human beings can do in a second, and so allegedly we should imagine that our AI systems can do the same thing in a second. And on this particular example, the AI system does fine. It says, a group of young people playing a game of Frisbee. Well, that's a pretty good caption for this image. And here's another example, a person riding a motorcycle on a dirt road. But what is totally characteristic of AI, the way that it works now, is that you get a bunch of answers that are right, and then I move you away from the core cases that you've been trained on, that you've got a lot of data for, and things just totally fall apart. So some of you might know Oliver Sacks' books, The Man Who Mistook His Wife for a Hat. Well, here's the computer system that mistook a parking sign with stickers for being a refrigerator filled with a lot of food and drinks. So you talk to the people in AI, and they're like, we're really close. And yeah, I know there are a few mistakes. They're like optical illusions. Humans are subject to optical illusions. These aren't optical illusions. These are hallucinations. These are cases where the system isn't even close. And if you think about that when you're driving, well, what happens when you have a car, a tractor trailer that crosses a road? Well, the system hallucinates that that's a billboard and somebody dies. It's a pretty serious problem. What do you see here? You probably see like a pattern of yellow and black stripes, orange and black stripes. But if you're a deep learning system, you see a school bus. I show you this one, what do you see? I know what you're all dying to say. A digital clock, right? Well, no, but if you were a deep learning system, that's what you would say, if you were AlexNet, the most famous net. So here's what Andrew Ng said. If a typical person can do a mental task with less than 1 second of thought, we can probably automate it using AI either now or in the near future. That's the optimistic view, and I want to give you a dose of reality. And so this is how I would think about it. If a typical person could do a mental task with less than 1 second of thought, and we can gather an enormous amount of directly relevant data, we have a fighting chance to make an AI system that works, so long as the test data aren't too terribly different from the training data, right? So you have input examples and output examples. If you've got a whole lot of labeled examples and they're close enough to what you need, then maybe you're okay. And if your domain doesn't change too much over time. Well, think about AlphaGo. I imagine you've all heard of AlphaGo, right? This is the world champion in Go. It's exactly the opposite of what I'm talking about here. There's an infinite amount of data. Google's computers can just keep playing Go over and over and over again, and that's what they've done. They've played millions or tens of millions, maybe hundreds of millions of times, machine playing against itself. So you have essentially infinite data, and the game never changes. The rules never change. So what works for Go doesn't necessarily work for the real world. If you're talking, for example, about driving, and you have cars that are dealing with different environments, or if you talk about domestic robots, which we'd all love to have, that would take care of our children and our dishes. So a lot of what we want to do with AI actually remains out of reach despite all the hype. So speech recognition, all the things I have here in green we can do. You can do speech recognition in quiet rooms. Speech recognition in this room probably wouldn't work that well. If you tried to have Siri transcribe my talk, I'm not sure how well it would work with all the background noise. We can do image recognition as long as the set of objects that we're trying to recognize is limited. We can do natural language understanding in narrow domains like sports scores, but that doesn't mean we can do natural language for anything you might want to ask a machine about. And we can do advertising targeting. But there are lots of things we can't do. We still don't really have conversational interfaces. Anybody who read the news today might have noticed that Zuckerberg is going to hire 4,000 more people to screen videos to see if there's violence in them. I mean, why in 2017 can't he have an AI system do something as basic as that? We still can't do automated scientific discovery, which is what I really care about as a scientist. So I would like for AI systems to help us understand the brain, for example, but we're not really there yet. We're nowhere near to building domestic robots. We're probably not all that close to safe, reliable driverless cars. The way I think about this as a cognitive scientist, someone who studies natural intelligence but also works on artificial intelligence, is there are many things that go into intelligence. There's perception, there's common sense, there's planning, there's reasoning, and so forth. And the only thing that AI is really any good at right now is perception. And that's great. We've made real progress on perception in the last few years, but that doesn't mean we're anything close to conquering the problem. So my biggest fear about AI is not Skynet, right? Everybody is worried about the Terminator and so forth, powered by neural network. I'm not so worried about that. What I'm worried about is getting stuck. So you can think of there's a landscape, and this is how machine learning actually works. There's a landscape, and you're trying to crawl down that landscape. By taking small steps, you always go down, you never go back up. But the problem is you can get stuck, and you don't actually get to the bottom of the mountain where you want to go. And if that happens, then we might never make real progress in AI, and that would be a shame. I mean, it's great that AI can do a great job targeting advertisements and prioritizing search queries, but there's so much more we could do with AI if we could get it to actually work, if we could get the flexibility of human intelligence. But if we can't, we might never build machines that can really read. We're still a long way away from that. Chatbots aren't really working yet. We're a long way from getting machines that can help us discover cures for cancer, how the brain works, and so forth. So you could look at the field and what it has done as what people in the field will call gradient descent through model space. We're getting a little bit better each year. And that's been true in object recognition, that's been true in image recognition and so forth. But it's not true in every domain. So for example, in natural language understanding, I don't think we've really gotten appreciably better. And common sense understanding, I would say also we haven't gotten much better. So the fundamental risk is that we might spend a lot of time working on things only to hit a wall. So if we use the same approach over and over again, which is basically what the field's doing right now, there's a risk of asymptoting a long way from perfection. In some domains, that's fine. So if I have a recommendation engine that's 97.5% correct and 2.5% of the time recommends a book or some song that you don't like, so what? So you buy a song you didn't like or a book you didn't like. It's no big deal. But if I have a pedestrian detector that's 97.5% correct, now I want to see if you're paying attention. What happens if I have a pedestrian detector that's 97.5% correct? A lot of people die, right? You know, if you scale that up to a fleet of cars, it's a disaster. Same thing with a domestic robot interacting with live humans. So imagine you've got an elder care robot that's taking care of your grandfather, and 39 times out of 40, it manages to pick your grandfather out of the bed and put him into the sofa. And on the 40th time, well, it drops him. Too bad. AI is not reliable, right? This would be a disaster. So why aren't we there yet? Now that I've convinced you that everything is overhyped, well, here are what I think are the impediments. Number one is engineering with machine learning is actually really hard. Peter Norvig gave a great talk about this at MTech a year or so ago, and he talked about how it's difficult to debug machine learning, it's difficult to revise it incrementally, it's difficult to verify what's really going on. So we have no procedures at the moment for reliably building complex cognitive systems. We just don't have the engineering tools for that. Related to this is a great paper called Machine Learning, the High-Interest Credit Card of Technical Debt. It was written by John Scully's nephew and some other people at Google. The second problem is statistics are not the same thing as knowledge. So this picture comes from the cover of an article in ACM that Ernie Davis and I wrote. And what you see there is a robot that is cutting off the wrong end of a tree limb. Now, what's going to happen to the robot? Well, you don't need a lot of trials to figure that out. You know the robot is going to fall along with the wrong side of the tree limb. You don't want to have your system be a learning system that tries 100,000 tree limbs in different orientations with different kinds of chainsaws in order to acquire that fact, right? Statistics is not the same thing as knowledge. Then there's a problem, which is that everybody in the field wants to start with a blank slate. They want to start with a system that knows nothing at first, and I have no idea why they want to do this. If you look at biology, this is not how biology works. Now, nobody ever believes this about humans. Everybody thinks humans start at blank slates. I think that's totally wrong, but I will take the things out of that context and show you instead an ibex, a baby ibex. And so you have an animal here that's, I don't know, a few hours, a few days old, climbing down mountains, right? This is one trial learning, or it's really zero trial learning, right? The ibex falls once, and that's it. It's over, right? If you fall off the side of a mountain. But the ibex doesn't, right? It is born with sophisticated navigational systems that help it understand rocks and understand the gravity and the shapes of the walls and so forth. For comparison, right, that's an ibex. Here's a robot. So you can watch more of that on the web, but how can we move forward so that the robots are more like the people? Well, one thing I think we need to do is to look at CERN, which is a model of international collaboration where you have thousands of people working together, billions of dollars invested towards a common cause. So right now, most AI research is done in industry where people are pursuing short-term profits. And that's good for those individual companies, but it might not be getting us to where we have automated scientific understanding and other really important advances. The second thing I would say is that we should look towards children. These are mine. Chloe on the left, Alexander on the right. And children are phenomenal learners. They learn with tiny amounts of data. In a couple of years, they master all of human language way better than any AI system's ever done. Common sense and so forth. And I'll just give you one example from my daughter just before she was turned 3 years old. She will turn 3 years old in a few weeks. And she made a little artwork, and I said, why don't we put it in Mama's armoire? And here's what Chloe said. She said, that way, if we put the artwork into Mama's armoire, that way Mama doesn't see it. But when she opens it, she can see it. And I think if you look just at that one example, it's light years ahead of what we can do with AI systems. So my daughter was able to infer the intent behind my proposed plan. She was able to articulate the reasoning behind it. She was able to understand a potential future without doing a lot of trial and error learning. Like, she got how the world works and how people work. She understood why this is interesting. She got a theory of mind, understood that Mama can't see through walls, all of this kind of stuff. And for comparison and fairness, I asked Siri the same question. I said, what happens when you put artwork in an armoire? And this is what Siri gave me. Okay, I found this on the web for what happens when you put artwork in an armoire. And the top hit, pawning this off to Bing, was what happens if you break an artwork, which has nothing to do with the question that I asked. So I will end with a rhetorical question, but an important one, which is, isn't it time that we learn more from human beings? Human children are such spectacular learners, and they're not doing it by having petabytes of big data. They're doing it by having some background about how the world works and filling that in, trying to understand the causal mechanisms that make the world work. When we understand that, then we'll be able to build real AI. Thank you very much.
Thanks so much for checking out the unbelievable talks this morning. Come back later on today at 1:20 for the afternoon sessions focusing on AR, VR, drones, and robots. I'm Adam Zuckerman from Discovery. Go Shark Week, and enjoy your lunch.
Bye. Welcome back. Are you guys loving Collision in New Orleans? Well, you guys are in for a treat because we have an exciting lineup for you this afternoon. We're going to do all kinds of interviews and conversations around everything from flying cars. Who wants their flying car they were promised many years ago? We'll figure out where those flying cars are. We're going to find out how soon we're going to get groceries delivered to our front door. That's going to be great. We're also going to be learning about these robots that are going to be coming into the workforce. Are they going to be taking our jobs? Or are we going to figure out a way to work together with them? So we're going to talk to lots of great speakers tonight. And the companies are going to include Porsche, Anki, SoftBank. They're going to take a crack at these big questions and help us understand where we sit with our silicon brothers and sisters. Up first, though, we're going to talk about the impact of the fourth industrial revolution. So taking to the stage, we have the Chief Technology Officer of the massive firm HP, and he contends that by blending the physical and the digital worlds, it's going to have profound consequences on our planet. He's going to talk about the rise of smart machines. He's going to talk about immersive computing and 3D printing. And it's going to transform the way we build and the way we live. So here we got an approach to sustainability using technology that they're going to discuss in an interview with Bloomberg's Keith Perrine. Please welcome Shane Wall.
Hi, everybody. Hi, Shane. Why don't we start by having you tell the audience what you do at HP? Yeah, so so I'm the Chief Technology Officer for HP, and in that role, I'm really responsible for the future, and that is where we're going, what our strategy is for the future, and as part of that, I run HP Labs, which is the oldest research institution, commercial research institution in the Valley, in Silicon Valley, and then I run HP Tech Ventures, which is our venture capital wing.
And tell us a little bit about blended reality. What is that, and what is it going to look like in the future?
Yeah, so blended reality is our vision that we've established about where we think the world's going. And it's a simple concept, it's just the idea that our physical world, the people, places, and things around us, will become inextricably entwined with our digital world, with how we compute, how we communicate, how we analyze, and when the two work together in a mutually reinforcing way, then you achieve, I think, solutions that will help mankind. The one thing I will add on it is where we came up with it is through work we do on kind of visioning long term, and the way we do that is by looking 30 years in the future. We don't look incrementally 2, 3, 4. We try and place ourselves 30 years in the future and look at the socioeconomic, geographic changes that occur in the world around us, and then figure out what are the biggest problems in humanity to solve.
Now, manufacturing is becoming increasingly digitized. What are some of the trends you've observed there?
Yeah, it's interesting because we talk about the fourth industrial revolution. When you look at what we think will happen over the next 30 years, is there's going to be some profound changes in humanity that are going to drive some changes in manufacturing. So one, cities becoming much larger, incredibly dense. By the end of the 30-year period, there'll be almost 60 megacities. A megacity is 10 million people or more. There will be, just this drive towards hyper-globalization, which is going to force products to be developed differently and at the speed of light. And a changing set of demographics, older population, new generation coming in, and then growth in the emerging markets. All of those are going to lead to what we believe will become ultimately the fourth industrial revolution. And that revolution will be a full digital manufacturing. And a little hard to maybe, ingrain, but give you an idea. This is the idea that the front end is already digital. You're doing design. That's moving from a subtractive process to an additive process. Supply chains are already digital, though you're going to watch things like blockchains come into how you manage parts within the supply chain. And then on the back end, that will be digital. And today, that is all analog processes. It's done, send your labor or send your product somewhere to be manufactured, low-cost geo, get it done, put it on boats, and then ship it around the world. And what we believe will happen is you're going to move to a world in which you send it digitally to the locale where it's going to be used. It's personalized, localized, and then it is manufactured on demand in a digital way, fully digital way.
Now, with new methods of production becoming more widely available, how do industries need to change their thinking about production and design, questions like that?
Yeah, I think it's going to have some profound effects on all aspects of society. Imagine a world in which what you do is design anywhere, transmit digitally that representation where it's needed in the locale. And then in that locale, it ends up being personalized, localized, changed. And then there'll be regional within the areas, call them manufacturing centers, but they're essentially, big automated 3D print and assembly locations that are regionalized kind of more within the areas where they're used. And in doing that, it's going to change all manner of things. It's going to change, where manufacturing happens. I mean, big debate going on, obviously in our society about how do you bring manufacturing back to the U.S., or to whatever your country might happen to be. But what I'm going to assert is in that time frame, it will totally disrupt where manufacturing is. It will move manufacturing back to the area in which it's created, where it's needed, because it will force us to think differently about training. Right? You're going to have to train new people. You're going to have a new set of skills in order to adapt to that environment. And then obviously, massive changes in things like intellectual property when everything is digital. Tax law, what now constitutes an import or an export. Government policy about what you can build. It'll have some profound effects, we believe, on society.
What's one way intellectual property might change, or the way we look at intellectual property law?
Yeah, so you know, today we always worry about copy parts in an analog manufactured world, so we always, you know, anybody can go copy something, and then, you know, can be very difficult to track down where it came from. But imagine if what you have is fully digital parts that are represented. You represent the space in what you call a voxel. So every point in a 3D space can be represented by a volumetric pixel, just a description of the part itself. And when you can do that, then what you have the ability to do is do things like digital watermarking, invisible digital watermarking in the parts that you manufacture, or invisible QR codes that can be printed straight on, you know, with the part itself. And by doing that, now you have the ability to track a part that you never could before. So now I know the origin, I know who owns it, I know what printer it came from, I know what rights are associated with it, and now you have a tremendous number of tools by which you can use to, you know, manage intellectual property.
And there are a whole host of other legal and regulatory questions around this future we're all going to embark in. And when it comes to 3D printing, what are some of the other legal questions, such as with product liability, if no two parts are exactly the same?
Yeah, there'll be some interesting, I think, challenges in the design space we'll go through about how do you validate and ensure that the part was consistent with the specs itself. Now, some of that's already happening. I mean, in fact, 3D parts are actually used in manufacturing today, and they have standard ways in which they test out the parts themselves. I'll give you an example. Our 3D product, which is called Multi-Jet Fusion, which is designed for manufacturing and part production. These are machines that sell for $250,000. Half of the parts in that product are printed by the printer itself. It's manufacturing itself, okay? And that's today. So you can imagine when you fast forward 5 years or 10 years, I mean, the changes there will definitely be profound.
And let's talk a little bit about the Internet of Things, or as you call it, the Internet of All Things. What trends are you seeing as we continue down the path to that reality?
Yeah, obviously today, you know, all of us, including HP, you know, have various positions of how we use Internet of Things, how we connect up compute with the communications in order to monitor, measure, control, whatever it might happen to be in that space. But we actually think some of the more interesting things will occur as you go into this fourth industrial revolution, where everything that gets printed can be actually tracked on the internet. Now, it's not I'm not talking about like a consumer wanting to hook up their toaster or some other device and put it on the internet. What I am is talking about very useful techniques where an item that's digitally manufactured that now has a digital watermark embedded on it, you know, you now can track that through the entire supply chain, and that can all be associated with an internet service. So through, you know, simple scanning of a manufactured part, you can now associate experiences that you could deliver via an internet backbone. And some of it, you know, might sound a little funny, but we already do pieces of this today. And so when you kind of look forward in the next 10 years or so, you're going to see this, I think, happen in spades.
How important will be issues such as privacy and data security when it comes to this reality? If the chairs, if the stage, if everything's connected, the internet is everywhere, then that means the security threats will be multiplied even more than they are now.
Yeah, I think you're exactly right, Keith. It's probably the biggest thing that I'm conscious about, that we put significant amount of work on in HP Labs. And they're really the bookends of security and privacy. The good thing is you have more tools now by which in a digital world that you can increase the amount of security on them, but you never underestimate the number of paths the bad guys can take. But I think the more important piece is its counterpart, and really establishing clear privacy rules, and then making sure we honor those going forward. They're key.
who's best equipped to establish those privacy rules? Should it be something the private sector does by consensus, or is it something the government should be involved in?
I think I'm a firm believer in the public-private partnership, and I think you see that work really well in places around the world. I would say probably the leader in that would be Germany, who's done a fantastic job of starting to establish standards with a set of policy papers that are jointly written between government and private institutions, and really kind of paving that path for that next, the next revolution. Other places, probably not quite as far along. Unfortunately, the U.S. Not as far along as it should be, and I think that's where we have to get much more of that private and government partnership that goes on.
And what does it mean for companies like HP and others that there is a difference in the privacy regimes between countries like Germany, the rest of the EU, and the United States?
Yeah, so for us, since we're obviously multinational, we play in just about every country around the world, and so we plug into those very well. So we obviously work a lot with Germany, as well as the EU more broadly, which I think takes a proactive stance. We're actually quite proactive in the U.S., trying to start a set of matching standards that go on here. And then doing the same thing in the Asia region as well, and that's establishing standards groups, driving a set of standards that relate to what the fourth industrial revolution will look like.
And you've written about something called microfluidics. Tell us what that is.
Yeah, it's another piece of when we talk about blended reality. There are kind of four main pillars that we think will have massive impact on the world. And these are ones that we think are profoundly changing in society. There's the digital manufacturing we've spent a lot of time on, healthcare and solutions for healthcare, how you alter the healthcare curve and how you can use technology matched with our physical world in order to balance is the second big one. And then efforts in this Internet of all things, as well as in hypermobility. Like, we really think we're at the tip of the iceberg in terms of what mobile means. But to your question on microfluidics, when you look at the healthcare one, we have to do something to significantly alter the healthcare curve. And one way to do that that's becoming quite interesting is microfluidics. And that is the idea, of being able to move fluids in incredibly fast, precise, incredibly low volume manners. And then from that to be able to do, all sorts of tests and assessments and observations on the fluid you move. Now, why do you care about that? You care about that because that's essentially what you're doing with all of your blood tests, your saliva, your urine, any bodily fluid. And today that's all centralized. And it's all done, in very old pipetting technology, and it takes an incredibly long time. But by taking microfluidics and then pushing the cost to 1/10 of what they are, and moving that out to the edge into more mobile diagnostics, mobile testing, you can significantly impact the cost of what it takes to do drug development, tests for various diseases, and it might sound kind of out there, but you do it all today, right? If you're a diabetic, you test that on a regular basis, and it moved from a central lab out. The pregnancy test, right? Eons ago, that used to be centralized. Now it's just you buy something and you test. The same thing's going to happen in the world of tuberculosis, infectious disease, superbugs. All of this will move out to the edge.
So should people be worried about data security there? That sounds very revolutionary, but on the other hand, there's a lot of really private information, to say the least, that's going to be moving around in that world.
Big. That's a really big one to focus on. And within HP Labs, we have 4 big labs that focus on, one of them is on emerging compute models, one is on 3D digital manufacturing and the future print technologies associated with it. One is on experiences, which is much more user experiences. But then the fourth one, and it really is the statement to what you're saying, is in security. It is focused on cutting edge security and everything we can do on that aspect. It is front and center of everything we do.
So as we head into this new industrial revolution and technology becomes even more interwoven into the future of our world than it already is, how can we reduce the environmental impact?
Yeah, it actually opens up a new set of possibilities for us. HP has, for a long time been one of the global leaders in sustainability and are pretty well recognized for the work we did. A lot of that was rooted in what Bill and Dave, Bill Hewlett and Dave Packard did when they formed the company. And so that remains at the forefront of what we do. But what we really like about this move to a digital manufacturing and the ability to print on demand is the impact it has upon society, that it has upon sustainability. I'll give you an example. In the current manufacturing revolution, just the act of manufacturing our products in one location, sticking them on in containers on ships and shipping all of our products around the world to where we need them, that one thing alone consumes 5% of the world's oil supply. And the great thing about a world of which when you manufacture local in a digital way is you eliminate so much of that, right, that you save on that side. And then the parts that you actually can produce are produced on demand, right? So there's no longer stockpiling massive inventories. Think of the car company who, today has to carry, depending on the country, 10 years of spare parts. Well, that's money on their balance sheet, it's taking up space in a warehouse. Well, imagine if you can just do that on demand. You get rid of the warehouses, you're using minimal amount of materials itself, much more efficient. Now that's the great thing about that direction, is it's truly fundamental.
So when you talk about how manufacturing is going to change like that, it seems like the future of work is also going to change. You talked a little bit about the need earlier about the need to retrain the workforce and reorient them. What sort of changes will that mean if everything is manufactured where it's needed and if you don't have to move around? It does consume fewer resources, but it also consumes fewer man hours.
Yeah, it does. And just as technology has from the very beginning, technology fundamentally changes the nature of jobs, and every technology that came out, you go back to the automobile, right? There was always the statement that all of our jobs will go away, and which usually proves to not be the case. It actually expands jobs, and that will happen here as well. But the nature of those is going to change. You'll be, when you have factories that are running in a digital way and they're all spread out in the locales in which they're used, you need operators for them, you need people to understand how to maintain the machinery, a tremendous amount of computer skills to do it, and that is going to require development that has to occur in the early times, and it has to occur later on, in terms of retraining as well. But yeah, the workforce will significantly change.
And we're almost out of time, but I know you're a drone enthusiast. I want to just ask you quickly what you see in the future for drones as AI becomes even more integrated into its operations. What's that industry going to look like in the next few years?
It's another fascinating area now. I'm a drone geek, no doubt. I think I'm up to 18 drones at this point. And I'm always changing, modifying on my 3D print pieces to them. I do everything with them, right? But to watch kind of the evolution that's going on in that space is tremendous. And I think you're going to watch, you see the footprints of some of the changes that are coming, right? You have to register your drones now, so now they know who owns them. I think you're going to watch that probably accelerate, and then you'll have to have licenses associated with them, and then they'll have defined paths in which they can travel, and a lot of the things that develop, just like when we started flying airlines around. All planes have tail numbers on them, right? All drones will have registration with them. So it'll be a fascinating area to watch over the years.
All right, well, this has been a really interesting conversation. It's all the time we have, but thanks very much for sharing your thoughts.
Perfect, thank you.
Way to go. So we'll be talking more about drones after the conversation that's coming up. And I gotta tell you, this is a really exciting time for Collision and the AutoTech stage. We're gonna have a first here. This is the first time we're gonna have one speaker sit in another speaker's lap. Instead of keys, our next two companies have been hard at work testing a peer-to-peer car sharing service that allows smartphones to let drivers access their vehicles. It's just another step to make our cars more connected and can lead to greater urban mobility, our next two speakers say. So please welcome to conversation with the Wall Street Journal's Stephen Rosenbusch, the Get Around co-founder and chief marketing officer Jessica Scorpio, Toyota Connected CEO Zach Hicks, and Jessica's dog, and the actual mascot for Get Around, Indy. Welcome.
Welcome. You know, we hear a lot about the future of transportation, and the discussion always involves autonomy and artificial intelligence. You know, this particular model is focused on data, and we're going to talk a lot about how data informs the future of transportation in a sustainable way. And first, I just want to talk a little bit about how these really interesting companies come together. Jessica, you founded a company called Get Around that takes the idea of peer-to-peer sharing and brings it to the automotive market, where the idea of ownership, it's my car, is really deeply rooted. And Zach, you know, you as the CIO of Toyota North America, you moved into something entirely new at Toyota, and that is a data science company, something that most large automakers just don't have. So let's start talking about how you see personal mobility evolving during the next few years and how data science informs that. Jessica, why don't we start with you?
Yeah, thanks. Well, it's great to be here. This is a really hot topic, and we're doing a lot of fun stuff in the space, so it's exciting to talk about the future of cars. Basically, for us, we are tackling a problem we call car overpopulation. Essentially, there's 1 billion cars on the planet that sit idle 23 hours a day. And sharing cars is the biggest way to take CO2 emissions out of the atmosphere and enable people to live car-free. So what we've done is we've created a platform for people to share cars. We've passed legislation, created custom hardware, and we've really created this movement where we have 500,000 users now in a number of US cities sharing cars.
Now, I have to ask, how do you bring order to that? Now, it's difficult for me to coordinate lending my car to a neighbor or lending my car to a family member. Mm-hmm. How do you coordinate millions of people potentially exchanging vehicles for very short periods of time?
Yeah, well, it all comes, like our secret sauce is in the technology and the experience we've created. So basically we have hardware technology in the car that can make any car connect to car. And also it makes it that the owner just has a calendar that they keep up to date, and if they're not using it, anyone can use their car. So they're really trusting us as the brand that these drivers are safe and that we have top-notch insurance and processes for handling any situation.
Zach, from your perspective as the head of a unit owned by one of the largest, not just automotive companies, but companies, period, in the world, how does this all sound to you? Is it completely alien? Does it turn everything upside down?
Well, it's not completely alien. The ownership models what we're seeing are changing. People's expectations of transportation certainly is changing. You know, I don't know if anybody has the exact answer yet, but what we do see are certain components about connectivity, understanding where your car is, what condition that vehicle is in, and being able to share a physical key. So if I want to be able to share my car as an owner and park it on the street and have somebody else come and get it and use it for the day, I don't want to physically meet them, hand them my key. And then longer term, we want to be able to have Amazon or other companies be able to deliver to your vehicle when you're not there. So these mobile type apps that give you a new experience with your vehicle and a new way to interact with your vehicle are critical to us.
Why Get Around? You could have partnered with any number of companies in the space. What was interesting about this opportunity?
Yeah, so I think it's important to understand when we formed Toyota Connected, we were focused on, we've got all this tremendous data coming out of the vehicles. How do we unleash that data to make the customer have a better experience with their car? And our mission at Toyota Connected is to free us from the tyranny of technology and make driving a more human experience, or technology a more human experience. Today, technology, for the most part, isn't great. You've got this app by app or device by device experience. It needs to be contextual, it needs to understand where you're at. And when we partnered with Get Around, what we saw, which was great, was their ability to understand the marketplace and to pivot. One of the first use cases we saw was that there were power users on the Get Around market space leasing a car, a Prius, for $300 a month, parking around San Francisco and making $800 a month. That's really powerful. And when we abstract that a little bit further, we can see, well, our dealers have used inventory sitting on their lots. Why couldn't they participate in this marketplace? So partnering with GetAround gives us a great partnership and a place for us to try out. And we're putting 100 vehicles into their pool. 60 are owned by Toyota. The other 40 we're partnering with new car owners who may want to split the revenue, where it can help offset their car payment. Revenue would go to GetAround and revenue would go to them as well. So we're also getting a chance to kind of learn how to, new business models and how to pivot.
And one thing we're trying to do is basically, cars haven't really changed in the past 100 years, and now there's this big shift towards access to transportation over ownership. So our vision for owners is, like you were saying, it's a better experience to have your car and have it on GetAround than to just have it for yourself. So we can make it easy to have it maintained, clean all the time, and then your car pays for itself. So you may have that Prius, or you may be able to afford a higher end Lexus because you have the GetAround income.
The car has been described as one of the most lethal things that we own. It kills people, it pollutes, it sits idle most of the time, and it costs a lot of money. So how do you begin to turn that around?
Yeah, I think, what we're seeing is, like, one of the reasons we were so excited to partner with Toyota is, as the car makers go, you guys are really innovative in terms of putting safety technology in as a default. And like one thing we try to do with GetAround is to get the cleaner, greener vehicles on the platform. So if you are sharing your car, you can actually turn it over quicker rather than keeping an older car and driving it around. We basically reduce vehicle miles traveled. When you start sharing your car, you go into this mindset where you don't need to drive it all the time, whereas when you just own it, you actually try to drive more because you're paying for this depreciating asset. So it's kind of a lot of different things, but I think it really comes from a shift in behavior with customers that will only be supercharged once we have self-driving cars.
Zach, I have to wonder, you're basically taking capacity out of the system, and what does that do to sales?
Well, I don't know if that's what we're seeing, or what our goal is to not sell less cars. I mean, we want to sell more cars, but we sell, and we also sell the most efficient cars on the marketplace today. But what we do want to do is give our customers a choice. Customers will drive what experience they want. And we get that question a lot about, say, Uber. We're saying, is Uber is hurting? Well, actually, the biggest manufacturer in that Uber space is Toyota. So they're buying our cars more than anyone. So we're seeing sales. But what we want to do is give customers freedom of choice. You may own a car differently in the future. So maybe you have one permanent car that you have, or maybe you have a subscription to a vehicle in the future where during the week I want to drive a Camry and on the weekends I want to drive a sports car. Those models may be an opportunity. And what we're getting a chance to try out with GetAround is building a profile. So once we understand your car seat settings, your air conditioning settings, the radio stations, your preset destinations, you should be able to go up to another vehicle and have all of that experience, your profile, go with you on the cloud. You get in the car and your destination's already there, your car seat's in the right position, you can just get and go.
Yeah, and that's what's such a magical experience, because if you can just open the app within a couple taps, get whatever car you want, walk up to it and unlock it with your phone. And then if you have Bluetooth, you can actually just have keyless go, so the car will just open. And so people say it's kind of like magic.
What else do you do with this profile? What are the applications and features that you can build on top of it?
Well, what we're seeing with the data science already, if a customer decides to share their data with us, if we know enough about you, we know your likes, the type of food you like. So if you're driving down the road and you say, I'm hungry, we know that you like Mexican food, and we know there's a Mexican restaurant that's 2 exits ahead of you instead of 2 exits behind you. That's a contextual answer. Or even something as simple as when you get in the car to start, instead of getting halfway to work and realize, oh man, I forgot my cell phone, reminding you when you get in the car to say you forgot your cell phone. So making people's life easier. We know when you get in the car, you've got an 8 o'clock meeting, you're not going to make it, traffic's too bad. So how about we automatically let the meeting organizer know that you're running late? It's just making people's lives better and using their data to help them, not to exploit them or to sell it to somebody else. It's about unleashing the power of that data for a better experience.
How much of that technology is available right now or likely to be available very soon?
It depends upon the model. So on our Lexus vehicles, which are very connected, we can deliver those services pretty quickly. But what we've committed to is starting in 19, all of our vehicles will be connected and constantly connected. And so that gives us the path to be able to deliver these services.
Jessica, as you see the mobility market take off, do you see ownership fading away entirely?
Well, we definitely know that car ownership in the future is more shared. So when you have autonomous cars, it absolutely doesn't make sense to have one car, one driver, since it can be super convenient for that car to service multiple people or multiple families. But we actually still believe that because of our platform, car ownership will stay, and it just depends on who wants to be the owner. So we have fleet partners, we have power owners who have small businesses on the platform. You could imagine that you could go away, but I think certain people really like to have ownership. They take pride in that, and what we've seen with our owner community is they also take pride in the fact that they're helping to take cars off the road by sharing vehicles. So I think who can own may still, it's really just like using the technology to make sure that they still have their perfect experience when they use the car, and other people can also have the same experience.
Yeah. And maybe to add on to the earlier question too, is that once we understand how somebody drives their car, so the next time you want to share your car, having a profile on a potential renter of your vehicle, you want to know how aggressively were they driving the past vehicle. So we can get all of that data, score that type of driver, so then you know as an owner of a vehicle, I'll rent to these people, but I won't rent to those. Mm-hmm. Or the platform provider can help figure that out for you too.
Question for both of you. How do you view advantage from business's point of view? Jessica, what does prevent Zipcar or any other ride-sharing service from moving into a peer-to-peer model? And Toyota faces endless competition, mm-hmm. And all of your rivals can establish data science units. So how do you maintain advantage? And what do we as consumers value in the future?
That's a great question. When we started the company, we had the smartest people in Silicon Valley say, this is a great idea, but it'll never work. It's too hard. You're going to have way too many challenges. And we've time and time again overcome a lot of hurdles that would have brought us down. We've also seen a lot of competitors crop up and go out of business within like 24 months. So we're definitely a survivor, and we've taken this opportunity as a long-term opportunity.
Why did they go out of business in 24 months?
Yeah, maybe function of the raising too much money and not knowing how to deploy it efficiently and not realizing how hard the business is. So we've been at this for 8 years.
What is so hard about it?
Hardware technology, getting the product experience right, understanding the claims process and unit economics, as well as how to avoid security risks and fraud. So a lot of different aspects, but we took an iterative approach. We tried not to grow too quickly. The major things that give us a competitive advantage is that we have patents on our hardware technology and the business experience, and just know-how and speed. So now we're scaling up. We've raised almost 100 million at this point, and just partnering with great companies. We know how to spend it and spend it carefully and create value for the customer.
So where do you see advantage residing in the digital environment?
We spent a lot of time, even today at this conference, talking about autonomous driving, which is cool, it's exciting, but we're all going to get there, and at some point, it'll become a commodity. It won't be a differentiator in the vehicle, but will be a differentiator is the experience, and that ownership experience and the services that you can provide and deliver to the vehicle. So it's important that you honor the customer's data and you do something exciting and cool with it, and that's the opportunity. Today, if a customer is driving outside of their normal route, using machine learning, I can predict with 80% accuracy where they're going, even if they've never been there before. And what I can do with that data is say, it looks like you're going to a Kings game. Do you want me to route you around traffic and prepay your parking? That's a good experience. So it really is about leveraging the data to make a new experience for a customer.
There's an argument to be made that that data will eventually be so valuable that the car itself will be free, much in the way that, say, cell phones at various times have been essentially given away for free. Do you think that that's possible, given the expense of building one car?
We're kind of starting to do that now. So part of our partnership is that your car payment can be paid directly through your get-around earnings. So that's a bit of a twist of how it can be free.
Really?
Mm-hmm.
Very interesting.
Yeah. Because cars generally make more than their car payment when they're shared on a regular basis.
That's something that Get-Around specifically has been experimenting with?
And that's something we're doing together. Yeah.
We're doing it together.
How is it working out so far? Are there actual beta users using this model?
Yeah, we've done various smaller tests in the past, and this is really about scaling it and opening it up to more Toyota customers. It's been very successful. Toyota's our top brand on the platform, which drove the decision to partner. And basically it's exciting to just go get deeper in the ecosystem, partnering with dealers as well as the brand.
Let's say that I want to use my car and 50 other people want to use the car. How do you prioritize everyone's interests?
Yeah, it's really on a first come, first served basis. So if the car is available and you're a member in the network, you can just book it. And so it's, we really work to balance supply and demand on the importance of providing a good experience. So if you have a particular car in mind, like a Tesla or a Porsche or a new Lexus, of course, you could book that in advance, or a lot of people just go for the closest car. So we'll have a car, for example, on every block in our major cities.
One of the familiar narratives in business since forever is that the startup will disrupt the behemoth. We have a startup, we have a behemoth. How are you getting along, and what have you learned from one another?
It's been a great partnership. It's a great test bed for us to try different models out. As you just heard, we put some Lexus vehicles in there, and we saw that we were actually making a small profit on these vehicles very quickly. We didn't anticipate it. I don't know if it'll scale. I don't know how big this will go, but it's a great opportunity for us to dip our toes in the water and to see what works. We're also looking at, so I've got 60 cars that we've bought, and we're putting into the Get Around platform, but the other 40 is we're trying to understand, what do customers want? What's really meaningful for them? Is there a segment that wants? Yeah, it does. I mean, so if you've got now customers that are saying, I'm willing to help pay off my monthly note by revenue I'm getting through Get Around, if we embed that capability into the head unit, maybe that's an option for the next time that somebody wants to buy a car that's a little bit above what they can afford. It's a new space for us, but it's worth us trying it out.
Yeah, one interesting thing about selling cars, and you'd know this better than I do, but about 2/3 of people who want to get a car can't because of credit reasons. And so in terms of selling more cars, we can actually guarantee those earnings and enable more people to have car ownership that need it, which there's a lot of people out there.
Yeah, we're definitely seeing that on the ride-sharing side. The average person that wants to drive for a ride-sharing company has actually bad credit. So they've got that problem of how do they get to the vehicle? And so this may be an opportunity that we can, through the vehicle controls, as long as they're driving and paying off their lease or their ownership model, they can continue to drive. But you can also then turn it off if that car is not earning value and it's not being paid.
Are there any examples in the market of this sort of predictive technology, and does it actually work? I mean, we know that peer-to-peer platforms work. Uber works, Airbnb certainly works, but can you point to examples of other companies that have brought this predictive capability to market and actually done something with it? Jessica.
Good question. I mean, I feel like you see this in general, the on-demand economy is a space we're playing in, and I feel like you just see so much predictive intelligence going into shopping, like all the purchasing decisions you're making. I don't know if that's what you had in mind, but
well, in a shopping environment, it's not really a real-time decision. I might buy a book and then Amazon will recommend another book. Oh, you like that book? Well, try this one. But that's very different than saying, I'm driving down the highway, I'm at exit 9, I know that you like a certain kind of food, pull over here.
Well, I can say, I'm sorry, go ahead.
Sorry, I was going to say. Yeah, I mean, you definitely see that already with apps that, apps that you allow to push to you, mostly like Foursquare, Yelp, different things try to recommend things based on your location. So I've definitely seen that in social apps in general. Friends are nearby, like using proximity to kind of make those connections.
Is it more difficult to make those recommendations when I'm traveling at 55 or even maybe 75 miles an hour?
It's not. I mean, we're already doing things today with analytics of ADAS to the cloud, where if we're seeing vehicles going down the road, and if one vehicle swerves around an object, and we're detecting other vehicles swerving around an object, we can take that to the cloud, understand it, and then start warning the vehicles behind them. So in vehicle to vehicle and vehicle to infrastructure, we have to get that. And in order to get to autonomous driving, you have to be able to do that type of processing as close as possible to real time. But our goal isn't to serve ads up to people while they're driving down the road. It's to just make their lives better. So when they say I'm hungry, we know enough about them that it's really from a limited decision set of what we're giving to them. But our earlier question is that we saw in some early tests, if we looked at customer data and we mashed it up with social data, that we could predict when a customer was ready to buy a car. And we then got down to say how many blue Camrys versus white Camrys would we sell in the Boston region. We proved that our predictive analytics were getting better than what our sales department was predicting. So absolutely you can leverage this data to have better insights.
So it seems that both of these ideas are based on the idea that you know everything about me as a consumer, and that's a great thing. How secure is that data, and how short a trip is it from the best thing ever to you've ruined my life?
Yeah, I mean, with great data comes great responsibility,
right.
And we take that very seriously. We've never had a breach. We have so many layers of encryption on the hardware, as well as we actually use Facebook Connect to make sure that people are more secure in terms of how, which is a little controversial, but how people are using their real identities, and we're just going to keep being on the cutting edge of safety.
Yeah, and we were at Toyota one of the founding members and drivers for the privacy principles that we worked out with the automotive industry and working with the U.S. government. You get one shot at this. If you betray a customer's trust, you're not going to get another shot at that. So it's, I think you've heard it from the earlier sessions, it's just paramount. It's got to be the first thing you do. And that's why when you're asked, to your earlier question, you're saying, how fast will we see this in the cars? It may not be as fast as you want, because we want to make sure it's the safest thing that it can be before we deliver to the vehicle.
Great. We are out of time. Thank you so much.
Thank you.
Thank you.
Great insight on the present and future of connected cars. Now it's going to get fun. We're going to disconnect the car from the road. We take from the road to the skies with our next discussion. Now, I've been promised a flying car for a very long time, and these people are going to answer the question of where my flying car is. Please welcome to the stage a discussion that will answer these questions and more around flying cars, drone delivery, and how in the world are we going to share the airspace that's above our heads. Please welcome NPR's Car Talks, Jim Motivelli, in a discussion with Ben Marcus from AirMap, Hidai Mukai from Rakuten, and Rodin Eliasov from A3Cubed by Airbus.
And here we are. Welcome to another great panel. This one we're talking about a subject that everybody loves, which is drones and flying cars. And we have some really novel approaches to this that we're going to be talking about. I think you're really going to learn something on this panel. One of the things about drones is that we're hearing about new uses for them every day. And yesterday I heard about a really great use of drones, which is basically planting trees with them. And they can deliver something like 53,000 trees, plant that many trees in one day, way more than people can actually do. And they can do this in very inaccessible areas. And there's a couple companies that are doing this biocarbon engineering and drone seed. So you probably hear more about drones doing this very useful activity, because every year we lose many, many trees. So let's get started. We're going to go right in with Hidei. And they've done the very first drone deliveries in Japan. And he's going to tell you all about that.
Okay. Hello, and thank you for having me. My name is Hide, and I work for Rakuten. Rakuten is the biggest e-commerce company, like Alibaba of China. Then we provide a lot of IT services like Viber and eBay in the United States. So we did very first drone delivery to the general public at golf course. So we prepared a video about it. So please watch the video. Hopefully it comes. Okay, so golfers make an order on smartphone application, and they can order hamburger or golf ball, and the staff at the depot will pack, then put it on drone. Then staff just press the button to take off, and it will automatically take off, and people do not need to control. It's really autonomous. So it goes to the destination using GPS and land precisely by using image recognition. So this is the real flight for our golf delivery service. Everybody use smartphone to take photo and movies whenever they get things from the sky. So they are very excited. So it uses the image recognition to land precisely, and the box will be released like this. Then it's easy technology, and it flies away automatically. So no human involved. It's totally autonomous. Then the box has the name of the customer, and he can pick it up once drone is away. And for this time, they ordered a lot of drinks. So first, it's canned coffee, and that's Minute Maid, orange juice, and another orange juice. It's really cold because drone will deliver within 10 minutes, and sport drink, and this guy got a snack. So this was the real thing. We did it for 1 month, and it was very well received, and we delivered more than 100 times. So I hope this can be done in the United States as well. So if you are interested, please let me know. Thank you.
Hey, Day, I think you told me the most common thing people ordered was beer.
Yes, right. So beer was super popular, and everybody just ordered 4 cans of beer. And because of the payload limitation, it must be within 2 kilograms. So 4 or 5 cans of beer was kind of maximum.
We're going to move on to Roden from A-Cubed, and they're doing fascinating stuff. They may have a airplane that they're testing, which is going to do autopiloted drone flights carrying human cargo. You'll be able to go up in your own drone, and it will, instead of you having to pilot it, it will autopilot to your destination. So tell us about that.
Yeah, so one of our projects at A-Cubed is called Vahana, and it's an electric vertical takeoff and landing, automated, essentially air taxi. And we are building it today, and it's going to fly this year. The prototype's going to fly this year, most likely without a human, and we plan on moving to certification afterwards to have a product by 2020.
Use dogs like the Soviets did with their
We are not going to use dogs. Our test program is going to be unmanned, and it's going to be in designated test ranges in the US, but we are also looking at deployment for cargo delivery before it's certified for autonomous human flight. And we're also in parallel tackling a few other questions about ground operations and about airspace management with separate projects.
When do you think you'll do the first human flights, or people will be taken?
Per our schedule, we plan on a vehicle that's certified for human flight sometime around 2020.
It's amazing how fast the technology is working in drones.
Yeah, I mean the technology. We don't like to call it a drone, because if you look at the industry, we've had autonomous flight and very highly automated flight for a very long time. So I think the current crop of commercial drones is leveraging that technology at a particular level of reliability and safety. But we've had very reliable autonomy in flight for decades, and really this is just filling the gap.
Now, I noticed that Elon Musk yesterday was quoted in an interview as saying, it's difficult to imagine the flying car becoming a scalable solution. But it sounds like what you're targeting takes a human error out of the equation. You wouldn't call
That's
it
correct.
a flying car, I don't think, but you're doing.
Right now we're sticking with air taxi, sure. But if the question is about scalability, there is a limit to how many vehicles you can safely operate in the airspace. But the truth is that today, the airspace is not really being utilized. It's vastly underutilized.
Well, I think that brings us to Ben Marcus from AirMap, and we're going to talk about really patrolling that airspace, because that's what your company does. And I wanted to point out that AirMap and Rakuten are involved in a pilot project in Japan. They're working together.
Yeah, that's right. Rakuten and AirMap have a joint venture in Japan to provide airspace management services in that country, and we're very pleased with our partnership with Rakuten. But yeah, AirMap is an airspace management platform for drones. And ultimately, if you think about any use case in the airspace, whether that be with people on board or not, that vehicle needs to be able to navigate safely and efficiently, taking account of all kinds of context, not just traffic, but also regulations, and a lot of these are very hyper-local, obstacles, real-time weather, and you take all of this data, you put a routing engine on top, and ultimately you can deliver a safe and efficient route for that vehicle to operate along. And that's what AirMap's all about. If you think about the traditional air traffic control system that we take for granted today for airliners, for example, here in the United States, there's about 50,000 flights per day. There are 15,000 air traffic controllers. Clearly that does not scale to millions of drones operating billions of flights. AirMap today, still a very young company. The drone industry is still being a very young industry. We're already managing or providing services for more than 50,000 flights per day, and we only have 50 employees. So we need a much bigger, more scalable system, and it needs to be able to take account of much more complex context that exists very low, close to the ground, that doesn't exist at 30,000 feet. That's what AirMap is solving.
Ben, you have a background as a flight instructor and a safety engineer for planes and pilot. Do you think drones will be safe, just generally?
Absolutely. I mean, drones already have a far better safety record than manned aircraft. You know, there's, as I was saying before, you know, more than 50,000 flights per day, more flights today than there are manned aircraft flights, and you never hear about a fatality with a drone, right? But just about every day of the week, there's a fatality with a general aviation aircraft.
I wanted to point out that the FAA said yesterday that if a drone hits you on the head, you have a 0.3% chance of getting a concussion, which I thought was pretty good. I mean, the chances of it hitting you on the head are pretty low anyway, but even if it does, assuming it hits you the bottom part first. But let me throw this out to the whole group. What are the uses for drones that we're going to see in the near future? How are we going to commercialize this? Because certainly with electric cars, which I write about a lot for Car Talk and others, there's a lot of test programs, there's a lot of pilots, and it took a long time to get to the point where we were really putting them on the road as commercial projects. And I think, Hide, what you're doing in Japan with a delivery, that points the way towards a commercial product. So let's start with you. Do you see that becoming commercial pretty soon, the delivery from drones?
So, of course, the currently inspection or aerial photography, these are already in place. But drone delivery takes a bit more time because we need to clear the regulation issue. So government needs to allow fly drone over the human. That's not allowed now. So we need to talk with the government to allow them. And also we need to have public acceptance. So people are still a bit scared of drones flying over their home or their kids. So that kind of public acceptance we need to change. And also we need to have better technology. So currently all drones are from hobby field. So we need to have better technology from industry, like airplane maker or automotive maker. So that kind of level of safety and technology needs to be in place.
Okay. Roden, what do you think about the timetable for commercializing drones? Including what you're doing with it?
Well, I think, so your original question was, what are the uses that we're going to see? And I think what's interesting is to look at where can drones provide an improvement in efficiency. A lot of the focus today is on time-sensitive delivery, delivery or travel, right? And
including the last mile, right?
Including last mile. And for us, the focus is on transporting people, and people put a lot of value on their time. A lot of people put a lot of value on their time, and they spend a lot of their time very slowly moving about 30 miles, 40 miles. And I think that is a perfect market opportunity if I've seen one, right? There's a pain point, there's a willingness to pay, there's a massive market, so even a small portion of that market would be a very viable proposition. And so for us, the focus is that gap between commercial drones and small cargo drones and commercial manned flight So
if
medium
you had to
range.
put a year on it and say the point where drones go from being a cool novelty that everyone thinks are great to something that we all take for granted. You see a drone, you don't have to necessarily say, oh wow, look at that. You just say, oh, there goes a drone.
I appreciate you're trying to put me on the spot, but I think the timelines are going to be very different for different business models and for different types of airspace and for different types of drone and mission.
Okay.
And it will depend a lot on the regulations.
Let's ask Ben this. In terms of, if you look at self-driving cars, I think people don't actually realize this, but self-driving cars are going to be held back significantly by regulation and legal issues and safety issues. Is that also true of drones? I mean, if they hit you on the head, they're not going to do much to you. So how much are regulations and regulating the airspace, how much is that going to slow this down?
Yeah, so big drones that hit you on the head will hurt. The FAA information that you quote is for a relatively small drone, right? 2 kilograms. But yeah, I mean, a big drone that hits you on the head is going to kill you, right? If it hits you hard enough. And certainly, if you're sitting on board, a vehicle that's going to have an accident, you could get hurt too. So safety is obviously first and foremost most important thing. The regulators, the traditional aviation regulators, are already managing a very safe airspace, right? We take air travel for granted. I'm going to get on an airplane tonight and fly back to LA, and I'm damn sure that I'm going to land safely in LA. And right, the regulators don't want to upset that existing ecosystem that is so safe. So the tendency is to not innovate in regulation, because if you've already got a safe system, why should you change it? So we need to be persuasive to society at large that there's a lot of benefit to be redeemed by this technology. And then society goes to the lawmakers and regulators and says, hey, please let us take advantage of this activity, this technology. And I think that we're making great progress. Just in the last year, you see major brands like Airbus, for example, Rakuten, airlines around the world. Lufthansa has a whole drone department now, right? So this is becoming increasingly accepted. And I actually think that we have an opportunity to leapfrog self-driving cars at the surface with airborne mobility, because it is relatively virgin territory. We don't have to train the vehicles to learn how human drivers drive, right? Which is a big thing that's holding back self-driving cars. We don't need to train the vehicles to avoid a baby buggy or somebody crossing the street. So I think we have an opportunity to actually move a bit faster than self-driving cars.
But Jim, I would like to challenge this perspective that innovation is always held back by regulation. If you look at regulations for airspace in recent years, like the Part 23 rewrite, I think is just a massive accomplishment for everyone, and it benefits everyone, and it's actually an example of regulators anticipating and enabling what they see coming in a very proactive way, and they wrote it in a way that's very different from the prescriptive regulations that worked for us for decades, because they see that you need something that's flexible, adaptable, that allows innovation to really occur without compromising on the safety that everyone counts on, because Ben's right. We're going to get on planes and we're going to fly home, and we will not worry about it. We just won't, and we shouldn't. And that is key. I don't know how we got to be okay with the accident rate with cars, but we know how to do safe air transportation, and we should not sacrifice that and the standards that we've established in order to do it.
Just quickly, we have 3 minutes left. Do you think that your method of mobility, where people fly single, almost like pods, automated pods, could that replace some of these planes that are going to take us all home from this conference?
I mean, again, it's a complementary set of missions. So what we're interested in, where a lot of the customers are in urban areas, and they're commuting maybe to the airport or to work, and they're going about 40, 50 miles, which is not a mission that any large commercial aircraft would address, or even a Cessna would not really target that. The overhead is just too high, and they...
Would you use it for commuting as an example?
I hope so. I would like to. Yes.
So, Hide, your company, what is delivery pretty much what you're targeting, or are you looking at other areas also?
So, but primary target is delivery. So we are now in the process of developing drone acceptable condominium. So this, 50 floors condominium will have drone port. So drone can land, and from the drone, unmanned ground vehicle will carry parcel to each door. So this kind of really autonomous, very quick last 1 mile delivery will be happening. And that's our primary focus.
And then you can convert that to a vertiport where you can land the pods. So you can just go to work from there.
Yeah, it's interesting. I think the way people live in apartments or houses or in suburbia actually affects how delivery will work for these things. We have to think about it. Like, for instance, electric vehicle charging in China is rather problematic because they don't live in single-family suburban houses. They live in apartment houses, so you have to figure out how that could work for that population. It's pretty different. So just very quickly, say something cool you've never said to anybody else.
Me first? I love you guys.
I've
never met you before.
I really dislike licorice.
Really?
Yeah.
Okay.
I don't admit to that.
Well, it's supposed to be about drones. Okay, we're going to have flying cars. How about that? Let's use that. We have 36
Oh, we're definitely going to have flying cars. But I've said that before.
Okay.
I mean, that's my...
Ben, flying cars?
Absolutely. Actually, that's why I started AirMap, because I do want to fly to work. I hate driving.
Nice. High five.
Hide, flying cars, yes?
Yeah, I want.
Toyota flying cars, Honda flying, Mazda flying cars.
Yeah, so
the Mazda
Japan.
Miata flying car.
Right. So Japan is good at automotive, so we hope we can collaborate and to make this flying car thing happen.
I'll give you my card after this.
Yeah.
Okay, we're about out of time. Hide, Ben, Marcus, and Roden, thank you very much. This is a great panel.
Thanks, Jim. Thank you, guys. Thank you.
So we're going to keep raising the bar. First, we learned about the infrastructure that puts everything together. Then we learned about the car and the road sharing service. Then we went off the road just now and we talked about flying cars. Nobody still has given me a date. I'm going to be pushing these guys backstage to find out when am I flying cars, get them in my garage. But now we're going to be talking about something entirely different. And again, this is a first for Collision. We might want to clear the front row because it's a splash zone. Daniel Turdeman from Fast Company, he writes on emerging technologies, and today he's going to be wearing emerging technologies for the first time. They've never turned this thing on. He's going to become Iron Man. The maker of exoskeletons for soldiers, disabled patients, and construction workers are going to be the people responsible for powering up this technology. Again, we're going to have a robotic arm company on stage as well. They can actually make that robotic arm double as a 3D printer. So, I would like you to welcome to the stage the demonstration of how we can democratize access to sophisticated robotic tools, whether they're on us or around us. So with Fast Company's newly augmented Daniel Turdeman, please welcome Carbon Robotics co-founder Rosanna Myers and Exobionics co-founder Russ Angold.
Welcome, everybody. Thanks for joining us. So here I am wearing an exoskeleton. And Russ, maybe you could explain to me what it is that I'm wearing.
Sure. Thanks, Daniel, for being brave enough to try it on. So Daniel's wearing the Exo Vest. It's the first time he's put it on, and we're going to demonstrate what it does in front of you for the first time. So it's geared for manufacturer workers, construction workers, anyone that spends a lot of time with their hands overhead. And so I'm going to give you my backpack. It weighs about, I don't know, 15, 20 pounds. So try lifting that up.
It's heavy and nearly impossible.
You wouldn't want to do that all day, right?
Nope.
All right, so now I'll turn it on. Now lift it up.
Much lighter, yeah.
Much lighter.
Yep.
So that's it. It doesn't give you superhuman strength. It's really about endurance, all day endurance. And you can just hang out, wave, your next parade, you're good to go.
Right.
So that's it. So bring your arms down. I'll shut it off and take it off you. We can get to the panel. And just take it off like a backpack. It's also the first time we've had anyone in a sports coat in it.
Nice. Well, okay, so you've seen the demo. Maybe, Russ, you could start off by just saying a little bit more about what exobionics is and what exoskeletons are and who they help, but how they do that.
Sure. So exobionics, we're all about helping people. We started as a DARPA program back in 2000. The company was founded in 2005. We made advanced technology to try to augment soldiers' capability, protect them from injury. And then we got into the medical space, which we now sell medical exoskeletons around the world for rehabilitation from spinal cord injury or stroke. We've helped over 6,000 users take over 77 million steps in our devices. And now we're getting into the construction and industrial space, again, trying to help those workers that are spending all day on the job, tearing up their shoulders, their backs. How do we provide them with technology that's actually going to help them do their job safer, more productively, and longer?
Got it. Rosanna, maybe you could talk about what Carbon is and what
yes.
you're doing.
So we are Carbon Robotics. We build intelligent, low-cost robotic arms for light industrial manufacturing primarily. So today, if you want to automate a task, it's easily tens of thousands of dollars just to buy the arm, and that's only about 25% of the total cost. There's a ton of peripheral hardware that goes along with it, and then on top of that, the programming is really expensive. So it can cost 2 to 3 times as much as the arm itself to actually program. And so in manufacturing today, 90% of all of the tasks that could be automated are being done by hand. And these are things like scraping metal off of parts and putting boards into jigs, things that people do for hours and hours, repetitive tasks that's the problem we tried to solve. So our arm is about 10 times cheaper, has industrial grade precision, and it's simple enough for anyone to set up. So now the people who have the tasks that they want to automate are able to actually do that rather than hiring in contractors.
So the idea of an inexpensive robotic arm, like how big of a game changer is that?
This is huge. This actually, I remember reading an article a few years ago before we'd even started. SRI had said that this was $5,000 as a mark was the tipping point for getting robots into way more applications. So it's partially the cost of the hardware, it's also the ease of use, but really anywhere that we're seeing people doing the same things over and over again, and then not retaining any of that intelligence, and people are having issues with rising wages. In many cases, they can't hire the people that they need, and in a lot of cases, these aren't the roles that people really want to be doing. So it's huge.
Right. So this word democratizing robotics is being bandied about. Like, what does that really mean? Like, what do you like? How?
I think it's just awareness and acceptability. So making this technology available to folks. So I totally agree. Getting the price down, that makes it more attractive to a wider audience of users to actually start implementing. And then it also, what we've seen with the construction side is by having the augmentation technology now, it doesn't have to be that 250-pound worker doing the job with a heavy tool. You can actually democratize the workforce and actually have someone that weighs 120 pounds doing that same job. Mm-hmm. So it actually opens up a lot of opportunities for different workers.
Does it open up new industries altogether, you think?
I don't know. That's an interesting one, like servicing robots. I think it's all out there. I think it's going to change the way people think about work, and it's going to help people that are in the workforce now either work longer because they have to either retire later, they can work longer without getting hurt, but hopefully this technology also helps attract people into these jobs, realizing that there is cool technology they can leverage now. It's not the same old type of work that's going on.
And do you think inexpensive robotic arms will also, or can also, open up new industries?
Oh, it's huge, yeah. I mean, so we started with the industry that we started with because there's such a high pain. So there's a high need to automate, high desire, and huge pain when they don't automate. So this was a good place for us to start. But we have people reaching out all the time from different industries. So, for instance, pipetting in labs. A lot of that is manual. It's grad student labor. It's people dispensing liquid and doing that for days and days and days. And but behind the scenes, what we're building for one application is actually very similar for that. It's basically moving between positions and being able to perform work that, even though it looks like it's a completely different industry, really behind the scenes it's very similar. So it really is changing how we think about labor.
Right. How do you raise awareness for what both of your companies are doing?
How do you raise awareness?
Yeah.
So we make fun robot videos. That always helps. We're going to be launching some new ones as well. I think a lot of it is teaching people what can be done with tools that they don't necessarily think about. So for us, a lot of it is going into customer sites and showing them something that they had no idea they could use robotic tools for, showing them that they can do that and just how easy it is to set up. And I think that, so a lot of our work is really just broadening their horizons of what's possible.
Yeah, it's definitely a challenge raising awareness. We've been fortunate with the medical side that when someone's wearing a medical exoskeleton that's been paralyzed for 20 years and stands up and walks, we get a lot of media attention, so that actually helped raise the awareness on the construction side. But now getting out to those end users and letting them know that this technology is not science fiction anymore, that it's available, they could go rent it today, that's really a challenge. So the awareness coupled with adoption, I think you have to, again, being price sensitive, have the right channel. We go through the rental channel, making it very easy, right? It's $30 a day to get this technology, so it's really easy for them to adopt. But now we have to know, explain to them how it's available or get the word out, which we do through different conferences and stuff, but it's a challenge.
So there's been a lot of talk over the last few years about robots are going to come and take our jobs. Like, I don't personally think that that's true. What do you guys think?
I think that it's a really important conversation to have, because we are starting to see what we think of as being work is changing. When we look at the tasks that we help automate, these are things that really, one, in many cases, they're having a hard time finding people to do those tasks. One of our pilot customers is already unable to staff sufficiently. They're paying 2 times minimum wage, and they have a huge rate of people just leaving the company. And so that's something that is very frustrating for them to deal with. But I think in many cases, these are tasks that people don't want to do, and that no human should have to do. So I've spent a lot of time in factories, a lot of time. And these are things that, in many cases, if you wouldn't want to do them and you wouldn't want somebody you love to do them, then it changes how you think about it.
Yeah, for us, it's a little different. We definitely need a human for any of our technology to work. So it's more of a hybrid solution. And what we look for in applications is the highly skilled, high decision-making type of task that's in a very unstructured environment. So think a construction site where it's constantly changing. Those are the tasks we go after, and what we found is by doing that, you can take that skilled worker that has 30 years of knowledge in doing this job, and now give him mechanical assistance to do that job without the pain, to let him do it longer versus having to go take a desk job for the rest of his career because he's blown his shoulder out and hurt. So it really helps keep those guys on the job, working longer.
I think it's really the fusion too. It's letting robots do what they're good at and letting people do what they're good at.
Right.
The tools should amplify what it means to be human.
Right. But I would imagine for people that have been, doing the same type of work for decades, even, that there's some sort of entrenched mentality of how things are supposed to work. So how hard is it to get those guys to try it on and change?
That was a really interesting insight we had when we went out to customers and started demoing it. The older workers that had been through either a shoulder injury or been hurt before, they were the ones that were most likely to come use it, because anything that could make their life better to where they could go home and throw a ball with their kid at the end of the day, they were all in. The younger workers, there was a little bit of machismo. They're like, I don't really need it, I'm strong enough. Then after they use it for a while and we shut it off, they're like, no.
They don't want to go back.
We want to use that.
Nice. So, when you're getting ready to go into the office every day, like what is the sort of the biggest concern that you have? Like, how am I going to move my business forward? Like, what are the biggest challenges?
Yeah. For us, it's awareness and adoption. Like letting people know, like, look, the stuff's here. It's only going to get better. There's tons of applications for it today, and where we're going is, more sophisticated types of exoskeletons. The ones that are out in the market right now are very passive. They're very simple. They solve real problems. But it's that strategy to actually get them to adopt the technology. That crawl, walk, run strategy, that's key to getting the acceptance and getting it out there.
Right.
I think for us, we are very focused on our pilots right now and getting those initial applications. But what I'm most excited by and think about a lot is what happens when you bring these tools to people who can develop applications for them in other industries. So I think one of the things that's really cool about what you guys have done is that you've seen this tool that can be used really for just amplifying humans, be it construction, be it a different industry. And there's such an opportunity to get these tools out to people So what I think a lot about is, well, how do we make it so that we're not the only ones developing the applications, and we're not the only ones creating this, and we're not the bottleneck. So we spend a lot of time thinking about how do we build the infrastructure so that we build application 1, 2, and 3, but somebody who doesn't know anything about robots but really knows their application and really knows how to program could then take that and apply it to something else.
So it's a classic case of sort of emerging behavior, or emergent behavior, like seeing people doing things that you didn't expect.
Yes.
Can you talk about any of the things that you've seen people do that surprised you?
Yeah, so we get a lot of outreach from industries like I mentioned, but we get some off the wall ones too. So there was one that snake venom extraction is apparently a big problem.
What is it?
Snake venom extraction. We've units that go out. Most of our units go to pilot customers. Some go to developers, and it's like, hey, what's your idea? What's your application? And that was one of them. We get a lot of very artistic applications, so people putting cameras on them and being able to do really cool motion control because it's a precision tool. And so that for us is fantastic. We love hearing those stories, seeing what people do.
Yeah, for us, we got a picture sent to us one day, and the guy had, typically on our 0G arm, people mount heavy rivet busters, chipping hammers, or rotary hammers. And he sent us a picture with a concrete chainsaw strapped to the arm to cut open some windows, which, one, I didn't know there was a concrete chainsaw, which was kind of cool. But
right.
Two, seeing him adapt the arm to work for his setting was pretty neat.
Right, so it must be, those are the kinds of stories that get you excited to go to work every day?
Yeah, no, you want to, having a job where the whole mission really is to make people's lives better, right, and help them out. And when we showed up, I'll give you this, we were up on the Tesla battery factory drilling holes in the ceiling, and with the use of the arm, that guy went from drilling 80 holes a day to over 400 holes a day. And when we showed up on the factory to kind of get his feedback, he was literally like, are you the Exo guys? I love you. I love you guys, because it's making his life that much better.
Right. What are the biggest sort of design challenges that you face when you're developing the products? Like, what do you have to think about the most to make sure that it works well with people and it works well for the company's needs and things like that?
So we spent a lot of time just figuring out how we could bring the cost of the hardware down to get it just to even have a company. And so to do that, we had to go pretty deep with the supply chain and figure out ways to make our own most drivers. And so that was sort of a lot of work that we had to do just to get to the point where we had an arm that had the goals that we wanted to hit, but at the price point that we could achieve. And now a lot of our attention is on how do we make it collaborative, as safe as needs to be. So one of the big problems in robotic arms today is that they're not very safe. Even collaborative robots generally have to hit you to know where you are. So people will put vision systems on them, or they'll slow them way down, so they're running at about 10% of their rated speed. But if you take that to a manufacturer who says, well, I really care about throughput because I need to hit a certain ROI, there's a huge gap there. And so we created a new sensor that is actually built into the housing of the arm that can detect motion up to 20 inches away in any direction from anywhere on the arm. And that's something that is a different way of thinking about safety, but it's also taking steps to make sure that those collisions never actually happen.
Right, and how hard is it to get the lawyers, to sign off on that? Like the idea of getting people and robots to work so close together.
You have to do a lot of testing and a lot of certification and a lot of. We're very cautious and like to make sure that we test in-house before we ever go out.
Right, and then your design challenges, maybe.
For us, probably the biggest challenge is no human is the same size, right? And so when you start putting technology on them, it has to be comfortable. You have to be able to wear it all day. It can't be hot. It's got to be light. I agree with you. Cost is a huge component. So you take all of that into account. And if you think about like the end state where it's going, like we're all wearing exoskeletons. Everyone in the audience says it's your clothes, right? And nobody's wearing the same size. But for some reason, when you start with some sort of exoskeleton, they want a one size fits all. So if everybody here was wearing one size fits all pants, I think we'd look pretty silly. So how do we get there in a reasonable way and make it comfortable for every user? That's a challenge.
Going back to the idea of like inexpensive robotic arms, like why is now the time where that's happening? Like, what's happening right now that's making that possible?
I mean, one of the big things is having just faster processes, being able to actually run very fast algorithms on the device in ways that wasn't possible before. In some ways, we benefit from tangential markets as well. So we use a lot of carbon fiber, which became very inexpensive because drones took off. And so we're able to leverage that. And also washing machines. So there's been a lot of innovation with Moses for washing machines, smart washing machines.
How does that work?
Well, they have a variable load, and so a lot of the things that you need to make that successful, you need in our application as well. So it's finding these different tangential markets and seeing where they've made innovations, and then elegantly stuffing them into a robot.
Right. Are there a lot of exoskeleton competitors, and if so, like how do you differentiate what you're doing from those?
Yeah,
people?
no, that's a good question. There is. I mean, we had the world's first untethered powered exoskeleton back in 2004. I think we're in the world records for that. That was again the DARPA project. But since then, I think we've gone through that technology tipping point that's enabling your robots to work as well and be cost effective. We have better processors, we have better sensors, we have better, lighter materials. All those things have fed this exoskeleton market as well. So there's competitors across the board, other people working in medical space, other people working in the industrial space. Some people are dabbling in the consumer. It's not really there yet. But I think what differentiates us is we do a little bit in all of those spaces. And it's really interesting, you know, I go back to our exoskeletons we made for soldiers. One of the requirements there was make sure the guy can get in and out of it very quickly. Right. And then we incorporated that feature set into our rehabilitation exo just because that's what we had done for that exo, which turns out to be a huge win because when a hospital buys a medical exo, they want to hit 8 to 10 patients per day and get them in and out of it very quickly and resize it. So, you know, there's some benefits to having that kind of high-level vision of the whole market.
Nice. Well, I think we're out of time. The clock just hit 0. So
thank
you very much for talking with me. Thanks for coming.
Thank you guys.
We're going to keep this thing going, and we're going to stay on the topic of robotics. Now, you'll be relieved to know that not every robotics company is thinking about industrial and altering the capabilities of man and making us superheroes. Our next presenter is actually from a company called Anki. And what Anki is doing is they are building new technologies that are for our children. These technologies enable animated characters, spunky robot named Cosmo, to come to life and create brand new types of media and entertainment. So please welcome to the stage to give us a detailed process walkthrough of how you create these wonders, and they're setting the tone for the way our youngest generation are going to relate to the robots in their lives. Put your hands together for Anki CEO Boris Sofman.
Okay. All right, thank you. So let's see. Oops, perfect. Okay, so I'm going to speak today about a few ways that robotics is actually reinventing some pretty established industries. And I'll use as one of the examples how we're using robotics to reshape the sort of entertainment products you can make and how we're actually bringing an animated character to life. I'll start with an industry that's very familiar in terms of robotics innovation to everybody, and that's transportation. So autonomous vehicles are now the hottest space around. Everybody's familiar with how almost every single company is chasing these sort of technologies. But what's interesting is to look back at how quickly that innovation happened and how just over 10 years ago, it was a completely different landscape. And this is actually a really great example of how robotics can come in a very short time into a space and completely turn things upside down. So a little bit of history. What most people would consider an inflection point in autonomous driving was actually in 2004. There was something called the Grand Challenge, which was a competition sponsored by DARPA, where they had a $2 million prize for the first team that could navigate a 130-mile course in a desert, completely autonomously with no humans. It was a fixed course, no moving obstacles, but they had to do it on their own. And there were a bunch of entrants, universities, some companies, and the team that got the furthest was this entry, Sandstorm from Carnegie Mellon. It got about 7.5 miles in before it flipped over a boulder and busted that really expensive looking sensor there. So, but it was considered a pretty big breakthrough at the time, and just the very next year that we did the challenge, and that time 4 teams finished, 2 from Carnegie Mellon and a winning team from Stanford were among them. And 2 years later, there was an urban challenge in a suburban environment with traffic lights and moving cars, which again, multiple teams finished. And just a few years after that, all of these projects became the precursors for the Google Autonomous Car project, which as we know was kind of was the front runner before a lot of other teams got into space. And it's pretty incredible because back in 2004, nobody would have predicted that within 10, 12 years, we'd be at the stage that we are at today. And now we have on the order of 40 to 60 companies that have legitimate efforts at trying to make autonomous vehicles. But what's interesting is most of the companies you would consider the front runners into space aren't the traditional automotive companies. It's actually very software-driven companies from places like Silicon Valley. And I'd even consider Tesla in that category because they're one of the few automotive companies that have really treated an automobile as a majority software problem, not just a hardware problem. And so it's a really great example of how in a short amount of time you can have an established industry get completely flipped upside down with technology and DNA that typically isn't found within that industry. And when you look at the rest of consumer spaces, one of the big catalysts of innovation in other consumer categories is actually the price of a lot of components that have been impacted by the mobile phone industry. You look at the last couple of decades of mobile phones and the last decade of smartphones and tablets, and you've had incredible price pressures on things like microcontrollers, cameras, wireless chips, batteries, motors, all these sort of things that when you ship units at multi-billion unit quantities, you suddenly have capabilities under $1 that you would never even dream about even a few years earlier. And so if you have the right kind of creativity and combinations of systems that you put together using these components, you can do some pretty impressive things. And so for us, when we started Anki back in 2010, we wanted to approach the entertainment side of robotics and create products in the toy and gaming and entertainment space as a starting point for broader innovation within consumer robotics. So we started with a battle racing game called Overdrive. This is basically a racing game where each car is a robot. You control them with smart devices, but whichever cars you're not controlling, they drive themselves. And there's virtual characters that become the drivers of those cars. They trash talk with you to tell you how you're inferior as a driver. You have weapons, special abilities. You're effectively playing a video game in the real world. And the goal was truly to make it possible to program games on top of these physical characters. And so when you look inside of this car, what's interesting is that you have 50 megahertz computer. Again, less than $1 because suddenly a computer that used to cost gigantic amounts of money has been pummeled by the mobile phone industry. You have an optical sensor that's basically the front-facing camera of an iPhone. You have these systems that are scanning environment 500 times a second where the cars can identify their positions and send that back to a mobile device. And in effect, we have a video game inside of a phone that's synchronized to the physical world. And so we can effectively program these games on top of these characters and do things like have weapons, special abilities, high levels of AI, and bring all of these digital elements to life that you would typically not expect. And so this was a starting point, but in parallel, we were working on underlying technologies that would let us go a step further. And our goal was to actually bring a physical character to life. And so this is where I'd like to introduce Cosmo. What we wanted to do was to bring to life a physical character with a level of personality and emotional depth and behavioral intelligence that you would never see outside of a screen. So if you literally think of the beautiful characters that you remember from Pixar movies and DreamWorks movies, we asked the question, what would it take to bring a character like that to life physically, where not only would it have a level of emotional richness and intelligence beyond anything you'd expect, but we could actually use robotics and AI to make those emotions relevant to what's happening around it. Things like face detection and interaction, understanding of the environment, being able to play games, being able to have the right emotions at the right time, evolve as a character. And so we wanted to make this little robot come to life and and in effect be this like mischievous little newbie of a robot that wants to be a superhero but isn't quite there yet. And your goal is to kind of play with him and evolve him. And in the process, all of the emotional cues and opportunities to show off his intelligence end up being far more powerful physically than they ever would virtually. So I'll show a little clip that gives you an idea of him and his personality. All right, so that tells you all I need to know about Cosmo. He's a fun little guy. But what's really fascinating is how he's actually designed. And this is where one of the most important realizations that we had took us a little bit of time to get there, but we realized we had to approach Cosmo as a character from a film. And so we literally built an animation studio within a robotics company that's animating a physical character in the real world. So when you have a situation like this where Cosmo's waking up off of his charger and kind of coming out into the real world, this is a rendered version of what happens, but it matches exactly what happens physically. And that's because we use the exact same tools that you would use for animating a character in a film. We actually use a program called Maya, which is one of the main programs used for animated film. We have a rigged up version of Cosmo, an eye engine, sound engine, all of the motor capabilities that match his exact ranges of motion. And our animation team actually animates Cosmo exactly like they would have animated him if he was a digital character, except that the output is actually spliced to the physical world instead of digital. And so what this allows us to do is to approach Cosmo exactly the same way an animation studio would approach the development of a character in a film. We think about his backstory, his motivations, what makes him tick, what gets him excited, what's he scared of, what makes him insecure, what's his long-term goal, and how does he build relationships with people? How would he react under every single type of circumstance? And so we have sketches, we have storyboards, we have backstories, and the really unique thing is that the robotics and AI is the layer that ties all of these digital elements with the physical world by allowing us to understand everything that's happening to where the emotions could make sense, but also knowing the right time to spawn them. And so we have a behavioral and kind of character engine that actually takes the stimuli from the outside world and generates the right emotions in real time. And so what happens under the hood that enables this is actually a lot of pretty interesting systems all working together. So from a technical standpoint, Cosmo is about 320 components. So there's microcontrollers, cameras, IMUs, motors, gyroscope, accelerometers, all sorts of gears and joints. Really, really sophisticated actually, and almost no empty space inside of him, where getting all these things to work within such a small cavity was quite challenging. But when you combine it all, you have a pretty interesting system that uses computer vision, uses these all these overlaps of technologies, and you end up having almost this triangle between character and animation from kind of a film-like approach, the game design side where you want to bring the interactive elements to life, and then the robotics and AI which enables it and in some sense embraces the constraints of the physical world. And this is where one of the most interesting challenges comes in, because when you are animating a film, you have a story on rails. You directly think of exactly what you want to happen. You work for years on a 90-minute film, and you control every aspect of that experience. In a case like this, you actually have to have something that's very interactive and intelligently responding to the environment. You have to be able to realize that you're going to encounter the same situation 200 times. You might be interrupted. You might get picked up. You might get tossed around. And the challenge is in making all these systems come together and create a character that, for lack of a better way to say it, feels like he's alive. And that is, in the end, the goal. And what's really fascinating is that all of these tools that go into making this one character, it's not about Cosmo, it's about the ability to animate physical characters and to bring these characters and stories to life. And so you can imagine different characters with different personalities, different background stories, different purposes. all existing with the same framework that allows this to happen. And over time, you can even imagine functional layers coming on top of it when the capabilities of these characters start expanding beyond just entertainment or companionship. And so we're really excited because we have a really rich roadmap ahead with Cosmo. And in fact, even from a developer standpoint, there's an SDK that's been used by universities to teach courses in robotics and to do research in areas like autism and human-computer interactions and computer vision and other areas. But more broadly, hopefully this is another example that helps you understand how robotics isn't really a particular industry. It's actually a tool that can be applied to almost any other industry to completely reshape the sort of products that are possible. So just like the internet was a tool that forced every single industry to rethink in the way they do business, and some were impacted more than others, robotics allows us to really rethink the levels of physical intelligence and autonomy that are possible. And what's most powerful about this is that it's so deeply tied in to the landscape of hardware ecosystem, mobile phones, smartphones, technologies, cloud AI, all these different elements, that it'll be a series of innovations and transitions that happens over the course of a number of years. And most of the time, these will happen from the outside because the incumbents in most of these spaces are actually not in the best position to completely rethink how they make products in the space. The sort of products that you see from us typically would not come out of traditional toy companies, just like an autonomous car would not have independently come out of an automotive company without a push from the outside. And so so hopefully this gives you a little bit more of an appreciation on how these technologies over time can actually lead to some pretty exciting innovations in spaces that go far beyond the ones that you would initially think of. Thank you very much.
Okay, more robots. Now we have some robot guests. Now, I know what you're thinking. You're worried that these guys are going to take your jobs. I'm up here speaking to you today to tell you they're not. In fact, the conversation we're now going to have is maybe these robots can actually work side by side with you in the workforce. And as you see, we have some guests that are going to be joining us soon. One is named Pepper, and one is named Relay. Here they come. Now, while they're not going to take our jobs in the workforce, they are now becoming speakers, so not really sure how that sides up. But the idea here is that we're going to talk about the workforce and talk about how technology and robotics and everything we've seen here today comes together to make the technology evolution continue to move forward in an interesting pace. So we're joined by a trio of renowned roboticists featuring this is fun. We're arranging our guests. They actually want the spotlight. The robots themselves have asked to be front and center, but we're going to keep them by the side, keep them under control. So please welcome to the stage contributing editor to IEEE Spectrum, Evan Ackerman. Rodolphe Gallen, who is the EVP and Chief Science Officer at SoftBank Robotics. Melanie Wise, who's the CEO of Fetch. And Tessa Lau with the greatest title of all. She's the CTO of Savioke, and she's also the Chief Robot Whisperer. I think we need that right now.
All right. All right, we've got robots. So why don't we just start with you, Rodolphe? Tell us about Pepper and what Pepper's designed to do.
So Pepper is this cute humanoid robot that has been designed to welcome people in shops. That's the reason why he has big eyes to have a look on you, big ears to hear you, and this tablet to explain you if you need more detail about the products you want to buy or you want to. And today it's used in many shops, mainly in Japan, and soon in US. We have some tests in France, in Europe as well, and things are pretty well with it today.
Mm-hmm. All right, Tessa, how about your robot?
So this is Relay. Relay is hospitality's first service delivery robot. He delivers room service to guests in hotels. So you're staying in your hotel, it's late at night, you want a snack. You call down to the front desk, and they send it up via relay. And 5 minutes later, it arrives at your door. He can take the elevators. When he gets to your room, he doesn't have an arm, so he can't knock, but he calls your phone, and he tells you that he's there, and you can pick up your item.
And Melanie, I think we have a video of your robot. And
Yeah.
while that's playing, why don't you tell us about Fetch Robotics?
Yeah, so, well, you know, robots are kind of hard to travel with. So our robots are made for logistics applications. So we do warehousing robots, robots that help goods get from point A to point B within a facility.
I think we have a video somewhere. Hopefully that'll play so you guys have an idea of what Melanie's robot looks like.
Yeah, somewhere. Oh, there
we
you
go.
Yeah, so that's the freight robot. It's very cleverly named. It works with other humans within the warehouse, and it does transportation of goods. And we make it in different sizes so that you can move pieces, cases, and pallets.
And just to be clear, all of your robots are out in the world right now doing stuff in warehouses and hotels and malls and such. But Rodolphe and Tessa, your robots are designed more for social interaction, right? They interact with people on a regular basis. So but at the same time, they're very differently designed. So Rodolphe, maybe starting with you, can you tell us about how you came up with the design for Pepper?
Yeah, for this robot, interaction is so important that we wanted to have a robot that you fall in love at first sight. So that's why the appearance is so important. And not only the appearance, but also the behavior, the way it moves. And you know, we also think to use it for an elderly person, for instance. And that the first time we discussed with elderly person about robotics to assist them, they say, oh, no, we don't want robotics. They were horrified by robots. But when I show my robot, and I show them my robot, they say, oh, it's so cute. What could he do for me? And only the word robot was horrifying for them, but the object, this object, was completely charming. So that's the reason why the appearance for these very social robots is so important. And we have put a lot of effort in the appearance and you know, this gesture, all these little gestures that gives life to it.
And Tessa, your robot's much different looking, but it's also interacting with people all the time. So how did you come up with that design?
Yeah, well, I mean, our robot starts with functionality first, right? It's a delivery robot. But we also know that in order for robots to really take off and be successful, people have to love them. And so we designed Relay from the ground up to be cute and adorable, emotive, and actually have a personality. Right now he has a set of blinky eyes that communicate with you to tell you what he's thinking and where he's looking. And we did this partly because he's operating in semi-hostile environments, in hotels or other places. You know, there are drunk people, there are kids, there are luggages, there are pets. And so we wanted him to be able to survive and thrive in that kind of environment. And one of the ways he does that is by being cute, and you want to help him.
Now, Melanie, you're not in hotels, you're in warehouses, but your robots are still interacting with people. So can you describe what they do and how that works?
Yeah, so really the way I guess a picker interacts with the robot is they basically put the packages onto the robot, and then they use the touchscreen interface on the robot or a tablet interface to trigger whatever the destination is for the robot. And it is a lot about creating a friendly design because, you know, there is a lot of bad PR around robots and jobs, and so you have to ingratiate the robot into their presence.
And all of these robots are working in environments where they're working with people, right? And they're not necessarily taking jobs away. They're doing jobs that people don't really want to do, or they're assisting people with their jobs and making them more efficient. So can you talk about that a little bit? Like, is that actually a problem?
It's an issue, so we have to take that into account. And of course today, I don't think that the robot can take the work of somebody because it's very simple. But it can be here where a service is missing. For instance, in shops, it can give simple information, and that nobody would spend time on it. But you have to be very careful in the position you give to your robot. For instance, in Europe, because we have a big trouble with unemployment, you cannot really say, okay, my robot will replace the work of someone. But it can help, it can assist. For instance, we have used this robot in railway station in France, and maybe you know in France the SNCF is unions are very strong, so you cannot say, okay, I put the robot to replace someone. But the robot is here to give information that the guy who sells the ticket is not really ready to give the information, like where is the closest bakery where I can drink something. So then the robot is here to help and to give a better experience to the user. Mm-hmm. And for instance, a good application for this robot in Japan wouldn't be a good application in Europe or in US. You really have to adapt the work and the task of your robot to the culture and the country where you want to use it.
Mm-hmm. And Tessa, is that the same for you? You're not taking the job of a person?
It's not about taking jobs, it's about empowering people to do more with the help of robot assistants. And one of the stories I like the best about one of our customers, we're using Relay to carry on a pen pal conversation with a girl who was staying at their hotel. And she would write notes and she would put them into Relay, and Relay would take them down to the front desk, and the front desk would write a note back pretending to be the robot and then send it up to the girl in her hotel room, and they would keep her entertained. It was actually while her brother was sick, and so they were stuck in their hotel room for a couple of days. And so the staff has figured out a very creative way to use Relay to supplement their own ability to make their guests happy.
Mm-hmm. And Melanie, I think it's a little more complicated in your industry because you have some people doing some of these like moving things around jobs in warehouses. So how does that come in?
Yeah, I think that there's no there, to be honest, with jobs. In the United States, there's 600,000 jobs going unfilled. People don't want to do these jobs anymore. There's 25% turnover, and really, these companies have to increase productivity, and automation is the way to do it because they can't get enough people to do the jobs. And this is just getting worse and worse because the average age of a picker is actually much older than you would expect. And those people are starting to retire, or they have back issues, knee issues, other health issues that are precipitated by walking a lot, and our robot actually helps remove some of that walking. The other thing that's really fun and interesting, and this is robots for saving lives, there's about 800,000 forklifts in the United States, and a person dies about every 3 days from a forklift accident. So if you work in a facility with forklifts, you're twice as likely to die from a forklift than a car accident, and you're 7 times more likely to be injured. And so these robots also help with limiting the interaction between walking, pedestrians, and other vehicles within a facility. So it actually is a double, or actually a triple win in many cases for increasing efficiency, reducing health benefits and workman's comp, and safety, increasing safety.
Mm-hmm. And your robots are working directly with people, making them more efficient. Like, how do the people feel about that?
Yeah, it's at first there's a lot of concern because people have this perception that the robot's coming in to take their job, but many of them have a very strong, happy reaction within the first week of working with the robots. A gentleman actually said that he thought he could work an extra 5 years because his knees weren't going to hurt as much. And what's really interesting is we can tell that they really love the robots because instead of naming them like George or Tom, they name them Batman and Superman. and having that kind of like interest and excitement about a robot to name it a superhero, I think is a little bit indicative of how they feel about the robots.
Mm-hmm. Yeah. Now, your robots all, to some extent, depend on having people around for them to be functional. Is that correct? Like, it works directly with people, like Pepper and Relay also?
Yeah, the Pepper is autonomous in a way that it can interact with a visitor. So I don't know if you say if it's working with people, but there is no co-worker with Pepper. Pepper is interacting with the visitor, giving information, but of course, sometimes Pepper will understand that she cannot give the good answer, she doesn't understand the question, so then she will call a vendor. But it means that more and more customer could be served by the robot, and the human can be here just for complex situations, and then the robot can say, okay, it's not my job anymore, and the human will help me and will help you.
Mm-hmm.
Yeah. In average in a hotel, it takes about 7 minutes round trip to get an item up from the front desk to the guest room and back. And that's 7 minutes during which someone is like standing there waiting for the elevator, walking down the hallway. And that's something where the robot can really help. And so we designed Relay to actually ferry things, to relay things from one person to another. So there's one person at the front desk who puts items in, and there's the guest at the room who takes items out. So it's meant to work in conjunction with people.
Yeah, so to what extent does the effectiveness of robots in the workplace depend on having humans around? Like, what's the state of the art in autonomy? And at what point are robots going to say, okay, we don't need humans around anymore, we can just do our own thing?
Well, in the service industry, there's always going to be people, because the heart of good service and hospitality is really understanding what people want and helping create the personalized experience just for them. And it's going to be a long time, I think, until robots can actually do a lot of that. What robots can do is they can make some aspects of service a lot more predictable, a lot more automated. So, for example, delivery times to your room, if you don't want to wait 30 minutes or more for your room service, you can wait 5 minutes and have a robot do it. And so I think it's going to be, for the near future and probably for the foreseeable future, it's going to be a mix of humans and robots working together.
Well, the fact is that there's already lights-out manufacturing facilities in the world.
Can you describe what that means?
Lights-out means that there are actually no active workers on the floor. The lights in the facility are actually turned off, and they produce cars. There's actually several lights-out facilities that already do that. But the thing is that there's still the operators that monitor the system. There's still the people who go and repair the robots. There's a whole network of people and other jobs associated with just deploying and maintaining robotic systems. So no matter what, whether or not you go to a fully automated system, you're always going to need the +1 to repair the robot. And I don't see people getting out of the equation anytime soon.
And to some extent, all three of you have robots operating in what you might call semi-structured environments, where you're familiar to some extent with the environment you're operating in. Maybe you have a map, you know it's not going to change that much. How much of an obstacle is that to kind of deploying robots in more places, and what kind of things are we going to have to do technologically in order to get robots kind of out into the world more?
Well, I think that's a complex question, obviously. I think that people are making good headway into dealing with more and more unstructured environments. Yeah, the warehouses are semi-structured, but whole pallets move around, and the topology of the warehouse changes very rapidly. And right now, our system can tolerate about 60 to 70% change in the environment. But I think that what you're going to see is a general progression of us slowly changing our environments to make it easier for robots to come into our lives. I mean, the autonomous cars are kind of a very good example of an extremely unstructured problem, and the time horizon for that is still a couple decades out, I personally believe, in terms of you or I owning an autonomous car. But I'm not even sure we're going to own autonomous cars, because that's kind of a moot point. You should probably not own it. You should do ride sharing. But I think that if you look at going into the home, it's really about, can we do things to assist the robots? Can we have special dishes? Can we have special furniture to make it easier? And people already do this with their Roombas. They pick up all the stuff on the floor so that the Roomba cleans the house. And so I think we've already developed a culture of assisting robots to be effective in our unstructured environments. The question is how do we help them culturally adapt to these environments and semantically explain to them what we actually want them to mean? And it really comes down to usability long term.
And what's it been like in hotels? And I imagine that as you expand beyond hotels and environments get different and more complicated, what kinds of problems do you have to solve?
Yeah, there's a lot of changing environments, as Melanie said. One of the things that we watch carefully is that there's a lot of research going on in the robotics community about how to solve some of these problems. And a lot of these problems are sort of the cutting edge of what can be done today with robotics. And so what we're really excited about is that there's a lot of progress being made on a number of different fronts. that will all end up helping robots eventually deal with all of this chaos and unstructured environments. I talked to several startups here right now that are doing image recognition or machine learning or data processing to try to make sense of the world based on camera data. You know, all of that stuff is technology that will eventually help robots figure out what's going on in the world and how can they deal with it.
Rodolphe, how are you able to go into, say, a business that's never even thought about using a robot like Pepper in this capacity before and say, oh, you know, this robot can actually be helpful and actually do stuff? How do you cross that kind of first kind of perception gap that you need to convince them that it's a real thing that can work?
Today the robot has been designed for welcoming people in shops, but we see many people bringing new ideas to how to use the robot in completely different situations. And this robot has been used for education, for instance, and and of course we have in mind to use it for assistance to elderly person, and then the collaboration between human and robots will be again different, because of course there will be the cooperation between the robot and the elderly person himself or herself, but also with the human assistant that will come someday during the day sometimes, and then the robot will share with the human assistants the experience, what happened during the day. So this collaboration between these three people will be very, very interesting for us, and we have a lot of improvement to bring in a robot to have a good understanding of the situation and what should be transferred to the human assistant and what should be private, for instance. That there are so many questions that will come.
Mm-hmm. So over the long term, or say the next 10 or so years, and you're all working very hard to make robots even more capable, it does seem like, and you should feel free to disagree with me, that some jobs will gradually disappear and be taken over by hardware automation. I mean, do any of you disagree that that's going to happen?
I think that there will be job displacement.
Okay.
I think that there's going to, I mean, to be perfectly honest, this is not a technology problem. Technology should progress. Mm-hmm. This is a socio-economical, political discussion, and it really should be tendered as that. I really wish we would start having that discussion instead of continuously looking at robots and saying bad robot. Because job displacement is going to happen. We need to change our culture to lifelong learning. We need to really think about how people are going to need to be retrained to handle the new technology. And some of the burden does fall on roboticists because we need to make the systems more usable so that the burden of the technology that they need to learn is very low. And that's one of the big bets that Fetch has taken, is we've invested a lot of time and energy into usability, into making it easier for people without technology educations to interface with and use our robots. Because this job displacement is happening, it will happen, and we're going to need these people to manage our robots, fix them, repair them, install them, and there's going to be a lot of jobs to do that, but we need people that are technically trained to do it.
Mm-hmm. I think one of the best things that people can do now to prepare is to really learn how to use computers as tools, because robots, just like computers, are going to be tools. They are tools already, and to the extent that people can understand how they can use this piece of technology to make them more effective or more productive, everyone wins. You know, there's more jobs out there. There's more people who can actually use robots to do something important in the world.
Mm-hmm. And there are some new jobs will appear. When you say displacement, that's a nice word. For instance, we need a lot of people to teach jokes to the robot. So we have people writing jokes for the robot, imagining the dialogue the robot can have with people. Today, the artificial intelligence is not ready for the robot to create and to the dialogue. So we have to prepare all the dialogue. So we need plenty of guys imagining all the discussion you can have with the robot, and that's a completely new job in robotics. And there will be so many new jobs that we don't even imagine today.
Mm-hmm. Now you mentioned that artificial intelligence you don't think is quite ready, and I'm just curious, what are some of these maybe overhyped things about robots? Like, what are some of the technical problems that we need to solve before robots can get to this point that I think a lot of people think that they're at already?
That's a hard question. I would say that one of the next big challenges for robots, for generic use, and the notion that you can walk up to a robot and say, "Hi, robot," and the robot will actually respond and say, "Hey, how's it going?" Is really semantic understanding of the world, the ability to do vision processing in unstructured environments. I mean, people look at Facebook and they say, "Oh, it can recognize all these faces, it can know what a dog is," but we actually, as people, do a lot of pre-processing. We center the subject in the photo, we make sure it's well lit, we make sure that, you know, we can see all the people's faces are pointing forward most of the time. And so there's a lot of pre-processing that we do, but if you ask a robot to go into a room and find someone, the lights could be very low, the person could be wearing a hat, they could be wearing something highly reflective, and all of those things play havoc with the sensors. And I think that perception and understanding semantically what's going on is a big problem, especially when you go and buy a hand-carved cup from Fiji. Like, how do you explain that to a robot? I mean, it just doesn't work.
One of the most common requests we get for Relay is that people want him to bring them a beer. And you know, the challenge in that is that, yeah, sure, he can bring it to you, but he doesn't know what a beer is. He doesn't know how to open the fridge. You might not even know where your fridge is unless you teach him. And so I think all of that is semantics, as Melanie is saying. And it's really about how do we imbue our systems with the ability to understand what we're saying to them and respond appropriately. And that's a really interesting frontier.
Yeah, and that must be a challenge for Pepper as well, because it has arms, it has hands, it has a head. How do you control that expectation that someone who meets Pepper for the first time has?
Yeah, that's very difficult, because when you see Pepper, you talk to it exactly like to a human being, and that's one of the reasons why it's not too similar to a human. So you see that it's a machine, and his voice is not exactly a human voice. So we try to keep the distance to explain. Okay, it's not a human, it's still a robot with the limitations. And it's true, everybody say, okay, artificial intelligence, deep learning, blah, 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 but it's difficult to learn all this, common sense. We had a very nice speech this morning explaining what is a common sense for a robot. If you have to learn everything you know to a robot, it will take decades, and if you have to show to the robot millions of beer for it to understand what is a bottle of beer, okay. So really have to find another way, a new way to train the robot, and for them to be, to really share our understanding and to share the semantics of the world.
Mm-hmm. Well, and if any of you want to help teach Pepper what a beer is, there's some upstairs, right?
Yes, absolutely. You can. Play with Pepper on the first floor, on the second floor here, you say, and we'll be more than happy for you.
Okay, and hopefully Relay will walk around too a little bit, and so come see the robots, and thank you all very much.
Great job. So don't go anywhere, folks. We have a lot more coming up. Now we're moving on beyond robots. I, for one, welcome our robot overlords. That's the reason I have robot socks, right? I've been assimilated backstage, so I'm completely corrupt in this. But now we're moving on to AR, VR. One of the challenges that we've had in the past with technologies like Google Glass and other technologies, we really didn't think about the societal impact of it. We didn't think about the user in the user experience. So we're going to have a demonstration here in just a minute. So we get the best toys here. We're going to see a demonstration using Leap Motion's interface, so that they actually take hands and put them into a virtual world, and you see how good that actually is. So we're getting set up right now. You guys don't go anywhere. This is going to be really fun. And after this, we're actually going to be talking to Porsche about the cars and where we're going from here. Strides in personal mobility. So stick around for that as well. So we're going to start with a demonstration, and then we're actually going to have a discussion with Michael Buchwald, who's the CEO of Leap Motion, as well as Noah Kraft from Doppler Labs. It's going to be a really great conversation. Hey, let's hear it for Collision for pulling together such great technical experts, demonstrations, and conversations on where we're going with the future.
Okay. Second.
We're about ready to go here. Okay, we're about ready. I think they're going to do a two-player demonstration. Ready to go?
Not quite.
Okay.
I'm not seeing anything in the headset. I'm not seeing anything in the headset.
So while they get everything ready to go here, let's just kind of recap everything that we've seen today. We started with like infrastructure overlay. We heard from the CTO of HP talking about all of the back-end systems they're going in to connect all of us. Then we went and learned about the connected car, and now we're going to learn about how we're going to interact with the technologies around us in just a moment. We also went from the connected car to the connected skies, drones. You guys, how many out there know that I'm waiting for my flying car? Still waiting for the flying, yeah, exactly. Still waiting for the flying car. And then we went on we met new robotic counterparts. Really interesting conversations with all of that. What did you guys think of Pepper? A lot of personality. Did anybody notice that Pepper is actually very respectful, bowed a lot of times? Did you guys pick up on that? Anybody count how many times? There's probably another robot that could do that for us to count the number of times Pepper bows. So you guys know that demos are demos, and that's exactly what it is. Are we ready to go? Okay, no worries. Okay, so what did you guys think about the dark, what did they say, the lights out facilities? Did you guys know, how many people knew that there were lights out facilities for car plants, manufacturers where there's no humans at all? How many people were kind of challenged by that? When you learn, yeah, exactly. You're learning there's all these factories going on and there's nobody there 24/7. It's fun stuff. You know, I've been purporting here since my simulation that robots aren't going to take over our jobs, and I believe that's true for many cases, but I also heard a great term today that what we have to do is we have to upskill our workforce. We have to teach people new skills for the skills that robots are going to actually take over from a manufacturing perspective. And it looks like we have a demonstration. You guys enjoy.
Sorry. Thank you for bearing with us. My name is Rebecca. I work at Leap Motion. For those of you who don't know us, at Leap Motion, we believe that you should be able to use your hands in VR and also interact with objects in the digital world just as you would in the real world. We're going to show you a demo today. What you're going to be seeing is what I'm seeing in this headset here, and I'm going to be interacting with my colleague Sean over here. So let's get started. Okay. So we start out here in this virtual scape, and you see my hands in front of me. My hands move and react just like my real hands, and what's really interesting here is that because my hands are in the same place and they move with the same dexterity as my real hands, my brain actually can't tell the difference between my virtual hands and my real hands. And so the demo that we're going to do today is we're going to be playing with blocks. And so to create a block, you pinch your thumb and your index fingers just like this. You bring them together, and then you spread them apart, and then you have a block. And then I can interact with these blocks the way that you might, similar to what you might do in the real world. Another feature of our virtual world is that you can interact with other people. Sean is having technical difficulties at the moment, so I'm going to play with blocks. Another feature of this world is that we have this virtual wearable interface where I can change the shapes of blocks. And then one last feature of this virtual world, because this is a virtual world, is I can turn off the gravity. And I can play with blocks just like so. And then I can turn the gravity back on. And everything falls to the ground. No, okay. So that's all we have time for today. Apologies that the multiplayer aspect didn't work this time. If you would like to see a demo, please feel free to reach out to me. My name is Rebecca Lee. You can find me on our website or in the Collision app. Thanks so much.
That was very, very cool, wasn't it? So here to discuss what we just saw and to talk about the social ramifications of interactions like that with the multiplayer mode and everything, let's welcome Sunday Times West Coast technical correspondent Danny Fortson and CEO of Doppler Labs Noah Kraft, and then Leap Motion CEO who put this technology together, Michael Buchwald.
I'm right behind the podium. Hello.
I don't think I'm on.
Testing.
Yeah. Thank you.
Hey, Michael.
Magic. Right. So that was a very cool demo. So I think a good way to start the discussion is 10 years ago, I think in June, is the launch of the first iPhone.
Yeah.
And so I think that's a good way to start this discussion of how close are we to the end of the smartphone and the beginning of this next phase, this kind of new interface and the way to interface with technology?
Great question. So you guys just saw a little about what Michael does. I'm Noah. I'm the CEO of Doppler Labs, and we're actually focused on audio augmented reality. So I'm just going to give them a little context.
Yeah, please.
So we create a product called Hear One. Hear One is the first in your computer. It basically takes the foundation of a headphone and adds a lot of new functionality on top of it. So when you put the product in, and we were playing around with it earlier, it mimics the acoustics of your ears. So it's like having nothing in your ears. But then you can augment the world around it. You can turn the volume of your world up and down. You can add filters that reduce noise or enhance the environments, and you can stream audio on top of that. And we believe, if you kind of think of the film Her, that the future, to answer your question, is going to take computing to a much more human place. And we think that audio and voice is a key part of that. And the reason we're focused on the ears is kind of two reasons. One, we've been wearing technology in our ears for decades, right? And I know one of the things we were talking about backstage is there's a lot of focus on the eyes and there's a lot of focus on the wrist, but we do not have a precursor technology that is kind of the bellwether for that technology, right? You had the typewriter and then the laptop, you had the Symbian phone and then the phone, and we believe that not only from a cultural perspective are people more comfortable putting tech in their ears, we believe that audio has the ability to be a much more elegant way to interface with computers. And to answer your question, we think the mobile phone will be around for the foreseeable future, let's call it the next few years, but we're going to see more and more technology enter the body, both internally and externally, that will free you from the phone more and more, but that'll be a gradual process.
And Michael, how does virtual reality fit into this future? Is it destined to be just a niche product, or do you think it will go further than that?
Well, I think that the word virtual reality conjures this idea, obviously, of a virtual reality. And I think that if, when you put on a headset, you actually feel like you are in the streets of a Paris or on the surface of Mars or in the patient of your body, like in your patient's body if you're a surgeon, or in an airplane engine that you're repairing if you're a mechanic. I think if you can deliver those experiences and actually make them feel real, then it will be very successful. I think that we're seeing hardware get to the point where that is possible for the first time. And obviously, there's billions of dollars being invested in VR and AR. So I think the hardware is there. But what I think is still missing is input that can replicate and create the sense of immersion that has to parallel that. And I think that the current efforts we've seen at controllers just don't do that. And also, I think obviously what has to come after that is content that uses that combination of hardware and input. But I think that we will see over the next 1 to 2 years VR hardware come to market that is able to provide that, like, holy shit, I'm actually sitting here and I feel like I am in this place. And I think if it can do that, it will be a relatively mainstream and very disruptive part of our society and culture.
And how important is what Facebook does with, say, Oculus, in terms of getting this to be a technology that really captures the imagination and becomes really widespread? And the same question for you with, say, Apple, with the speculation on what they may or may not do with augmented reality and what they've already done with the earphones.
Sure. You want to go first?
Yeah, I think that what happens with technologies like Oculus and such is it's important, but I think actually that we're kind of already seeing the commoditization of the hardware in VR to the point that the actual building of a VR headset is something that almost any Chinese manufacturer can do probably. And I think that the real thing that Oculus Rift and now Facebook did, which was very sort of important for the space, but also by definition started this sort of commoditization, was realized that you can take an already mass-produced mobile phone display module and put it in a piece of plastic and have a good VR headset experience. And that now means that almost anyone can build a decent piece of hardware, but obviously having just a display is not a product. So then there's a question of ecosystem and content and obviously input. And we know that there are a lot of large household name companies that are working on either mobile devices that would have their own ARM processors already built in place, or people working on things that connect to PCs like Oculus Rift. And I think what's going to be interesting is how the sort of operating systems, content, and input develop, because I think that's the part of the puzzle that hasn't really been defined yet.
Yeah, and I think for us, Apple releasing the AirPods was a sea change. I think the removal of the headphone jack was equally. It signals to, when a company like Apple signals that the in-ear form factor, that in-ear technology is going to be a big part of their play, obviously people start paying more attention. And for us, one of the things, if you start looking at market research, we were talking about this earlier, is now the predictions is this category is called hearables, that by 2020 it'll be a $40 billion industry. And I believe that it's going to come to fruition a lot faster than AR glasses or VR glasses. And I think the debate about what comes first, I fundamentally believe the ears are going to be part of the zeitgeist a lot quicker than that. And we were talking backstage about how in certain use cases you're going to find that the visual is really powerful, but it's going to be episodic. You're going to have, surgeons or manufacturers or things where having these layers are going to be, really important. I think one of the other things that Apple did is, without throwing them under the bus, let's just say the aesthetics of the AirPods have come under a lot of scrutiny, but they've already started to become mainstream. I see people walking around all the time with AirPods, and that's in itself a cultural, and I'm very interested in how do these things become culturally acceptable on a day-to-day, because I do believe AR is one of the ways we're going to bring technology and humanity closer together if we do it right. But just the fact that people are comfortable with a white stick sticking down their face, walking around, being normal and interacting with people, for us that's a big signal. And we believe in the space of the only other people really pushing the boundaries of kind of what you can do in the ear. And in our technology, we actually have 4 ICs, 4 compute processors in each of your ears. And once you start doing that, you open up the ability for things like real-time language translation and these things that have seemed sci-fi, but we've already built. And it's cool.
And do you foresee people really grabbing on to this technology and and getting excited about it, or being like, okay, wait a minute, this is getting all a bit weird. I have a computer on my face, I have one in my ear, I have a hang in front of my eyes. It does raise a question about how much technology we want, and really about how we all interact with each other in this question of humanity and computing and how those interact.
Yeah, I think those are two great questions. So first, I think it takes step functions. Like for us, we started with an earplug, and then we made a concept car product that was AR only, and then we launched a flagship. But on a market level, people need to get comfortable with technology. 10 years ago, you brought up the iPhone. It was a phone. It didn't even have an app store. And as more and more functionality came in, like this is becoming an indispensable piece of technology that I guarantee you, if we were having this talk 15 years ago and you said people will be walking down the street with their heads in a piece of glass, tapping like this, it would have seemed really odd. But through conditioning and through kind of the socialization of this technology, it's become, but to your point, I actually think your head in a piece of glass is distracting you from humanity. And part of what we're focused on, part of the reason the product is called Here, is we believe you can pick your head back up and use audio as a way to interface both with the world while still getting data. But it will take time. I don't think tomorrow everyone's going to be wearing AR glasses or AR audio products. I think there's step functions that are as important to the cultural adoption as it is, as well as the technological, and they have to go hand in hand.
Yeah, and I also think that the more human the technology is, the more invisible it becomes. And I think you're right that people are going to be reluctant and feel overpowered if they have to deal with lots of different systems that have different modalities and feel like they're just more stuff to think about. But part of the reason we love hands and part of the power of our hands and fingers is that they're already capable for every person of doing these unbelievably complex things that we don't think of oh wow, picking up this cup of coffee is just so hard because I have to maneuver my fingers just so, and there are so many millions of nerves and muscles moving. I just am my brain is just grab the cup, and then my hand does the rest. And I think that at its best, technology can feel like that, and certainly that's why we're passionate about bringing fingers to it. But I think that at a higher level, I think whether it's through hearing, whether it's through visual display, whether it's through fingers, I think that the more human the technology is, the more natural it is, the more it builds on and becomes a part of us. Actually, the less it feels like I have 5 computers on my face, and the more it feels just like I'm doing this thing that for me is just a natural part of my existence.
And how important is getting the operating systems right now? Because you can see the dark side of this, of if we're one day wearing glasses or have an earpiece and your vision and your hearing are polluted with banner ads, spam ads, or in virtual reality, you're walking through your virtual world and Krispy Kreme is offering free virtual donuts. How important is that, and how much work is going into setting the ground rules of what is acceptable and how these technologies are going to be rolled out?
And I'd also love to understand I think we probably have different ideas of what it means to be human. I mean that. For me, virtual, the demo was awesome, but anti-gravity, creating boxes out of thin air, as much as that might be a cognitively human, it's starting to become more real in the sense that our senses can be tricked into thinking that is more like humanity. At the end of the day, you're wearing a giant thing on your face that fully takes you out of your reality. And so I'd love to, I think that's a really good question. We were what does it mean to be human in this digital future? And if you are totally removed from reality, is that still a human experience? And then you get to the questions of, are all you avatars anyway, and what does that mean?
No, these are deep questions, and I think that the part that I think is human in this case are the hands and fingers that are being used to control the thing that, to your point, is not, I guess, explicitly a part of our universe. And there are always questions of, obviously one of the things that's attractive about a virtual world is sometimes you get to cheat or break the laws, and sometimes that's the explicit purpose. If it's a game, we're not necessarily sorcerers in real life, but it can feel a lot more immersive and fun to feel like you're a sorcerer with your actual hand, or as an airplane mechanic, perhaps rather than having to actually go about and like assemble all the parts individually as you would maybe if like they can snap towards you a little bit and you can cheat. Is that human or less human? I think that the application has more freedom to be physical and natural, but also at certain, from a design perspective, in certain ways, better than reality in the virtual reality. But I think that the input still has to be human, because I think that that's what makes it so that people can just instantly figure out, I see my hand, I see my fingers, and without having to think about like, oh, what do I do with these fingers, or which is how you approach the technology with a controller. Just having that instantaneous connection, I think that's the part that's human. But certainly, I think that for VR, you're always going to be wearing this headset, and the purpose of VR at its best should be radical immersion, where you're totally disconnected, and that's not the only future of computing. Certainly, I think that that there are places for that, and I think there's a lot of places, but I think there's also a lot of places for totally transparent sunglasses like computers that are all about being present, or even things like ear-based computers where there isn't anything that's a digital display, but perhaps, and not even a world where hands are the only input also, but where things like voice and audio and other things that are all complementary. I think all of those have a role to play too.
Yeah, and I don't know the answer to this either. I spend a lot of time thinking about what does, as people building technology, we are, and most of the people in this room and people in this space, the people at the forefront of defining what this kind of interaction, you keep using interface, but it looks like and how it does tap into our humanity. And I think, we were saying back, you kind of have this Blade Runner future, you have for us this kind of the film Her, where, and that also one thing we didn't touch much on is the idea of kind of the smart assistant, and the idea of this ever-present AI is definitely obviously going to be part of VR and AR. And I think for us, one of the things that's most interesting is if you think about the ear, you can bring an AI with you if you have tech in your ears all the time. And you can actually do it in a way that hopefully does allow you, because you tried the technology. With our technology, you can put the technology in and layer things on top of it. Now, yes, the person you're talking to doesn't know that, so that creates a certain type of barrier, but unlike something like Google Glass, you're able to actually do it in a very seamless way. And in a very culturally sensitive way, right? You're still interacting and talking with the people. And so for us, we think there's really interesting ability to integrate with AIs and make that, I could have a voice literally in my head right now while I'm talking to you, giving me data, maybe giving me information on your background or what Leap Motion's latest thing was, or what the crowd, you have this data flow, but you can still be tuned in. That's the terminology, we use music terminology. Yeah. And how do you bridge that is a lot of what we think about.
And I mean, a lot of this discussion is essentially around how not to be Google Glass.
Sure.
So 4 years on, why are you, or either of your companies or AR/VR not going to be just the latest iteration of Google Glass? Why is it going to work? Is it the rise of these voice assistants that are actually useful? Or why is this time different?
Well, for me, I'll answer from the audio perspective, and then I think there's a fundamental difference between the eyes and the ears. You wear glasses, I don't. To get me to put glasses on is a huge leap. Like, I have to wear a shirt, well, because of societal norms, I have to wear a shirt.
You can take it out.
Hey, night is young. But to get me to wear glasses is a leap, right? But to get me, so many people in tech didn't understand why Apple bought Beats, and I'm not going to claim I know it, but Jimmy Iovine is a genius. He got people to wear 6 pounds of red plastic on their head, spend $399 and turn to their friend and be like, if you're not wearing this, you're not cool. Like, that's huge cultural innovation, and all of a sudden everyone was on the subway. We were talking about New York, rocking Beats. It totally reinvigorated that industry. And so for us, we're really focused on the aesthetics and the social interaction, and we think the ears, again, because of the fact we've worn technology in our ears for so long, and because you can make it less intrusive, and because you can do it in this subtle, elegant way, we think it's a fundamentally different way to enter market than glass. Now, I think AR glasses will come, but again, I think it'll come in these episodic things long before. It'll take a lot for every person in this room to be we're all wearing glasses and they're all enhancing our worlds. 5 to 10 years at minimum, even if Apple, we saw what happened with Watch, even if they go for it, I don't think it's enough.
Yeah, I think that it's a question of value versus the cost, and for regular consumers, I agree that a lot of the cost is about wearing something, and Google Glass had a high social cost, and
a very high social cost.
Very high social cost, and a low value because the display was small and such, and it did a good job at capturing people's imagination and getting people excited about the idea of what could be possible, but it didn't approach that really. But I think that as AR becomes richer and richer, and I think for example, when we talk about human connection and creating more human connection and more humanity, and I think that you can make an argument certainly that if people are sitting next to each other, that they're less connected if they're wearing glasses, and that's maybe where something like awesome magical earbud computers comes into play. But on the other hand, if I can feel like I'm actually present in AR, and we could be on this, I could be standing over, in my office, and I could see someone as if they were actually there, and they could be my friend, and I could see them as a physical reality, even though they are on the other side of the world. If you think about how just growing up with friends in like Bangladesh and Australia and China, even just that simple part of one tiny, tiny, tiny part of what's possible with this technology, the implications that has, I think that there's a lot of value, and I think even if people aren't wearing it 100% of the time immediately, they might put them on when they want to talk to their friend in Bangladesh, for example.
Right. And we're running out of time, but just one last question on privacy. If we've come on leaps and bounds in terms of the technology, what they can do, what they can track, information they can provide, presumably that's what they can do in terms of invasion of privacy is equally high.
Sure.
Do you have any sense of the regulations? Are people looking at this, or how deeply are the companies thinking about, all right, how are we going to address these issues, because they're very real?
Yeah, I can't speak on behalf of the big companies, but I'm sure they are all, a lot of them have gotten caught many times with issues in this space. I know for us, privacy is something we take incredibly seriously. We don't record anything, right? There's a lot of things we could do that we don't, but again, this is as the people creating the technology, there is a responsibility, right? There's a responsibility to ensure that the user base is protected. And I know from our company ethos, that's something, we hired an entire team out of Palantir that basically works on ensuring data is completely secure. But it will be an issue, because AR glasses, you're going to walk through a mall and you're going to get bombarded with, if you walk into Best Buy in the next 60 seconds, you'll get $10. There's going to be this, and how you create those kind of abilities to control what you want and have those privacy protections is going to be essential.
And is it the same issue in VR? Very quickly, sorry, we're running out of time.
Yeah, I think it is an issue, and I think it's less about VR or AR per se, but it's more about the sensors in this case. And for example, everyone who has a Leap is trusting us to have a camera that it is, could in theory be on. And we've taken a lot of efforts to make it so that our data is only being collected at the level of what's useful for hands and fingers, even though it would make it a lot easier for us to just capture all the data all the time. But we're very sensitive to the idea that people don't want a camera looking at them always, and that's one of the things that separates our approach from how other people approach the space. But I think that as we move into the future, people will be, I think right now there's not an awareness necessarily of all the data capture that's happening. I think that that's changing very quickly though. And I think it's going to be a much more pressing concern on the part of everyday people as we move into this next phase of platforms.
Great. We've gone over a bit on time, but thank you very much.
Thank you.
I appreciate it. Thanks, guys.
Fantastic, right? Okay, don't go anywhere. We're quickly wrapping up the day. This is our last presentation of the day, and this is going to be actually really fun. It's been a really eventful day. A lot of fun. We've talked about technology, we've talked about robotics, we've talked about AR, VR. Now we're going to talk about a different kind of a robot that kind of blends between cars and mobility, personal mobility. So our last session is going to look forward in the future. Look forward in mobility, like we just saw in the video. What's it look like for personal mobility? Where do the cars fit in? And including, what about the autonomous cars? What about the electric cars? And who's going to be owning them? Who's going to be renting them? How are they going to be shared? Piaggio Group, the makers of the video we just saw behind, are the makers of the Vespa. And recently, they created a brand new company called Piaggio Fast Forward that's focused on lightweight vehicles like you saw. Their COO, Sasha, is here to talk about the first product, the cargo carrying robot. It fits into the new transportation ecosystem. Now, this robot, she's actually told us, has actually been called the sexiest robot in the United States. So I would actually challenge Collision next time to get a couple of the robots together and have them fight it out for the title. Ahead of that, we also have actually we have a really great group here. Stephen Rosenbusch from Wall Street Journal, who's the editor of CIO Journal, will actually be talking to Sasha, as well as Philip von Hagen. Now, Philip is a member of the executive board of the Porsche Automobile Holding Company. Now, if you guys don't know, that's not just Porsche. That's Porsche and Volkswagen and Audi, and by association, Lamborghini, Bugatti, Ducati, Bentley. You get the idea. So these folks have a lot to talk about with regards to how safety and style fit into next generation vehicles. And we would like to welcome to the stage right now Stephen Rosenbusch, Sasha Hoffman, and Philip von Hagen.
Afternoon. So looking forward to the future isn't always a cheerful exercise. We're going to talk about the future of mobility in the future of the world that we live in. And let's talk a little bit about what that looks like. Philip, you have a lot of ideas on this subject. Can you sort of sketch the problem out for us?
Certainly, Stephen. Mobility is a basic need to all of us, and it is also the foundation for prosperity of a nation. So mobility is very important, but as we all know, when we get up in the morning, I think two things are very much on our minds. One is the weather, and one is traffic. And that already points to a fundamental problem or challenge that we have to address. And that is related to the global population and the population growth, especially in urban centers. Today's population is close to 7 billion. The global population, 7 billion people. By 2050, this population will grow by approximately 1/3 to 9.3 billion people. Now, whilst today just over half of the global population lives in urban areas, this percentage is going to increase to about 2/3 of the global population. That means that close to 2.5 billion people are going to move into urban areas, and you can imagine what strain that puts already on our already strained infrastructure. And that's what we have to address.
That seems like an urgent problem. Sasha, how do you see this, the context for all of these developments in mobility?
So I totally agree with his comments. I mean, I think today all transportation companies are solving a couple of the same similar problems. We're all trying to attack congestion, air pollution. I live in Boston where it takes me 30 minutes to go 2 miles. And so all of us are trying to attack the same set of problems, but from different angles.
Let's talk a little bit about how you attack those problems and how you calculate those angles. I think we've all spent a lot of time over the last day talking about autonomous vehicles and other forms of data-driven mobility. Sasha, why don't you talk to us about some of the lighter weight vehicles and devices that complement that infrastructure?
Yeah, absolutely. So there's a couple different initiatives really happening in the lightweight mobility sector. We ourselves just recently launched a product called JITA. It's a cargo carrying vehicle. And you can think about it as us wanting to enable someone to be able to extend their own human mobility and keep your hands free. But there's a lot of people working on different efforts that are 2- and 3-wheel types of platforms. So bike sharing, there were over 1 million bikes in bike sharing programs last year. That's increasing significantly. Maybe people have seen things like the one-wheel. There are so many advancements being made right now in 1-, 2-, and 3-wheel, lightweight, electric, foldable platforms, things that you can use for last mile commuting. When you end up, if you take the train to work, but getting from the train station to your office, that last bit of distance, there are a lot of people tackling creating solutions for those specific problems.
Philip, how do you see these lighter weight, innovative vehicles and devices working together with more established traditional cars?
Well, we certainly need different kinds of vehicles going forward, and that's going to be enabled and facilitated by what Sasha already referred to, autonomous vehicles, electrification, and the sharing. And so we will have very dedicated vehicles for specific purposes going forward. So the scenery and the landscape we have in today's traffic environment is going to change over the next couple of decades significantly. So we will no longer see the sort of cars that we have on the roads today.
We often like to say right scale for the right task. So vehicles are starting to move into a point where we built our vehicle to be able to say, you don't need to use a car to deliver a pizza or to move one person. Why is it every time that I get something delivered to my house, I'm almost upset when it's a car that did it, because it's adding to the congestion problem. So how do we actually start using the right vehicles that are the right scale for any given task? So when we're talking about moving humans, it can be about public transportation when we're talking very large throughput into a city, but then to get you to that office, it's a different form of transportation that may involve walking or skateboarding or something that hasn't even been invented yet.
So could the two of you walk us through, say, a trip to the grocery store, but it's not around the corner, it's a grocery store across town and I can't walk there? How will these devices work together and how will I be directed?
So that's a little bit about, I guess I'll start into our vision of the future city, because I think that plays into there. So I think you're going to see 4 major constructs really coming up in the future city. One is less ownership, meaning that we really are operating in a sharing economy, whether it's cars, bikes, or anything else. We are utilizing platforms that are shared amongst everyone. The second one is that it's more information sharing. So at the end of the day, if there's not some sort of overarching platform that all of these vehicles and systems are connected into, you're only going to add to the problem, because everyone is only optimizing for their own product instead of efficiency. I think you'll also see multimodal transportation, so this idea of how do you get to the grocery store, which I'll talk about, and then lastly, kind of looking at things that help you move seamlessly and efficiently in the most transparent way. So maybe that ends up being an app that is connected to all of these systems, and it tells you, you're going to drive your car to point X, and then from there you're going to walk, and then there's another form of transportation that you can share to get you that last way. And maybe that's actually a 10-mile trip. You're using 3 forms of transportation, but that's in fact the most efficient way to get there. And maybe you use a Jita or something else to actually carry all of your groceries home.
Philip, how do you see the car integrating with these other options? And in fact, you've experimented with them in some interesting ways.
Yeah, certainly. I mean, the car is going to play an important role for the foreseeable future going forward. It's just going to change in the way the car is going to be designed, configured, and for the dedicated purposes it's put to use. Now, to take your example with the grocery store, perhaps I'm not going to go to the grocery store, but they actually, the groceries are being delivered to my house, so I don't need to even leave my home in order to do that, and might even be delivered by a drone. In order to answer this question, I'd like to step back a little bit and consider different city scenarios which we see emerging. And we've developed or defined 3 different clusters, and in each cluster you will probably find a different answer to this question. The 3 clusters that we see emerging and already exist largely today are, one is efficient collectivism. Those are cities that are highly regulated, standardized, and scaled mobility systems designed for efficient use. You find that largely in Asia, such as cities like Guangzhou. other areas, like here in the United States or in the Bay Area and in other parts of the world, you have effective individuals really defining mobility needs. It's a liberal system with a very diverse culture, and everything is optimized and geared towards individual effectiveness and comfort. And then thirdly, you have a group of cities that are really characterized by what we call overburdened sprawl. Those are cities that are very diverse, very unorganized, very chaotic in some places, and dependent on a DIY culture. Cities such as Lagos, for instance. And in each of those, you will have a different answer on how to solve those problems. Now, the simplest answer to your question of the grocery problem in, for instance, the efficient collectivism is that you're not allowed to travel halfway across town just to get a piece of meat. That will be forbidden because it's not good for the greater good of the city. It's got to be done differently. You will have to source it locally, or it will be heavily taxed.
Sasha, can you see these three different kinds of cities emerging, and who's really ahead of the curve and who's behind the curve right now?
Yeah, definitely. So at a core, I think everyone is trying to make cities more movable as a whole. And especially, we ourselves believe really in this vision of wanting to make people move more. We don't, right now in cities, I would say that sort of the romance of many cities is totally dead. They're devoid of life in a lot of ways. But you're seeing cities around the world trying to make an effort to really make people move more and do that in an efficient, seamless way. So Sheikh Mohammed of Dubai has said that by 2030 they want 25% of their rides to be autonomous. Singapore has put a ton of money into both robotics and smart transportation. They'd at some point like to get to a fleet of 300,000 autonomous cars to be able to service their population. In the United States, in Virginia and Idaho and California, they're starting to pass regulation around autonomous both vehicles as well as robots on the road being able to do deliveries. So you're slowly starting to see advancements being made, although I would say that in a lot of international cities, they're happening faster than they are here in many ways.
They're not just international cities. Would it be fair to say that in many cases they're more autocratic systems?
Definitely. So, I mean, yes, there is a king in Dubai. There's a president in Singapore who pretty much can say, I want to invest X billion dollars, and it's going to get done. And you're seeing the fruits of a lot of that. There's an autonomous car company from Boston, Autonomy. They did all of their original testing in Singapore. We'd love to be able to get to a point where, us in Boston, we'd be able to say we are a first mover now instead of following often many of the trends that are happening.
But even then, when we see what is happening in places such as Singapore, it will put a lot of pressure on the cities in our part of the world here to also make change happen and realize changes and change the system on how decisions are being made so that we can also benefit from those advances.
So how do we catch up, or how do we move forward in a system in which, ideally, there isn't an autocrat in place, and as you pointed out earlier, it's all about the individual?
Well, the answer is not to change the political system.
Okay, good.
No, but what we have to do is, as I said, we have to learn. We have to learn from best practice that we can see elsewhere. We have to certainly try to change within especially in the cities, the way decisions are being made. And technology is also going to play a role. We heard a lot about technology today. Technology is going to facilitate advances that previously were very costly to implement. And so you can execute some of the changes a lot faster than in the past.
I think it's really important, too, for companies to be very proactive in talking to cities. I mean, we've gone and done that. I think it's so important before you go and just release a product, have a conversation and learn about what a city's problems are. It's often you'll go in there and you'll think, oh, well, I'm helping solve X problem. But there's also 10 other dependencies that are as part of this mix. And as a city, you need to actually think about those and everybody else that's impacted. So in order to kind of get to this futuristic city, we need to have academics, regulators, businesses all really talking together and doing a lot more sort of rapid fire testing, creating zones that are meant to do this, and to actually have set goals and saying, if you can meet these goals, can we actually then create concrete implementation and do it in a much faster way. I mean, we're not getting anywhere if the testing period takes a year for us to even formulate an idea, another year to test it. I mean, by this slow crawl pace, everybody else is going to be faster than us.
The New York Times had a story the other day that went inside the New York City subway system and found switching and signaling equipment from the 1930s. No joke. And it will be maybe 25 years before the entire system is computerized. So the reality is that the infrastructure, at least in the US, is nowhere near ready to facilitate any of these changes, is it?
So you're highlighting something that's important, which is infrastructure costs, right, as a whole. And we're talking about advancements being made in public transportation, autonomous vehicles, other types of shared platforms. That all takes a strain on the system, right? But yet at the same time, what we're trying to do is avoid all of these costs on the existing system. But you have to sort of put money in to see any fruits come out as well. And it's about putting that money in the proper way to the right systems. Public transportation's never going away. People talk a lot about how autonomous cars are going to solve all of our problems, but the truth is public transport, especially in the cities where people rely on it, it really can't be substituted. The throughput of the amount of people who go through public transport is not going to happen through autonomous cars.
Sorry, Stephen, even if the signaling is not modernized within the next 20 years, the system is working to capacity, I guess. And it's always designed to peak capacity. That's a challenge. You can actually, even today, generate the data that you need to actually optimize the system and make it work better and incentivize people to utilize the system in a more efficient way. And you don't need to upgrade the signals necessarily within the next 5 years rather than next 25 years in order to actually optimize the existing infrastructure.
I wonder if there's a new also revenue model to be made of all of this transportation. If we're moving into a world where it's a completely shareable platform, and let's say some of these are actually owned by the city, so in many cities where they have shared bike platforms, it's run by the city. What happens if we're now, instead of paying just for my subway ticket, I'm actually paying more per month, but it allows me to access different things, and you're able to take that revenue and use it to improve all of these systems. So I think there's a point at which we start to look at how do we create new revenue models where you're having, citizens paying into a system to get something that's much more efficient, but at the end of the day, it benefits all of us as well.
Phil, from your perspective, overseeing a global company, if the answer isn't changing the political system, is it, what is the answer? Does it lie more in changing the regulatory environment?
Yeah, certainly I think it is, as Sasha already made a reference to, it is companies, large companies and entrepreneurs lobbying the system and demonstrating the benefits of advances and changes, what impact they may have on the system, and working collaboratively with regulators, legislators to advance and facilitate changes to be made. It's certainly a very intense process, often a very slow process, but it's inevitable that we engage, that we have that dialogue, and promote the benefits of making changes to the system.
I'm not sure if the answer is at a federal level or a state level, but I do know that going city by city is also very cumbersome, or even town by town for that matter, for any given company. It is a lot of work, and it's true to say, though, that for any given city around the world or town, the effects are going to be different. But if you have to go city by city, it takes a lot harder to implement all of this as well.
And is that the way things are working now in the US and in Europe?
It is,
yes. All the regulations done individually.
I mean, the challenge, if you look at a city like Berlin, you have European legislation, you have national legislation, you have city legislation, as well as district regulations, and then parking, traffic, and other aspects of the public infrastructure that you use for mobility are also dealt with through different departments. So this is enormously complex, and unless also cities move towards simplifying that, such as, for instance, London. Transport for London is a very good example of an organization that tries to take this holistic perspective on mobility. And unless you do that, it will be extremely difficult to achieve progress.
Where are public attitudes right now? If the infrastructure and the regulatory system and in the political system in many cases is an impediment, is is public sentiment working in your favor?
Public sentiment in many ways, it's good and bad, right? It's important to create an efficient system, but at the same time, when you're introducing a lot of these products, they're brand new, right? And let's be honest, they often have a lot of kinks. I've interacted with a lot of these new, whether they're robots or they're vehicles, and a lot of times public perception, it really does matter. We live in a society that's a democracy. We care a lot about what people think, which is why so many things often start with small scale pilots, and people look at the reaction and the impact that it's actually having. Sometimes it takes a little while to get through those kinks, and that can be a problem because you'll kill something before it ever even had a chance to develop. And that happens as well.
We are driven by habits. And getting people to change the way they consume and use mobility is a challenge. You can motivate people, you can perhaps even incentivize them. That's often done through for instance, in the case of transportation, you can do it through a tax system. But it is habits that you need to overcome. For Americans here, it is inconceivable why Germans still want to do manual gear shifts in their cars. I think they disappeared largely in the United States a long, long time ago, but Germans seem to like that. And so we need to deal with habits and not necessarily just through a very convincing product. You need to nudge people a little bit.
Are people coming around to the idea of sharing vehicles?
Very much so. Sharing is going to become much more easy, and you see a lot of car sharing, for instance, in Berlin. It's probably car sharing capital of Europe, I dare say. Especially in very dense environments, urban environments, car sharing is a very attractive solution, and people often don't want to own a car anymore and want to share it. Or vice versa, they have a car and they also want to earn money by renting it out to others, as we heard earlier from Getaround, for instance.
Last question. 3 years from now, how much do you think we'll see a tremendous amount of change, a little bit of change, or no change? Sasha, we'll start with you.
So when it comes to autonomous systems, I think that you're going to start to see the sort of good effects of autonomous vehicles and that technology being used in a lot of different ways. So like autonomous trucking, for instance, I think will become much more prevalent. Uber just recently did one of their first freight trips that was completed successfully. You'll also start to see it, I think, to use more for like safety things. So if I'm on the road and I'm swerving, or if you have a drunk driver, maybe the car actually notices that pattern and it's intelligent enough to actually take over. So I think that you'll start to see it used in more safety type of capacities. I think you'll also see many more cities actually having testing zones. I know for a fact now that there's multiple cities working on pedestrian-only zones. So I think that within a couple of years, you'll start to see the groundwork for a lot of areas that are meant to have really just walkable areas, but like no cars allowed. And I also think that you're going to start to see significantly more robotic vehicles on the road, whether autonomous or following humans, being used for everything from delivery to carrying cargoes and other just general autonomous systems being used.
Yeah. Philip, you add or subtract anything?
Well, in the short term, in the next 3 years, we will see a lot of data-enabled improvements in city traffic. So that relates to traffic itself, making it perhaps more efficient, optimizing traffic and traffic flows, and also, of course, understanding traffic better. And other models, such as in car sharing that we refer to, those are the models that we will see a lot more of. Parking-related solutions, that is the advances that we will see in the short term, because they're low-hanging fruit, they're easy to implement, you don't need the regulator to do very much to facilitate that. And
I also think 3 years from now, you'll see a ton of platforms that you have not seen today. I mean, we've started alluding to flying cars and drones doing delivery. I think there's 20 new systems that haven't even been developed yet that 3 years from now will exist.
I think we'll have to leave it there. Thank you so much.
Thank you,
Stephen.
Thank you.
Thank you for joining us today. That wraps up a fun-filled day of robotics, technology, AR, VR, and the future. Tomorrow at 10:35, this will turn into the music notes stage. So come back and enjoy that. You guys enjoy the Big Easy. Have a good time.